Hi everyone, very good morning and welcome to the ML Hub's Gate DM Mock Test 2 Complete and Detailed Solutions. So this is going to be a live session and you can ask your doubts in the chat for every question. I will be solving each and every of the 65 questions that were asked in GDMT-2. GDMT-2 was conducted yesterday, which is Sunday at 2:30 p.m. and a lot of students actually participated in it. It was an advanced level test and we will be releasing the results also very soon. In this lecture, firstly we will discuss the solution to all the problems, and by the end of this video we will be releasing the results as well. Okay, so what's more important? Not focusing on results. Okay, like for at least for all the full length tests that you have in the test series. Okay, you have 10 tests, like full length tests in the test series, grand test 1 to grand test 10. What do you have to do? Attempt all of these full length tests in the exact same timing of the gate exam. Okay, so this is one of the pro tips, so which I want to give you here. Try to do this. Attempt all full length tests or full length or grand tests which are there in the exact exam slot. This will help you build your muscle memory, like your brain will work better in that particular time frame, 2:30 to 5:30 p.m. You are training your brain to work efficiently in that particular time frame. Okay, so if that is your time, that is the time when you usually sleep. You should avoid that because the actual exam is going to happen. Gate D exam is going to happen on 15th of Feb at 2:30 p.m. right? That's the slot. Every student has to write it at that slot. So try to write all the full length tests in that exam slot. And GDMT2 also happened yesterday on the same slot. And in this session, we will be discussing the solution to all the problems. Okay, so write in the chat if I'm audible, visible, everything is working fine, and if you have attempted the test, so that we can solve the questions together. Okay, so write in the chat if you have already attempted the test, and even if you have not attempted the test, that's okay. You can watch the video and solve the questions now with us. Okay, cool. When will the results come? You attempted, that's great. So if you have attempted, like, please watch the video till the end. Let me know also what you thought was the answer to the question, and we can discuss more. If you don't agree with the answer, let me know in the chat, we can fix it. Okay, when will the result come? By the end of this video we will release the results as well, like your rank, your percentile, and detailed solution on the platform as well. Okay, so let us start. Before start, I would want to announce the toppers of this test, the toppers of GDMT2. So these are the top 10 students. Congratulations to you if you are in this list. Actually, at the end of the day, it doesn't matter. Like, GDMT2 is not the final. Like, you will not be getting a seat based on this rank, right? But yeah, you should feel motivated if you are in this list. Even if you're not, if you have attempted the test, you have cleared at least one of your fears of the exam. And we will have one more GDMT coming. So GDMT3 is going to happen on February 1st. More details we will let you know at the end of this lecture. So these are the toppers of GDMT2, the top 10 students. Okay, and we will release, if you're not in this list, we will release the results at the end, by the end of this session. Okay, for everyone. So these are the top 10 students. Okay, congratulations to you. So let's move forward to the solutions now. So firstly, we will start with aptitude questions. Aptitude is a separate section actually. Like, even in GATE exam, you will find it. So you will find all the aptitude questions in a separate section. Okay, like in the platform, like when you're attempting the exam, even for GATE CS or GATE DA, you will see aptitude and then technical. They are in different sections. In technical, you cannot bifurcate based on subjects. You cannot do that. Okay, all the questions will be shuffled. Even in aptitude, questions will be shuffled. But if you want, whenever you're like, see, every student has their own technique to attempt the GATE exam. Some students try to finish aptitude questions first. What I used to do was I used to start with the technical section, and whenever in the technical section I used to feel bored or like facing any difficulties, I used to switch to aptitude section for a little while, because that makes you feel better. Like if your aptitude is better, if your aptitude is not good, then you can like do it at the end or the beginning, like based on like you can try different things in the full length test. Whatever works for you, you can apply the same strategy in the exam as well. Okay, but yeah, aptitude and technical will be two different sections in the actual exam as well. Like the portal that we give you in the test series is exactly what you will get in the GATE exam. Okay, we have replicated it completely. So exact same will be there in the GATE exam as well. Also one more note, some of you are writing like thoda tough laga paper tough banaya humne. It was an advanced level test, right? Like there are 3 GDMTs. This was the advanced level, so it was deliberately difficult. And I have written this note yesterday in Discord server as well. Don't focus on the marks, okay, for especially for this paper, because the paper was slightly on difficult side. It was deliberately made that way so as to expose you in different types of scenarios, like what can happen, like if completely difficult paper comes in exam, how to handle it. Okay, you should know that as well. And if it is difficult for you, it is difficult for everyone. Generally, like in this paper, the median and mean score was really low as compared to GDMT1. So that is okay, but what is more important, now you should know the solution to each and every 65 questions, okay, because at least a few questions will come directly in exam as it is from GDMT 1, 2 or 3, okay. I'll tell you, like once the GATE 2026 paper happens, after that we can discuss it, and in another live video we will discuss that how similar questions come, okay. So questions will be really similar and you should know the solution to all the questions. लेंदी था लास्ट ईयर का गेट का पेपर भी लेंदी था. इफ यू नो, लाइक इफ यू रिमेंबर, गेट डी 2025 was slightly lengthy than 2024. It might happen in 2026. It might be even more lengthy. It might be easier. Anything can happen. So yeah, be prepared for that. Cool. So let's start with aptitude questions. This is question number 1 from aptitude, 1 mark question. Let x be a 40-digit positive integer whose first digit is 5 and the second digit is a, where a lies between 0 and 9. So second digit is a. This information is useless, right? It is a 40-digit positive integer. That's what they are saying. And they are saying like first digit is 5 and there are 39 more digits. So this is the first digit, this is the second digit, this is the third digit, and so on. This is the 40th digit. Okay, it is a 40-digit positive integer. First digit is 5 and second digit is between 0 and 9. Actually, we know that for any positive integer, the second, third, fourth, all the digits will be between 0 and 9. So this information is given, but it is useless. Okay, so you can have any possible digits in the basically at second, third, fourth or 40th position. The question is, how many digits will x cube have? This is x. Now the remaining digits can be anything. So what is the smallest possible number? The smallest possible number here is 5 and all zeros. And the largest possible number will be 5 and 9999999. This is the largest possible number. If you take cube of both of them, you will know that what will x cube lie in, right? So x cube will definitely lie between s cube and l cube, because x lies between s and l. We know that x lies between s and l, and hence x cube must lie between x cube and l cube because they are positive integers. I can take cube. Now what is s cube? S cube will be 5 cube is 125. So 125 into 10 to the power. So this is 10 to the power 39. So 39. So like you can write it this way as well. Like let me write it. So S is what? S is 5 into 10 to the power 40. Okay, 5 into 10 to the power 39. Sorry, because there are 39 zeros after it. And this L is what? 5.99999 into 10 to the power 39, which is approximately 6 into 10 to the power 39. I can take one integer, like I can take L plus 1 also, that is also fine, right? So which means L plus 1 will be 6 into 10 to the power 39. And hence we can say that S cube will be 125 into 10 to the power 39 into 3. 39 into 3 will be 117. And you can say that, see here that L plus 1 cube will be 6 cube, which is 216 into 10 to the power 117. So this number also has 120 digits. If you see 125 and then 117 zeros. So this number also has 120 digits. This number also has 120 digits, and hence no matter what x is, x cube will always have 120 digits. Any doubts? X cube will always have 120 digits because the smallest possible number also, its cube also has 120 digits, and the largest possible number cube also has 120 digits. Okay, so the answer is 120 here. Okay, simple question. Let's move to the next one. Keep writing in the chat if you want me to explain something again. Okay. Find the odd word from this list: orange, mandarins, grapefruit, pear. So these are all citrus fruits. They khatte fruits hain, right? Orange, mandarin, they are same thing. Okay. And grapefruit, they are all citrus fruits, but pear is not, right? Pear is not a citrus fruit. So, and hence the answer here is pear. Any doubt? So sometimes question like this might also come, like it's like generally questions like this always come like based on like odd one out of the 4 words, which one is odd one out. So sometimes they are related to word meaning, sometimes they are not, sometimes they are related to fruits and vegetables like this. Okay, any doubts? Let's move to the next problem then. Cool. Question number 3, which sentence here is grammatically correct? First is Sheila goes out to buy vegetables. This is correct. Okay, Sheila goes out to buy vegetables. This is grammatically completely correct. See, I'm not an expert in English as well, but yeah, like you can like sometimes just read out the statements whenever grammatically correct is asking. The question is asking about grammatically correct or not. Most of the times when you just read out the statements, you will know like something is missing or something is off. Okay, so to check grammar, the best thing is to just read out all the statements. So Sheila goes out to buy vegetables sounds correct. The sparrow is sit on the roof. It is not correct, right? You should be sitting on the roof. So option B is incorrect. Heavy rains lashed West Bengal yesterday. Okay, so this is a very important statement. This might look correct, but you don't write heavy rains. Rain is already plural. Okay, like the plural form of rain is rain only. So heavy rains becomes incorrect, and hence option C is incorrect. Where is my books? Books is plural, so you cannot use is with books. You have to use are. Where are my books? So option D is incorrect as well. So only correct option here is option A. Pretty easy question again. Okay, if you just read out, you will find out which of the statement is correct. Any doubts? Okay, let's move to the next problem. Okay, find out which of the figures 1, 2, 3, 4. So this figure type of question, okay, this visual interpretation question. These are called visual interpretation. At least one question is coming from the last few years I am seeing in gate CS also, in gate D also. So be prepared for this. Generally one questions for any gate stream is coming from visual interpretation as well. Like you have to like visualize what is going to happen. Sometimes a question comes on dice. What if you cut open a dice and which particular pattern will be formed? So it's like it requires some logical thinking, like what will happen. Just try to visualize what is going to happen. This is a easier question than that. You don't have to cut and open something. Here you just have to find out like what figure you can make using the pieces given here. Okay, and again a similar question actually came in gate 2025 as well. That's why I am adding them in GDMTs as well, so as to prepare you. What do you think? How will you make 2 here? How will you make 2 here? You cannot make 2 here. Try to do that. So the only figure which you can actually make is 1 actually. Like if you like, I'll try to make 1. So you can make 1 very easily. So if you just take the square, like if I call them something like A, B and C. So you just place the B square here. Then you place the A triangle here, the smaller triangle. And then you place the bigger triangle in such a way that the longer side is like this. This is the longer side. This is the longer side. And the remaining 2 sides are equal. So this is the longer side and the remaining two sides are equal. So this is the triangle C. Then you can actually make figure 1. This is the figure 1. This is the figure 1. But no matter what you do, you can never make, I think, figure number 2, 3 or 4. Think about it. Can you show me some way in which you can make figure 2, 3 or 4? Shivram, we will release the results towards the end of this video, like once we discuss all the questions. Otherwise, you will not be interested in seeing the solutions. I want you to see the solutions, okay? So we will hold the results until then. Okay, so any doubts? I think only figure 1 can be made. This is how you can make figure 1 using A, B and C, but you cannot make figure 2. How will you? Because you need, you have a square. Let's say this is the square. Then where will you get the other square? So this is not possible. Here also you need a rectangle, like if you see in some way, and there are two triangles. So you will not be able to make this also. And here also, here like this is not even possible, right? Like, so only possible option is option 1. It was an easier question. The question is not saying can we use multiple pieces. If you use multiple pieces, probably you can make all, right? The question makes sense only if you can use these pieces exactly once, and only one option makes sense then. Okay, so you have to sometimes assume these things on your own in exam. This question is not incorrect. Okay, it has not mentioned that you cannot use multiple pieces, like the question, like but you have to infer this. Otherwise you can make everything, right? Like in some way you can overlap and so on. Okay, cool. Moving on to the next problem, passage based question. In passage based questions, I told you, generally speaking, whatever the question is asking is generally not the summary of the entire passage. Most of the times I have seen this, which means if you are lucky, you don't need to read the entire passage, but it is recommended to read the entire passage. Obviously I will not be doing it here in this video. You can read it on your own time. But what question is asking, based on this passage, the question was asking is the inscriptions found in Tonuru are of which script? And it was mentioned in the second paragraph, if you read it carefully, that the inscriptions found are in Grantha script. The only script mentioned here in this entire passage was Grantha script, and it was a very easy question. Okay, so if you just find out like what is mentioned in the passage, that's enough in most of the cases. So the answer is Grantha script, option B. Okay, let's move to the next question. Two trains T1 and T2 start at the same time from the same station and move in the same direction. Speed of T1 increases uniformly from 40 km per hour at start to 60 km per hour at the end of the 2 hours, and then become constant. And then it becomes constant. I have added this line in the actual exam. This line was there, but here it is not. But I added this line. Okay, and then the speed becomes constant. So this was the question which was appeared in front of you. You can check it again later. So okay, so this is about the speed. This was about the train T1. About train T2, speed of T2 is constant at 50 km per hour. After how many hours will the distance between the two trains become 10 km from the first time? For the first time, so the distance between the two trains has to become 10 kilometers. That's what they want. So what are they saying? The question is saying that two trains T1 and T2 start from the same point at the same time. Okay, now what will happen? They are moving in the same direction. They are both moving in the same direction. Speed of T1 increases uniformly. It starts with 40, and after 2 hours, let's say after 2 hours, T1 is here. After 2 hours, at 2 hours time, T1 is here. At this particular time, the speed of T1 will become 60 km per hour, and then it will remain constant. It will remain at 60 only. And speed of T2 is constant at 50 km per hour. T2 is constant at 50 km per hour throughout the entire journey. So first thing, like the first way in which you can solve the problem is you can find the acceleration. Like let us try to firstly find out after 2 hours where will T1 be and where will T2 be after 2 hours, let us say. So for T2 it is easy. For T2 you can say that after 2 hours T2 will be at 100 kilometers. T2 would have traveled 100 kilometers. Correct? But after 2 hours, what about T1? First, like the first way or the hard way to solve it is like you can find the acceleration because time is given, so you can find the acceleration and then using that you can solve it. But since acceleration is constant, you can say here that the average speed in these 2 hours, the average speed in these 2 hours for train T2 will be the average of 40 and 60, which is 50 only. So the average speed of T1 in these 2 hours will be 50 also. So T1 will also cover 100 kilometers in the first 2 hours. In the first 2 hours, T1 will also cover 100 kilometers, T2 will also cover 100 kilometers. So they are exactly at the same point after 2 hours. Now the actual question starts. Now T1 is traveling at 60 and T2 is traveling at 50. So there is a speed gap of the relative speed. The speed gap is 10 km per hour. And hence that the relative distance, the distance between two trains, we want the distance between these two trains to become 10 kilometers, right? 10 kilometers is the distance gap I want. So after some time, what will happen? After some time, let's say after how much time will this distance be 10 kilometers? It is very easy because the relative speed is 10 km per hour. After 1 hour, T1 will be 10 kilometers ahead of T2. So after 1 hour, let's say T1 will be here, T2 will be here, and the gap will be 10 kilometers. So overall time will be what? 2 hours still here and 1 hour again later. So overall time from beginning at which this event happens is 2 hours plus 1 hour, which is 3 hours. 2 hours plus 1 hour. So after 3 hours, T1 will be 10 kilometers ahead of T2. Any doubts? Easy question. Okay, again, like it becomes easy if you don't go into acceleration and all. Just use your brain and see that the speed increases uniformly from 40 to 60 and then becomes constant, which means that you can find the average speed in that duration and then use it to solve the question. Okay. Moving on to the next question. Look at the series 3, 4, 7, 12, 19, 28, 39, 52. What number should come next? So here, like these type of questions, just you can solve using observation. That's all. Like try different things. What is happening here? See, if you see it in the first go, there's no linear pattern, right? If you try to solve it using 1, 2, 3, 4, there is no linear pattern. It looks like the numbers are increasing quadratically. Like the initial gap is like, if you see the gap between the numbers, this gap is 1, this gap is 3, this gap is 5. Okay, this is also an easier way to solve it, right? The gap is actually increasing. And whenever the gap is increasing linearly, the numbers themselves actually are following quadratic pattern. Okay, you can remember that way. So you can solve it using the gap or using quadratic pattern. So the gap between 7 and 4 is 3, then 5, then 7, then 9, then 11, then 13. So the next number will be 52 plus 15, which is 67. Okay. And the other way is, if you can find the quadratic pattern, 3 is what? 3 is 0 square plus 3. 4 is what? 1 square plus 3. 7 is what? 2 square plus 3. Similarly, 12 is what? Whenever the gap is increasing linearly in an arithmetic progression, the number themselves will always be increasing in quadratic. Right? We know this thing, okay? So 12 is what? 3 square plus 3. And then so on. 19 is 4 square plus 3. So this is another way of solving it. So 4 square, 5 square, 6 square, 7 square, and hence the next number will be 8 square plus 3, which is 64 plus 3, which is 67. Okay, so this is another way of solving it. So you can solve it in any way. The question is quite simple. Okay, the correct answer is option B. Okay, let's move to the next problem. A trader buys some articles at a rate of 8 articles for rupees 6. A trader buys some articles at the rate of 8 articles for rupees 6. So per article price is what? This is the cost price. Cost price for a single item. For a single item, what is the cost price? Cost price is the price at which you buy an item. So you are buying 8 articles for 6 rupees, which means for one article you have to give 6 by 8 rupees. So the cost price is 6 by 8, which is also 3 by 4. You can use any of these. Now he sells 3/5 of the articles. He sells 3/5 of these articles at a rate of 6 articles for rupees 9 and the remaining articles at a rate of 4 articles for rupees 3, which means whatever total number of articles he bought, he is selling 3/5 of these articles at a price and 2/5 of these articles at some other price, which means essentially 60% of these articles are going in some other price, 40% of the articles are going in some other price, are selling in some other price. The selling price of 60% of these articles is what? 6 articles for rupees 9, which means 9 by 6 rupees for one article, which is also 3 by 2. And the selling price of the remaining articles is 4 articles for rupees 3, which means the selling price here is 3 by 4 for one article, 3 by 4, okay? And hence, what is the average price at which you are selling? The weighted average. If you have to calculate for one article, how will you calculate it? It will be the weighted average, right? Because 60% are selling at this, 40% are selling at this, and hence overall average price for a single article will be what? So overall selling price, you can say, for a single article is 60% or 3 by 5 into 3 by 2 plus 2 by 5 into 3 by 4, which is, if you take denominator as 10, it will become 9 plus 3, which is 12 by 10, okay, which is 6 by 5, and hence the selling price for a single article is 6 by 5 and the cost price for a single item is 3 by 4. Now you just have to calculate overall gain percentage. So what is the amount gained? So the gain percentage is what? The gain upon the cost price into 100%. This is how calculate the gain, right? Profit. So gain is what? The difference in the selling price and the cost price, which means 6 by 5. 6 by 5 minus 3 by 4 upon 3 by 4 into 100%. So what will this value be? So this will be 4 and 5, 9 by 20 into 4 by 3 into 100%. So 3 3s are 9, 4 5s are 20, and then 5 2, which is 60%. So overall profit percent is 60%. Overall, you have had a profit of 60%. Okay, option C is correct. So sometimes, like, you have to be patient because the calculation might be like this in fractions. So be patient, but yeah, at the end of the day, you will get the answer. Okay. And generally in questions like these, after doing some calculations, if the options match, you will be very confident that you have done it correct, right? Okay, moving on to the next problem. A man standing at a point A observes the top of a tower T. A man standing at a point A observes the top of a tower T. At A, the angle of elevation is such that tan theta 1 is 3 by 4. He walks 7 units straight towards the tower to reach the point P. At P, the angle of elevation becomes such that tan theta 2 is 4 by 3. Find the distance between the base of the tower and the point P, BP. Okay. So how will we solve this? At point A, this is point A. You are observing the top of a tower T. This is the tower T. This is the tower T. And you are observing the top of the tower. And the angle of elevation is like this, theta 1. So it is given that tan theta 1 is 3 by 4. And tan theta is what? Base upon perpendicular. Sorry, perpendicular upon base, right? Which means the tan theta 1 will be, let's say this is distance is x. Is it given? No, it is not given, right? So the length of the tower is not given, okay. And AP is also not given, AT is also not given, okay, that is fine. So let's call this as y. This entire distance is y. So tan theta 1 is nothing but x upon y. It is nothing but x upon y. Now what he does, now he walks 7 units straight towards the tower to reach a point P, 7 units. So he travels 7 units. Okay. So he travels to a point P and this distance is 7, which means this distance becomes y minus 7. He travels 7 units, which means this distance is y minus 7. And at this particular point, he again notices the top of the tower, and the angle now is theta 2. And they are saying that tan of theta 2 is given as 4 by 3. And tan theta here is again perpendicular upon base, which is x upon y minus 7. Now find the distance between the base of the tower and point P, which means you have to find y minus 7. Y minus 7 is something that you have to find. Okay, you can just find x and y. There are two equations and two unknowns. Okay, so from the first equation you will have 4x is equal to 3y. Okay, and from the second equation you will have 4y minus 28 is equal to 3x. We are GATE DA students. We know how to solve system of linear equations, right? We can actually do it in 10 different ways. But you don't need to apply those here. You can just do it like using the easiest one. Okay, so the second equation is 4y minus 28 is equal to 3x. Okay, so x is what? X is 3y by 4. So you can say that 4y minus 28 is 3 times 3y by 4, which means 16y minus 28 into 4 is equal to 9y, which means 7y is 28 into 4, which means y is 16. Y is 16. And what do we want to find? We don't want to find y. We want to find y minus 7. So y minus 7, which is pt. Pt is what we want to find, which is y minus 7. That will become 9. And hence the answer is 9 units. Okay. I might have solved it using a difficult way, but yeah, you all know different ways, right, to solve it. Okay, shall we move to the next problem? Okay, let's see the next problem. This is a good problem. This is the best aptitude problem that we had in the paper. A shopkeeper has 3 different sized containers with capacities 4 liter, 9 liter and 11 liters. Every day he receives n liters of milk, where n is a positive integer. So he essentially is receiving n liters of milk. And he has 3 containers. He has 3 containers, 4, 9 and 11. 4 liter, 9 liter and 11 liter container. Now for each container size he fills as many full containers as possible and notes the leftover milk. Leftover milk is important. So only leftover milk is important. He calls a day's amount special if the 3 remainders, the 3 leftover milks, which means the 3 remainders n mod 4, n mod 9 and n mod 11 are all different. They all should be different, which means pairwise distinct, which means n mod 4, n mod 9 and n mod 11 all must be different. That's all. Like this is the important statement. The shopkeeper and milk, and they are all like useless. Okay, the important statement is, what do we want? We want, this is n, so we want n mod 4, which is the remainder, should not be equal to n mod 9 and it also should not be equal to n mod 11. All 3 must not be equal. So what is the question? How many values of n satisfy this condition for n being between 1 and 792? So it is actually a counting question now. What we have to find? We have to find how many such values of n will satisfy this constraint such that n is between 1 and 792. 792, right? Yes. So how many you were able to solve the question? Write in the chat. Okay, anyway, it's okay if you are not, like I'll tell you the solution now. So let's see. let us start with n, like if n is 1, let us see the, if n is 1, what will be the value of n mod 4, n mod 9 and n mod 11? Mod is the remainder. So firstly, let us do it for n equal to 1. For 1, it will be 1, 1, 1. For 2, it will be 2, 2, 2. For 3, the remainder will be 3, 3, 3. For 4, the remainder will be, for 4, the remainder will be 4, remainder 4 will be 0. And then for these two, it will be 4, 4 only. Okay. And similarly for 5, 6, 7, 8, 9, it will be like 0. So n mod 4 will keep on repeating 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, like this. Right. N mod 9 will keep on repeating like this 1, 2, 3, 4, 5, 6, 7, 8, then 0, 1, 2, 3, and so on. Right. It will keep on repeating like that. And n mod 11, like, and you can add 0 also. For 0, it will be 0, 0, 0. I know that 0 is not allowed. They have not asked about 0. But for 0, anyway, the remainder are equal and it will not be counted. So let us add 0 also. It doesn't matter, because for 0, the remainder will be all zeros and it will not satisfy the condition. If you want, you can add 0 also. So 0, 1, 2, 3, 4, then 5, 6, 7, 8, 9, 10. Then again, it will repeat 0, 1, 2, like that. So how many of these values? So you have to keep on doing this until 792. You have to keep on doing this until 792. And if you see that here 792 is actually divisible by 4, 9 and 11, you can check that. So what is the LCM? Or let's forget about LCM. If you just multiply 4 and 9 and 11. So you will get 36 into 11. 396. And so 396 is the product of these three. So 396 is divisible by all three of them. And 396 into 2 is 792. 396 into 2 is 792. And hence 792 is also divisible by all three of them. So at 792, the entire cycle will again reset. And again, all the three remainders will become 0, 0, 0. All the three remainders will again become 0, 0, 0. And again, actually the cycle will reset at 396 only. 396 is the first time the cycle will reset. At 396, it will again become 0, 0, 0. At 0, it is 0, 0, 0. And at 396, again it is 0, 0, 0. And what is going on in between? If you see carefully, it is all possible triplets. Like n modulo 4 is taking values from 0, 1, 2, 3, 0, 1, 2, 3, and so on. N modulo 9 is taking values from 0 to 8, then 0 to 8, and so on. And n modulo 11 is taking values from 0 to 10, 0 to 10, and so on. So what is going on here? The remainders, if you look carefully, the remainders are nothing like n modulo 4 values are coming from here, this pool 0, 1, 2, 3. N modulo 9 values are coming from this pool 0, 1, 2, 3, 4, 5, 6, 7, 8. And n modulo 11 values are coming from this pool. And you have to take every possible triplet. If you just make the first triplet 0, 0, 0, it will be here. Then you make the second triplet 0, 0, 1, it will be somewhere here. Then 0, 0, 2, it will be somewhere here. Essentially, and 1, 1, 1 is also here, right? So every possible triplet will lie somewhere here. So the next is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And how many such triplets will be there? If you pick one element from here, one element from here, and one element from here, the number of triplets will be 4 into 9 into 11, which is 396. So from 0 to 395, from 0 to 395, you will get all possible such triplets. And then again, same thing will happen. You just need to find how many such triplets have none of the values same. So if you're picking 0 from here, you cannot pick 0 from here. And you also cannot pick 0 from here. So we just have to count that thing. So if you are picking, let's say 0 from here. So let us fix here. Like if you're picking 0 from here, you don't have option of 0. You have options, you have 8 options left. So if you are picking 0 from n modulo 4, how many options do you have? 8 options in n modulo 9 times how many options do you have in n modulo 11? So again, let's say you have picked 1 in n modulo 9. You have picked 1 in n modulo 9. Then how many options will you have in n modulo 11? 0 is not allowed, 1 is not allowed, and the remaining 9 options are allowed. So 8 into 9. Similarly, for n modulo 4, if you pick 1, again there will be 72 options, for 2 also, for 3 also, because the problem is symmetric. And hence total number of integers, total number of triplets in which the remainder do not match, all the 3 remainders do not match, will be 4 into 8 into 9, because you have 4 different options in modulo 4, 0, 1, 2 or 3. After you have picked one of these, you have 8 options in here and you have 9 options here. Okay, so this number, if you calculate, will come out to be 288, right? Yes, 288. So this number will be 288, and 288 are just between 0 and 395. From 396 to 792, again you will have 288 more, because the cycle repeats 2 times, and hence the total number of integers for which this condition satisfies will be 288 into 2, which is 576. Okay, so it was not a straightforward problem. You have to do a lot of calculations and you have to see like what's going on. I don't know, like in exam pressure, if you're able to do it, it's really great. But even if you're not, like now see like how you to approach these problems. Generally in GATE exam, I don't think for 3 numbers it will come, because it has become too complicated. They might ask for just 2, 4 and 9, but you should be able to do it. Okay. Cool. So this was aptitude, like all the 10 questions from aptitude. Now let us start probability and statistics. Again, always remember that for aptitude, the weightage is fixed. We know that in aptitude, no MSQ and NAT questions ever come. Only MCQ questions come, which means there will be negative marking in all aptitude questions. Remember this, okay? So there will be negative marking in all the problems. There will be 5 1 mark and 5 2 mark MCQs, and total aptitude will be 15 marks. And there will be negative marking in all of them. Till now, they have not asked an MSQ or NAT problem in aptitude section. I hope they don't later as well. But so yeah, this is the only subject for which weightage is fixed in GATE DA. In GATE CS, maths is also fixed. Okay. But for other subjects, the weightage might vary. So let us now start probability and statistics. In GDMT-2, this was the weightage we had for probability and statistics. Okay, so we had 5 1 mark questions and 4 2 mark questions. Overall, we had 13 marks probability and statistics. Generally, this is what the weightage, like we want to follow the trend of previous years for different subjects, and that's what we are trying to do. So we are keeping the weightage almost that, like as per the GATE standards. Cool. So now let us start probability and stats questions. Okay, I'll just take a 1 minute break. I'll drink water and be back. Then we'll solve it. Okay, let us continue discussing probability and stats question now. I hope everyone is back. Cool. So this is the first question, MCQ 1 mark. In a company, there are 80 employees. They are separated in 2 groups. 50 employees have more than 5 years of experience and 30 employees have less than or equal to 5 years of experience. A project team of 20 employees has to be formed. Out of these 80, we want to form a project team of 20 employees such that at least 17 members have more than 5 years experience. At least 17 members have more than 5 years experience. So you can either pick 17 members with more than 5 year experience and 3 less than 5, or you can pick 18 and 2, or you can pick 19 and 1, or you can pick 20 and 0. There are 4 options that we have. It is classic like counting problem, right? Like rule of sum and product. So you can either do this way or this way or this way or this way. So you will have plus 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 between them, rule of sum. And just to number of ways in which you can select 17 people from this pool and 3 from this pool is a rule of product. So you will have this and this, this and this. We have seen multiple such problems in class. And hence the total answer will be 50C17 into 30C3. This is for the first one. Then 50C18 into 30C2. This is for the second one. And then you will have 50C19 into 30C1. Then for third one and for the last one, 50C20 into 30C0. This is for the last one. Okay. Pretty easy problem. And the 30C0 is actually 1. So if you see the options 17, 18, 19, 20, three, 2, 1, 0. Actually option D also looks surprisingly similar, but it is not same, right? We want the coefficient of 30 to be 3, 2, 1, 0, which is option A. And for 50 we want 17, 18, 19, 20. So option A is the only option which is correct here. Okay. Cool. So this is the first problem. Let's move to the second problem. Let A, B, C be mutually independent events. Mutually independent event means all 3 are independent, which means A and B are independent, B and C are independent, A and C are independent, and A, B, C all 3 are independent also. Which means probability of A intersection B intersection C is also PA into PB into PC. So all the 4 conditions satisfy. Okay. And also like the probability lie between 0 and 1, which means none of the probabilities are either 0 or 1 completely. So which of the following pairs of events are guaranteed to be independent? So we know the pretty easy way to solve these type of questions. You just calculate the probability of A union B intersection C. Probability of A union B intersection C. Now in these questions I always feel Venn diagram to be useful. So this is A, this is B, and this is C. What is the set in which you have all the elements of A and B in intersection with C? So it must be inside C as well, which means this entire set, right? It has all the elements inside A and B, and it has intersection with C also. So if you see this entire set is nothing but A and C plus B and C minus ABC. Okay, and all these are independent events. So you can write it like this, and or you can write it like, because these are independent events, so you can write it as probability of A into probability of C, probability of B into probability of C, probability of A, probability of B, probability of C. Now here you can take probability of C out and you will get probability of A plus probability of B minus probability of A into probability of B. Now probability of A into probability of B is, because they are mutually independent, it is probability of A intersection B, and hence this entire thing will be probability of A union B. So if A, B, C are independent, A union B and C are independent as well. We know this thing, okay, and we have solved the exact same question in class also. Okay. Now option B, again you have to calculate probability of A intersection B and intersection C. So this is very simple. Probability of A intersection B intersection C will be what? Probability of A into probability of B into probability of C, which is nothing but probability of A intersection B into probability of C, which means this is also independent. And we know that if A and B are independent, then A complement and B are also independent, A and B complement are also independent, and A complement and B complement are also independent. We have already proved this. So if these two are independent, then A complement union B complement is nothing but the complement of A intersection B. If you take overall complement here, you will get A complement union B complement, right? So, and hence B, this is also correct. Now only incorrect option here is A union C and B union C. This you cannot write. Okay, why? Because again, if you draw the Venn diagram, you will see this very clearly. So A union C and B union C. So let us say this is A, this is B, and this is C. So if you calculate the probability of the intersection of these two, so what is the intersection of A union C and B union C? A union C is the entire set in which you have all the elements of A and C both, and then B union C is the entire set in which you have elements of B and C both. And the intersection of this will be, firstly, C will be definitely the intersection, which means this entire part will be there. The entire C will be there. Okay. And then what else? A intersection B will also be there, which means this part. So this is the entire set. And hence this set can be written as C plus A intersection B minus A intersection B intersection C. This is what the set is, okay? And it is nowhere near like the product of A union C and B union C. Like if you want, you can try doing different things, but you will never get them equal, okay? It is difficult to prove not equal. It is easier to prove equal. How C is correct, I can say it again, like option B is clear, right? So we know that if A and B are independent, A complement and B are also independent. You can take complement on each of the side. So if you just take the complement of A intersection B and C, they will be also independent, and hence this complement is what? A complement union B complement. So they are also independent, which is option C. Okay. So only option D is incorrect. I'm not expanding this, you can do it on your own time, like try expanding this entire thing. Like what I mean to say is you have to write it like this: probability of C plus probability of A into probability of B minus probability of A, probability of B, probability of C. So that will be actually probability of C times 1 plus probability of A into probability of B times okay, you cannot take probability of C out. So probability of A into probability of B times 1 minus probability of C plus probability of C. Okay, this is what this intersection will be. And what do you need it to be equal to? You need it to be equal to the product of the probability of this and this. Okay, so I don't see it happening anyway. Okay, cool. So yeah, like, but I proved the correct statements. A, B and C are correct, okay, but option D is incorrect. Cool. So this is how you can solve it. Let's move to the next problem. So the question was not that difficult, okay, but yeah, like actually, like in class I covered all these 4 properties directly. If you remember them, you should attempt it. If not, yes, it will take time. For 1 mark, you should not do it. For 1 mark, you can leave it for the end. If time permits, you can attempt it. But yeah, this question I feel is wrongly classified. It was not good. It should be 2 marks, because those who remember all these, like we have covered all of these in class also. If you remember all these, then it becomes a 1 mark question. But yeah, we cannot expect you to do that. Okay. Cool. Anyway. Okay, use your wisdom in such type of questions. Sometimes 1 mark lengthy questions also come. Generally 1 or 2 definitely come, so you have to leave them. Okay, towards the end you can just mark them as visited and just move on. Okay, Cool. A dart lands uniformly at random on the closed disk centered at the origin. This is very simple problem. Okay. Now see, this is a simple problem and 2-mark problem. We should focus on this instead. A dart lands uniformly at random on the closed disk centered at origin with radius 4. It looks very lengthy, but yeah, the options are very easy. Okay. So there is a disk. There is a disk of size 4, of radius 4. Okay. That is all points xy is between x square plus y square is less than or equal to 16. So this is x square plus y square is less than or equal to 16. Inside this disk, consider 3 concentric circles with radius 1, 2 and 3. So there is radius 1 circle, there is radius 2 circle and there is radius 3 circle also. So this is 1, 2, 3 and 4. This is how the disk is. Now A is the event in which the dart, so you are throwing a dart at random. Whenever you are throwing at random, the probability of the entire space becomes uniform. Okay, so the probability of this entire area becomes uniform, and hence if you want to find the probability of the dart landing in a particular region, you just divide by the area. Total area of this entire disk is pi into r square, which is pi into 4 square. So A is the region with r less than or equal to 2. So A is this region less than or equal to 2, the green region. Then B is the region in which the dart lands in the annulus between 1 and 3. Between 1 and 3. So it is this region. Between 1 and 3. Okay. And then C is the dart lands outside the circle of radius 3. Outside the radius of circle 3, which means C is this one. Let's not use this. Let's use the orange. Okay. So outside 3 means this only because outside 4 it can never anyway happen. So this is C. Okay. This is the event C. Now what do you want? We want to find the probability, like let's do it it's a very simple problem actually. Probability of A given B has already happened is what? Probability of A intersection B upon probability of B. Now probability of A intersection B is what? Intersection of A and B both is what? Which means you have to be inside less than or equal to 2 and you have to inside 1 and 3 also. So intersection of green and blue region is just the middle part between 1 and 3. Between 1 and 3. Between 1 and 2 actually, between 1 and 2, okay. So the area of this strip between 1 and 2 will be pi into 2 square minus pi into 1 square upon the probability of B. B is what? Between 1 and 3. Okay, between 1 and 3 is what? Pi into 3 square minus pi into 1 square. Okay, this is the area, like you have to subtract the area of the bigger circle minus the smaller circle. So what it will be, pi by pi will cancel, so it will become 3 upon 9 minus 1, which is 8, 3 by 8, which is option A is correct, which means option A correct. Now similarly, probability of second option is B by A is again probability of A intersection B upon probability of A. Now A intersection B you have already calculated, pi into 4 square minus 1 square, which means 4 minus 1, which is 3 upon probability of A, which means inside the circle of radius 2, which means pi into 2 square. That is 3 by 4, which means option B is also correct. Now option C is saying probability of C given B is what? Probability of C intersection B upon probability of B. Now C intersection B is what? C is the blue region and C is the orange region and B is the blue region. There is no intersection. And hence it is 0 upon probability of B, which is something pi into 8. So it will be 0 only probability. So this is option C is also correct. Option D is probability of A given B has not happened. Probability of A given B has not happened. It will be probability of A intersection with B complement upon probability of B complement. Now what is the probability of A intersection with B complement? Which means A has to happen and B doesn't has to happen. B doesn't has to happen, which means what? R should not be between 1 and 3. Either it is less than 1 or it is greater than 3. And this one is saying less than or equal to 2, which means it has to be lying between 0 and 1. It has to be lying between 0 and 1. So it will be pi into 1 square upon probability of B complement. B complement is again what? Not between 1 and 3, which means it has to lie between either 0 and 1 or 3 and 4. Okay, so 0 and 1 will be pi into 1 square plus 3 and 4 will be pi into 4 square minus pi into 3 square. So it will be 1 upon 1 plus 16 minus 9, which is 1 upon 8. So the probability is 1 upon 8, not 1 upon 4. Option D becomes incorrect. Okay, option D is incorrect. The similar question came in test series, but not this, right? I made it better. Similar questions will always be in the test series. Similar questions will be in GATE exam also, okay? Okay, let's move to the next problem. The following table shows the values of x and y for 4 observations 1, 2, 2, 4, 3, 6, 4, 8. Using this data, calculate the covariance of x and y. Very simple problem, okay? Covariance formula directly you have to apply. So the values of x and y are given as 1, 2, 3, 4, 2, 4, 6, 8. Now x bar or the mean of x is 4 plus 3 plus 2 plus 1 upon 4, which is 2.5, and the mean of y is 2 plus 4 plus 6 plus 8 upon 4, which is 5. So if you write x minus x bar and y minus y bar, you will get 1 minus 2.5, which is minus 1.5, minus 0.5, 0.5, 1.5, and 2 minus 5 is minus 3, minus 1, 1 and 3, and you can just multiply x minus x bar into y minus y bar. So you will get 4.5, 0.5, 0.5 and 4.5. So if you add them all up, summation of x minus x bar times y minus y bar for I is equal to 1 to 4 will be the sum of these, which is 9 plus 1, which is 10, and hence the covariance between x and y is this quantity upon n, which means 10 by 4, which is 2.5. Okay, I'm directly using the formula. How will you use expectation here? Expectation you use when you are given probabilities. This is a statistic problem, not discrete random variable. Okay. So the covariance is 2.5. Okay, moving on to the next problem. Let x and y be discrete random variables with support. Support of a random variable, always remember, support is the set of all values it can take, the sample space. Okay. So x and y are discrete random variables with support of x is 0, 1, 2, 3 and support of y is 0, 1, 2. Their joint PMF is given in this table. Joint PMF probability mass function, because they are discrete random variables. The value of conditional expectation of x given y is equal to 1. Now x given y is a random variable, right? You remember, whenever I am asking you x given y equal to 1, x given y equal to 1 is a random variable. We know this thing. What are the values it can take? It will take the same values which the random variable x takes. So random variable x is taking the values 0, 1, 2 and 3, and hence this random variable will also take the values of 0, 1, 2 and 3, which means it is like essentially like x being 0 given y is equal to 1, and its probability, like these are the values it can take, and the corresponding probabilities will be what? Probability of x being 0 given y is 1, probability of x being 1 given y is 1, probability of x being 2 given y is 1, and probability of x being 3 given y is 1. So these are the values and probabilities. So this is a random variable. X given y equal to 1 is this random variable with these values and this probabilities, and its expected value will be, the expectation of x given y is equal to 1 is like the value times the probability. So 0 times the probability of x being 0 given y is 1 plus 1 times the probability of x being 1 given y being 1 plus 2 times the probability of x being 2 given y being 1 plus 3 times the probability of x being 3 given y being 1. We have discussed lots of problems like this. Okay. Now we just need to calculate these values. To calculate these values, we need to find. So in the joint PMF always gives us the intersection probability. What is this value? This value is probability of x being 1 and y being 0. This is what joint PMF gives us, right? So intersection is fine, but we need to find probability of y being 1 also for the denominator. So probability of y being 1 is the sum of these probabilities, right? The marginal probability. Marginal probability is the sum of the joint probabilities. So probability of y being 1 will be the sum of these 4 values, which is 4, 5, 6, 7, 8, 8 by 20. And now we can use just these values. So probability of x being 0 and y being 1 is 1 by 20. So we will just directly use it. So it will be 1 by 20 upon 8 by 20. And the next one will be 0 upon 8 by 20, 0, 3, 4. This will become 4 by 8. Okay, so 1 by 8, 0, 3 by 8 and 4 by 8. These will be the probabilities. So we can directly calculate 0 into 1 by 8 plus 0 into 0 plus 1 into 0 plus 2 into 3 by 8 plus 3 into 4 by 8. So you can take by 8 common, you will get 6 plus 12, which is 18 by 8, 9 by 4. 9 by 4 is the conditional expectation. Option B. Any doubts? We have again solved a lot of questions like this in class, okay? Moving on to the next problem. Okay, this is the best question of the entire paper. Okay, or you can say at least for probability stats, I can say. Very, very interesting problem, okay? Okay, a system has 10 independent components. Each component fails with probability 0.4. How many of you were able to do this? Okay, this is very interesting, like interesting way of looking at things. It is like discrete random variables plus correlation, like the concept of covariance that we see for discrete random variables. Okay, so we have to calculate the variance in some way. So a system of 10 independent components, we have 10 independent components, they are independent. Each component fails with probability of 0.4. Let n be the number of failed components, and given n is equal to n, a diagnostic test flags each failed component independently with probability of 0.6. Let k be the number of flagged components. So what is the correlation coefficient between n and k? Now n and k here are random variables. They are crazy random variables. Both are binomial random variables. Very good point. So notice that every binomial random variable is a sum of independent Bernoulli random variables only, right? So they are Bernoulli, like it has 10 independent components, right? So every independent component is a Bernoulli random variable. So let me define some events. Let us say xi is the event that xi will be 1 if the ith, let's say ith, whatever it is, ith component, it will be 1 if the ith component fails. And it will be 0 if it doesn't fail. So it is a Bernoulli random variable. So I can say that xi is a Bernoulli random variable with probability of 0.4. How many of you agree with this? How many of you agree with this? Now let me define another Bernoulli random variable yi. So yi will be 1 if the ith component, and based on this you can now say n is the sum of 10 such xi's. N is nothing but n here is nothing but the sum of 10 xi's, 10 Bernoulli random variables. So it is a binomial random variable. You can say that n is the sum of 10 xi's, and xi's are independent, and hence it is a binomial random variable. Sum of independent Bernoulli is binomial. Now y is a random variable which will take the value 1 if the ith component fails and it is also flagged, and it is 0 otherwise, which means it can be 0 if it is either not flagged, like in all the three cases, like there are three cases here, and the three cases are it did not fail and it did not get flagged, it failed but it did not get flagged, and it did not get failed but still get flagged. In all the three cases this variable is 0. This variable is 1 if the ith component fails and get flagged. So like this is what k is. K is the sum of such yi's. K is the sum of yi's. Okay. So what can we say? What is yi? What is this Bernoulli random variable? Yi is what? Yi, if you observe carefully, yi is nothing but xi times some other Bernoulli random variable zi. Like let me explain what I mean here. So xi is the random variable which tells us a particular component failed or not, and zi is a random variable that will tell us that a particular component was flagged or not. And if I multiply these two values, which means failed times flagged, which means if both of them are 1, a particular component failed also and it was flagged also, then only yi will become 1, otherwise it will become 0. So which means 1 into 1 will be 1, and 1 into 0, 0 into 1, 0 into 0, all the three cases it will remain 0. So these two are independent random variables. They are both Bernoulli random variables. This is a Bernoulli of probability 0.4 and flagging is a Bernoulli of probability 0.6. And the product of two independent Bernoulli is another Bernoulli, which makes yi also a Bernoulli random variable of probability 0.4 into 0.6, which is probability is 0.24. So probability of a particular component failing and getting flagged is 0.24. Directly you can say that. I just complicated it using indicator variables, but you don't need to do it. You can directly say that the probability of a particular component being flagged and getting reported is what? 0.6 into 0.4. So it is a Bernoulli random variable with probability 0.24. So far everything is okay. Any doubts? Keep writing in the chat. Now what? Now from here actually everything starts. Now what we have just accomplished? We have just accomplished that every xi is a Bernoulli random variable with probability 0.4, right, or 0.6? 0.4, and every yi is a Bernoulli random variable with probability 0.24, and we know that n is nothing but the sum of all these xi's, 10 independent random variables, which makes it a binomial random variable with n 10 and probability 0.4, and k is nothing but the sum of 10 independent yi's, which makes it a binomial random variable with n as 10 and p as 0.4. That's it. So finding the expectation and variance of x and n and k, expectation and variance of the random variable n and k is simple. You only told me in the chat that they are both binomial random variables. Finding their expectation and variance is very easy. I can say that expectation of n is np, n into p, which is 4, and the variance of n is npq, which is 2.4, and similarly expectation of k is np, 2.4, and hence variance of K is NPQ, which is 0.76. So if you multiply these two, what will you get? 1.824. Finding the expectation and variance of N and K is easy. But what do we need? We want to find the covariance, because once I find the covariance, correlation is what? Correlation factor is the correlation coefficient is covariance upon the square root of variance of first and the square root of the variance of the second, like which means the covariance upon standard deviation of first and standard deviation of second. Standard deviation I have calculated, variance I have calculated, which means standard deviation I have calculated. I want covariance, that is the tricky part. So covariance of N and K is what? Again, N and K are sum of 10 independent events xi and yi. So I can say that it is nothing but the sum of the covariance of all of them. If you have independent events, you can find the covariance of those independent events and sum them up. Again, a property that we have already seen. So summation for I is equal to 1 to 10, the covariance of xi and yi. So you can just find the covariance of any one of xi and any one of yi. And then you can add them up for all the 10 ones, all the 10 events, like because all these 10 are independent Bernoulli events. So what is the covariance of any xi and yi? What is covariance? Covariance formula: expectation of xi into yi minus expectation of xi into expectation of yi. Now this is where you use the covariance formula like this, not the previous question. Okay. So expectation of xi and expectation of yi we know, but what is expectation of xi into yi? This is difficult, right? Xi into yi. So yi is what? Yi is xi times zi. Yi is nothing but xi times zi, right? I just proved it. Yi is xi times zi, the product of two Bernoulli random variables, 0.4 and 0.6. So I can write it this way: minus expectation of xi into expectation of yi. These two values we know. Now this is what? Expectation of xi square times zi. Now expectation of xi square. Xi square is xi is a Bernoulli random variable. Xi is a Bernoulli random variable. The square of a Bernoulli random variable is the same random variable. 1 square is 1, 0 square is 0. So xi square is x only. The square of a Bernoulli random variable is the same random variable. Okay. So you can just write it as xi square will be xi only. So it will be expectation of xi into zi minus expectation of xi into expectation of yi. See, when I'm doing this on the board, it looks lengthy, but when you are doing it on your own, then it will be simple, right? Like you can write these steps in a single way, like in a single go. So xi into zi is again yi. So it will be expectation of yi minus expectation of xi into expectation of yi. So now all these values we know, and hence we can calculate the covariance of one xi and one yi. Then we will multiply it with 10. We will get the overall covariance. So what is this value? Expectation of yi is what? Expectation of yi is 0.24. Right? It is a Bernoulli random variable, so it will be 0.24 p only. So it will be 0.24 times 1 minus expectation of xi, which is 0.4, which is 0.24 into 0.6, and hence the overall covariance will be 10 times this value. It will be 10 times this value. If you calculate it, it will come out to be 1.44. It will come out as 1.44. Now you know covariance, now you know variance of both of them. Can you calculate? Can you calculate we know covariance, we know the variance of K, we know the variance of N. Can we calculate the correlation coefficient? Yes, we can. And hence the correlation coefficient between N and K is covariance between N and K upon square root of variance of N into square root of variance of K, which means the standard deviations. So 1.44 upon square root of 2.4 and 1.824. Brilliant question, brilliant question. Like no one can see like there is actually a relationship between these two, and you can calculate correlation as well. Okay, so brilliant question. And once you calculate it, it comes out to be 0.69. Okay, so this will come out as 0.6888, something like this, 0.69. Honestly, we have not covered questions like these in why not considered xy and yi on all 4 cases. Yes, you can do that as well. Very good. You can do that as well. But yeah, like that will again give you the same answer, right? Expectation of xi yi I directly calculated. I just directly proved that expectation of xi yi is nothing but expectation of this thing. So that made it simpler. That's all. But you can do it that way also, like very like a great strategy. In binomial, no. In Bernoulli, for a Bernoulli random variable, its square is the same random variable. Bernoulli random variable only takes 2 values, 0 or 1, right? So its square is what? 0 square is 0, 1 square is 1. Okay, moving on to the next problem then. I think this was a like, I'll give you the detailed solution again. You can check it out later as well. Again, one more very good question. So let us take a look at this. Let x and y be independent continuous random variables, each uniformly distributed on 0 to 1, which means x is a random variable like this. So p of x will be looking like this. X is a uniform random variable between 0 and 1. Y is also a uniform random variable between 0 and 1. And we want to do something with x plus y. So x plus y will be what? If x is a uniform random variable between 0 and 1, y is also a uniform random variable between 0 and 1. X plus y will also be uniform random variable, like it will be uniform on the square. It will be uniform on the square x, y being 0 and 1, like this is square, 0 to 1, 0 to 1. This is what it will look like, right? Okay, and it doesn't matter, essentially the range on which this function x plus y will be defined will be x can go between 0 and 1 and y also can go between 0 and 1. Now what is interesting is to evaluate this thing, like when is this condition true? That is what you need to evaluate. So in this entire region where x can take values between 0 and 1 and y can take values between 0 and 1, this is like the joint PMF. This is the joint, not PMF, joint PDF of x and y. So this is the x is a uniform random variable between 0 and 1. So Px, x will look like this. It is 1 if x lies between 0 and 1 and 0 otherwise. And similarly the the PDF of y will be this. PDF of y will be again like the same thing because it is also a uniform random variable. And their joint PDF will be what? Because they are independent events, their joint PDF will be what? So the intersection is nothing but the product. So x comma y will be the product of these two, which means 1 if x lies between 0 and 1 and y lies between 0 and 1 and it is 0 otherwise. So this is the joint PMF. Again, joint PDF. So joint PDF looks like this, and actually like it will be like a z-axis also, that will give you the probability, and that will be 1 only, but I hope you get the idea. We just need to figure out in this entire region when is this condition true, for what values of x and y is this condition true, because joint PDF is very simple, but this condition is difficult. So when is x plus y actually greater than or equal to 1 plus half of max of x and y? In this entire region, when does this happen? So we have to take cases, right? First case, let us assume that x is greater than or equal to y. because in that case max of x and y will just become x. I want to like somehow simplify max of x and y. So if I assume that x is greater than or equal to y, firstly like I am working in this region. X is greater than or equal to y, which means I am working in which region? This region, right? Like the right hand side, this region. Okay. Then symmetrically we will work on y is greater than or equal to x also. So if x is greater than or equal to y, what will this equation become? It will become x plus y is greater than or equal to 1 plus half x. Very good. It will just become this, which means that it will become y is greater than or equal to 1 minus half x, or you can say that x is actually less than or equal to 2y minus 1. X is actually less than or equal to 2y minus 1. 2y minus 2, right? Or y is greater than or equal to 1 plus half x minus x, which means 1 minus half x. So 2y minus 2. X is less than or equal to 2y minus 2. Inside this region, when will this happen? So let us try to draw this line, 2y minus 2. X is equal to 2y minus 2. If I draw this line, what will happen? If x is 0, y will be 1, which means I am just trying to draw this line. X is 0, y is 1, and y is 0, x will be minus 2. Did I make a mistake? Just a second. If x is greater than or equal to y, maximum of x and y will become x, and x plus y will become greater than or equal to 1 plus half of x, and hence y will become greater than or equal to 1 minus half x. If you multiply this entire thing by 2, you will get, sorry, I made a mistake here. Yeah. If you multiply this entire thing by 2, what will you get? You will get 2y is greater than or equal to 2 minus x, which means x is greater than or equal to 2 minus 2y. Great. Now if x is 0, y will become 1, and if y is 0, x will become 2. Yeah, that makes sense. So x is 2. So this is the line that we will get. This is the line that we will get. Okay. Now x has to be greater than or equal to 2 minus 2y, which means essentially it has to lie here in this range, right? X has to be greater than or equal to 2 minus 2y. This is x is equal to 2 minus 2y. And when is x greater? In this region. So this is the region in which this will happen. Only this area. This area is my answer. Now the PMF is, entire PDF is just 1, which means for this entire region the PDF value is just 1. I just need to calculate the volume corresponding to this area. And by symmetry we can say that like the region in the other half, which means when y is less than or equal to x, sorry, when y is greater than or equal to x, you will have another such region in the other side as well. In the other side you will have another line like this. In the other side you will have some another line like here you will go to 2 and here you will go to 1 and you will merge somehow. I'm just giving an idea. In the other region it will look like this. So there will be another line like this, and this will be your region. And both these areas will be equal because of symmetry. And you just need to calculate this area, that is your answer, multiplied by 1 because of the PMF. So what is this area? We just need to calculate the area between the lines, this line and this line, and you are done. And we are done, right? So we can just directly do it using integration also. What is this line? So it will be integration from like what values? So what is this value? Firstly, we'll have to calculate that. So when you calculate the intersection, like this value comes out to be 2 by 3, okay? So this value will come out as 2 by 3. You can just calculate the intersection of these two lines, x being 2 minus 2y and x equal to y. So if you calculate it, it will come out as x is 2 by 3 and hence your integration will be 2 by 3 to 1. And what is this line? This line is y is equal to x and this line is what? Y is equal to 1 minus x by 2 dx. So you can do it using integration. Essentially we are just calculating the area of this triangle using integration. How to do that? Like we already know, like from areas, like right, like you just subtract this line from this line. Like this line is y is equal to x, this line is y is equal to 1 minus x by 2, this x minus this line from 2 by 3 to 1, and x goes from 2 by 3 to 1. So if you calculate this, this integral will come out to be 1 by 12. So and hence this area is 1 by 12, and hence the other area is also 1 by 12, and hence overall the probability of this happening is 1 by 12 plus 1 by 12, which is 1 by 6. Okay. So another good question. How many of you got this in exam? Like it's actually it might look confusing that way, but yeah, like once you start writing code, like once you start solving, once you draw the diagram, the PDF, the joint PDF is really simple here. It's really uniform. Like x can go between 0 and 1, y can go between 0 and 1, and this will, like, z axis will give you the probability. So it's like a cube of 1 cross 1 cross 1. Inside that cube you are trying to find the volume of, like, here you have a triangle, here you have a triangle, so and that particular region. So you just need to find the area, because ultimately the height is 1, you just need to multiply it with 1. And now this area you can calculate, like just calculate one of these and the other one is exactly the same. Okay. Okay, let's move to the next problem. 1 mark NAT problem. Let x, y, z be mutually independent random variables. X is a Poisson random variable with lambda 3. X is a Poisson random variable with lambda as 3. Y is an exponential random variable with lambda as 2. And hence you can write the expected value of x as 3. Variance of x also as 3. Here you can write expectation of x as 1 by 2. You can write variance of y, sorry, not x, y. So you can write expectation of y as 1 by 2 and variance of y as 1 by 2 square, which is 1 by 4. Everyone remembers the formula for Poisson exponential, right? Don't forget them. And z is a normal random variable with parameters 1 and 4. So standard means, like, this is mean and this is variance. And hence the expectation of z is 1 and variance of z is 4. Now we just need to calculate the variance of this random variable. So the variance of 2x minus 3y plus half z plus 5. We know the properties. Everyone remembers the properties of variance. Variance of x plus constant is variance of x. And variance of any a times random variable is a square times variance of x. So if I use both these properties here, I will get 4 times the variance of x plus 9 times, not minus, plus, because minus 3 square is also plus 9. Minus 3 square is also plus 9. So it doesn't matter if you are even multiplying a random variable by minus 3, its variance will get multiplied by 9, not minus 9. Okay, so plus 9 times variance of y plus 1 by 4 times variance of z, and the constant does not have any effect on variance. You can just plug in the values. So 4 times 3 plus 9 times 1 by 4 plus 1 by 4 times 4. 13 plus 9 by 4. Is it? Okay, cool. So 13 plus 2.25, right? Which is 15.25. I hope that my calculations are correct. Yep. So it is 15.25. Okay. Very easy problem. If you just remember the formula for, so this question actually wanted you to remind, like, I just wanted you to remember the formulas. Okay, that's why I gave it to you. It might be very long time since you revised it. So I just wrote Poisson exponential normal and the property of variance also. Okay, it involves all of that. Okay, moving on. A factory produces components whose weights x1, x2, x64 in grams are identical. IID means what? Independent and identically distributed. Independent and identically distributed with expectation of x being 50. Expectation of x being 50. All the x's, the expectation is 50. And standard deviation is 8. A shipment is accepted if the sample mean weight satisfies x bar is greater than or equal to 51.5. So what is x bar? If you have x1, x2, x64, 64 independent random variables, their average is what? This is another random variable, x1 plus x2 plus x64 upon 64. This is another random variable. Here we will apply central limit theorem. Central limit theorem says that sum of a large number of independent random variables is approximately normal. Sum of a large number of independent random variables, no matter what they are, no matter what type they are, sum of a large number of independent random variables is approximately a normal random variable. That's why normal, right? It is found everywhere. You just add 100 independent random variables, you will get a normal random variable. That's what central limit theorem says. So this is approximately a normal random variable. So this will be a normal random variable and its mean will be the mean of all of them, which is 50, and its variance will be the variance of each one of them upon n, upon square root of n, because you have to because standard deviation, right? So its standard deviation will be, sorry, not sigma square, sigma. So its standard deviation will be 8 upon square root of 64, which is 1, which means it is a normal random variable with mean 50 and sigma as 1 or sigma square also as 1. Okay, and yep, that's what central limit theorem says. Now we can just use it. Now we have to find the probability of x bar being greater than or equal to 51.5, which means the probability of, whenever you have a normal random variable, you can convert it into a standard normal, then you can solve. So how to convert it into standard normal? X bar minus mu upon sigma greater than or equal to 51.5 minus mean 50 upon sigma. So x bar minus mean upon sigma is 6. Since x bar is a normal random variable, this is a standard normal random variable. So z is greater than or equal to 1.5. Now z is greater than or equal to 1.5. The options are in phi. Phi is what? The cumulative density function for standard normal random variable. So phi of 1.5. We want this probability. We want the probability of z being greater than or equal to 1.5. This one. But phi gives us less. Phi of 1.5 is the other way around. Phi of 1.5 will give us this. And hence we can say that the required probability, this is nothing but 1 minus phi of 1.5, because the total probability is 1, which is option B. Okay. Any doubts? Pretty simple problem. Okay, this finishes all the probability and statistics problems. Now let us start with linear algebra problems. So we'll take a 5-minute break, 5-minute water break. Stand up, do some exercise, like stay away from the screen for 5 minutes, and then we'll be back. And we will solve linear algebra questions now. Okay, let's continue with the linear algebra questions. So linear algebra was 12 marks. Total 8 questions, 4 1 mark questions and 4 2 mark questions. Okay. So let's start. This is the first question, MSQ type. Which of the following statements is or are correct? If A is involutory, then A is invertible. Every involutory matrix is invertible. Is this correct? What is involutory matrix? Involutory matrix is A square is I. So if A square is I, it means that the matrix is inverse of itself, and hence it is always invertible, and every involutory matrix has to be invertible. Its inverse is the same matrix. It means that A inverse is A only, and hence it is invertible. If A is symmetric, then for every real vector x, the value of x transpose Ax is greater than or equal to 0. We cannot say that, right? For a symmetric matrix, if for every vector x, if x transpose Ax is greater than or equal to 0, then it is called positive semi-definite matrix. A symmetric matrix for which for every vector x, x transpose Ax is greater than or equal to 0, it is called positive semi-definite matrix. We have seen this. It means that when does this happen? When all its eigenvalues are greater than or equal to 0. But it might not be possible. For a symmetric matrix, it might be possible that some of the eigenvalues are less than 0 also. For example, if you just take this matrix, -3, -1, 0, 0. Okay. So here the eigenvalues are -3 and -1. Definitely it is not positive semi-definite, and hence it will not follow this thing. Okay, option B is incorrect. Option C, if A is orthogonal, then A preserves Euclidean lengths for all vectors. Yes, orthogonal vectors, orthogonal matrices always preserve the Euclidean length, which means like why? Because orthogonal matrix has this property. If A is orthogonal, then A transpose A is I. Its inverse it's equal to its transpose, right? And hence we can say that the norm of Ax is what? The norm of Ax square will be Ax transpose Ax, which means x transpose A transpose Ax, which is nothing but x transpose x, which is the norm of x square, which means the norm of Ax will be same as the norm of x. If you multiply any vector with matrix A, if it is orthogonal, its norm will not change. It preserves the Euclidean length. We know this property of orthogonal matrices, right? And hence option C is correct. If A is diagonalizable, what is a diagonalizable matrix? For every eigenvalue, its arithmetic multiplicity and geometric multiplicity is same. If A is diagonalizable and all eigenvalues are distinct, then A must be symmetric. No, there is nothing with symmetricity, right? A diagonalizable matrix can be symmetric, non-symmetric, any of these. We already know this property again. So it doesn't make it doesn't make the matrix A symmetric. Okay, it might be symmetric or non-symmetric. Any doubts? Very easy problem. Option A and option C are correct here. Okay. Moving on to the next problem. Let A be the matrix 1, 2, 3, 2, 5, 8, 3, 7, 11. Select all the correct statements. So here, if you want, you can do REF. Even if you do REF, you'll get the same thing. We have to select the correct statements. So we have to find the, if you look at the options of this question, what are the options? Column space of A, unique solution, no solution. Essentially, you have to find the column space and null space. Firstly, let us try to find the rank and nullity of this matrix. Okay. So if we do REF, this is row R1, this is row R2, this is row R3. So we will have R2 is R2 minus 2 times R1, R3 is R3 minus 3 times R1. We will have 1, 2, 3, 0, 5 minus 4 is 1, 8 minus 6 is 2, then 3 minus 3 is 0, 7 minus 4 is 3, 7 minus 6 is 1, sorry, and 11 minus 9 is 2. Then we will do R2 is R3 minus R2, and we will get 1, 2, 3. Here we have a pivot, Here also we have a pivot. Here we had a pivot. So 0, 1, 2, and then we will get 0, 0, 0. So this is a free column. This is a free column. We have two pivot columns, and hence rank of this matrix is 2. The dimension of column space is 2. The dimension of null space is 1. Now let us try to answer some of these questions. Every basis of column space has exactly one vector. No, column space dimension is 2, and hence every basis of the column space will contain how many vectors? Equal to the dimension of the column space, which is 2. So this option is incorrect. For B as 1, 1 and 2, if you take the vector B as 1, 1, 2, the system Ax equal to B has a unique solution. See, one thing, it can never have unique solution because its null space has a dimension of 1, which means for every right hand side, either you will have infinite solutions or you will have no solution. Either it might be inconsistent, but if it is consistent, it will have infinite solution, because for any Ax equal to B, the solution looks like what? It looks like x particular plus null space, and the null space is infinite here. The null space is of dimension 1. It is an infinite space, which means that you will have infinite solutions or you will have no solution if it is inconsistent. So option B can never be correct. You can never have unique solution. You don't need to check anything. Either you will have infinite or you will have unique solution or no solution. For B as 1, 2, 4, the system Ax equal to B has no solution. This might happen. So we just have to check that this lies in the column space or not. So does this lie in the column space? Or you can see that so here essentially what is happening, the first equation plus the second equation is equal to the third equation. So essentially 1 plus 2 has to be equal to 3. So this has to be equal to 3, but no, here it is equal to 4. Or if you want, you can follow the same REF for B also. Like you will have 1, 2, 4 here. Let me do it. Let us just follow, like if you want to follow the proper procedure, you will have 1, 2, 4 on the right hand side. And then if you follow the same steps, you will have 1, then 2 minus 1 is 0, then 4 minus 2 is, 2 minus 2 is 0, yes, and 4 minus 3 is 1. And then you will have 1, 0 and what happened? 2 minus 2 is 0, and then 4 minus 3 is 1, and then 1 minus 0 is 1. Yes. So we have 0 is equal to 1 row, which makes it inconsistent. 0 cannot be equal to 1, which makes it inconsistent. We can do it using REF also. Okay. So if the right hand side is 1, 2, 4, Ax equal to B does not have any solution. This option is correct. Then coming to option D, the system Ax equal to 0 has a unique solution. Ax equal to 0 is what? Null space. Null space does not have a unique solution. Null space has a dimension of 1. It will be an infinite space. Option D is incorrect. So the only correct option here is option C. Write in the chat if you got this right. This is an easy problem actually. Just okay. Moving on to the next problem. Let T belong to a real number. Consider the system of linear equations x, y, z. There are 4 equations. Find the sum of all real values of T for which the above system is consistent. So firstly, like if you just look at these 3 equations, we have to find the sum of all possible values of T for which this system is consistent. So if you just look at these 3 equations, the determinant of 1, 1, 1, just these 3 equations, they are independent of each other. Why? I can prove that 1, 1, 1, 2 minus 1, 1, 1, 2 minus 1. This determinant is what? This determinant will be 1 plus 1 plus 4 plus 1 plus 1 plus 2, sorry, then minus 2. 7. So the determinant is 7, definitely not 0, which means these 3 equations are independent of each other, which means these 3 equations will have a unique solution. Now we just have to make sure that unique solution is satisfied by the 4th equation also, then it will become consistent. Or you can do REF. REF will make like some bad things will happen to this last row, right? It will have T minus 1, T minus 1, T minus 1. I don't want to go that way. The other easier way is what? Since these 3 equations are independent, it will have a unique solution. And that unique solution, you just, whatever that unique solution is, you just plug in the 4th equation it should satisfy that unique solution. And here in this question there is a trick. The trick is you don't even need to calculate that unique solution, because whatever that unique solution is, let us say that unique solution is x star, y star, z star that satisfies these three equations. It doesn't matter. The fourth equation says t minus 1 times x plus y plus z is this. Their sum x plus y plus z will be 2 from the first equation. Their sum will be 2. So we don't even need to calculate that. We can just directly write it as t minus 1 times 2 is t square minus 2t plus 1. So what is this equation? 2t minus 2 is t square minus 2t plus 1, and hence t square minus 4t minus 3 is 0. T square minus 4t plus 1 plus 2 plus 3 is 0. And we don't even need to calculate t also. Like the sum of all possible values t which will satisfy this equation is what? For a quadratic the sum is minus b by a, which is 4. And hence the sum of all possible values of t for which this system is consistent is 4. This is the easiest problem, right? Like if you do it using REF, if you like, when you like later when we'll release the solution, I will release it using REF. It will have the detailed solution using REF. But here there was a trick. If you just notice like these things, this will make the question very simple. Okay. Okay, let's move on to the next problem. Let M be a M cross N matrix with M greater than N and full column rank. Rank of M is N. Define G as this matrix M transpose M, so it is a gram matrix. P is M, G inverse M transpose, so it is a projection matrix. Let X star be the least square solution to minimum of Mx minus B. Also let the SVD of M be U sigma V transpose, where sigma is a diagonal matrix. Select one statement which is incorrect. So 3 here are correct and 1 is incorrect. It might look like a very long question. Again, it is very simple. So G is a gram matrix. We know that every gram matrix M transpose M is a symmetric positive semi-definite matrix. Gram matrices are symmetric positive semi-definite. These three properties, whenever you see a gram matrix, it should click. All the eigenvalues will be greater than or equal to 0. It is a positive semi-definite matrix and it is a symmetric matrix. Okay, even if you give M transpose M or MM transpose, doesn't matter, for any matrix M. So P is a symmetric and idempotent. Firstly, they are asking about P, not G. So P is what? P is M, G inverse, M transpose. This is definitely a projection matrix on the column space of M. Okay, why? Because if you see P square is M, G inverse, M transpose times M, G inverse, M transpose. Okay. P is a M cross M matrix. Okay, firstly let me calculate the transpose of P. P transpose is M, G inverse, M transpose, transpose. So it will become M times G inverse transpose which is just G inverse times M transpose, which is like M, G inverse, M transpose, which is P. So P is a symmetric matrix. But what makes P idempotent? Is there anything given about M also? Okay, M transpose, okay, we can, yep. So M transpose M is G, right? So this will become M times G inverse times G inverse times M transpose. And hence it will become G times G inverse is I, so it will become M times G inverse times M transpose, which is P only. So P transpose is P, P square is also P. If P square is P, it is a projection matrix. And if it is symmetric also, it is an orthogonal projection matrix. So it is an orthogonal projection matrix, it will project on the column space of matrix M. Okay. So P is a symmetric and idempotent matrix and hence it is a orthogonal projector on column space of matrix A M. Option A is correct. The least squares residual, we always know that the least squares residual actually satisfies M transpose R is equal to 0, which means R is actually like the least squares residual. What does it do? The least square residual is actually perpendicular to the column space we are projecting on, right? I explained it really well. How do we calculate the least square solution? We actually find the, let's say we want to find the least square solution for a matrix M. So we firstly calculate a matrix like a large, like matrix M transpose M, and we find the essentially the, like if you want to solve Mx equal to B, we find the projection of vector B on the column space of M. We find the projection of matrix B on the column space of matrix M, and the residual is perpendicular to the column space of matrix M. So yes, the residual is perpendicular to the column space of matrix M, and hence M transpose R is 0. Option B is also correct. We have to find the incorrect statement. It is an MCQ question, okay? The eigenvalues of P are sigma I square upon sigma I square plus 1. We don't know that. What are the eigenvalues of P? Right? We know that eigenvalues of G are sigma I square, because eigenvalues of the gram matrix are actually the square of the singular values of matrix M, and hence eigenvalues of G are sigma I square and then 0. But for P we don't know, right? So we are not sure of this. Option D is G is symmetric, positive, semi-definite. Yes, correct. G is positive, symmetric, definite, so it admits an LU factorization without pivoting. Yes, if for a positive semi-definite matrix all the eigenvalues are greater than 0, and hence LU decomposition will exist without pivoting, okay, because all the principal minors will be greater than or equal to 0. So option D is also correct, and also determinant of G is the product of all the eigenvalues of G. Eigenvalues of G are sigma 1 square, sigma 2 square, sigma n square. So option D is correct, but we are not sure about option C, okay. So option C is the only option which is incorrect. We cannot make a comment on eigenvalues of matrix P, but the eigenvalues of matrix G we know, they are sigma I squares. And yeah, very good point. Yeah, eigenvalues of P, very good point, right? Eigenvalues of P are 1 and 0, not sigma I square upon sigma I square plus 1, right? It is a projection matrix and its eigenvalues are 0 or 1. I forgot this point. Eigenvalues of a projection matrix are always 0 or 1. So it will be 1 for I equal to 1 to n and 0 for m minus n, not this thing. Any doubt? Moving on to the next problem, let P be an orthogonal projection on a k-dimensional subspace. Okay, P is again here a projection matrix on a k-dimensional subspace, so rank of P will be k, and P perpendicular is In minus P. Define the matrix like this. So M is this matrix. M is the matrix I plus 2P times I minus 3 times P perpendicular. P perpendicular is given as I minus P. So let us try to calculate what this matrix is. I plus 2P times I minus 3I plus 3P. So it will become I plus 2P times 3P minus 2I. So if we expand it, it will become 3P minus 2I plus 6P square minus 4P. Now P square is P because P is the projection matrix. So it will become 6P minus 4P, which is 2P plus 3P, 5P. 5P minus 2I. This is what M is. Now determinant of M will be what? So we have to find the eigenvalues of M. Eigenvalues of P is what? Eigenvalues of a projection matrix are either 0 or 1. So eigenvalues of P will be 1, 1, 1 and then 0, 0, 0. And how many times we will have 1? The number of times. What is the rank of the matrix? So rank of the matrix will be K because it is a projection on k-dimensional subspace. So this will be K times, and P is an n cross n matrix. So 0 will be n minus K times. So if you know the eigenvalues of P, you know the eigenvalues of M. So eigenvalues of M, these are eigenvalues of P. and hence the eigenvalues of M will be, for 1 it will be 5 minus 2, which is 3. So 3 3 3 3 3 k times, and corresponding to 0 you will have 0 minus 2, which is minus 2. So minus 2 minus 2 minus 2 n minus k times. These are the eigenvalues of matrix M, and hence the determinant of matrix M is what we need to calculate. Determinant of M is the product of the eigenvalues, which is 3 to the power k times minus 2 to the power n minus k, which is option A. Okay. Pretty simple problem again. Let's move to the next problem. Let A be a real singular matrix. Consider the linear system AX is equal to B, where B belongs to Rn. Select all the statements that are always true. So A is a singular matrix. For a singular matrix, the determinant is 0, at least one eigenvalue is 0, and hence at least one singular value is 0. Okay. So 0 is a singular value of A. And why is the singular value 0? It might not be always necessary that singular value is 0. Singular value 0 is because it is a square matrix. If you notice here, A is a square matrix. So for a square matrix, n cross n, its SVD will look like this: U sigma V transpose. U is n cross n, sigma is n cross n, and V is n cross n. And actually A transpose A and A transpose will also be n cross n. And since it is a singular matrix, their eigenvalues will be at least one will be 0. At least one will be 0. And hence in sigma, at least one singular value will be 0. For rectangular matrix, it is not correct. But for square matrix, if the matrix is singular, then yes, it will have at least one singular value as 0. Because their eigenvalues will be at least one will be 0, and hence one singular value will be 0. There exists a non-zero B such that Ax equal to B is inconsistent. There exists a non-zero B such that Ax equal to B is inconsistent. There must always exist a vector B which is not in the column space of A. Yes, because matrix A rank is not full rank. Since matrix A is not a full rank matrix, the dimension of the column space will be less than n. The dimension of the column space of A will be less than n. And hence there will be at least one vector which is not in the column space of matrix A. Because if all the vectors are in the column space of matrix A, the column space will become Rn, rank will become n, rank is not n, it is singular, rank is less than n. And hence there will be at least one vector which is not in the column space of matrix A. And hence there is at least one vector B such that Ax equal to B is inconsistent. Because Ax equal to B is consistent if B lies in the column space. If B does not lie in the column space of A, Ax equal to B is inconsistent. So there has to exist at least one vector B which is not in the column space, which means Ax equal to B is inconsistent. There exists a non-zero B such that the system Ax equal to B has infinitely many solutions. Yes, that is correct also. Because rank is less than n. Hence nullity will be greater than 0. And hence dimension of null space of A will be greater than 0. And for any vector B, or actually no, this is not correct. Right? We cannot say always. Beautiful option. See here, nullity will be greater than 0. I agree. Nullity will be greater than 0, which means that if a solution exists, it means that we have already seen that question like this before as well. It means that Ax equal to B will either have no solution, or it will have infinite solution. It can never have unique solution. For unique solution, nullity must be 0, which means rank has to be n, or it will have infinite solution. But the option is saying there always exists a non-zero B such that system Ax equal to B has infinitely many solutions. This statement is in general correct, but the only problem is if the nullity is n or rank of the matrix is 0. That is the only matrix that will not satisfy this. Because if the rank of the matrix is 0, which means nullity is n, which means all the vectors lie in the null space. which means only the zero vector can be on the right hand side, that will have infinite solution. Every other right hand side will have no solution only, which means for all the cases you will have this only. This will also not exist. This will happen if rank of the matrix is 0. Only the 0 matrix has the rank as 0. And here the question does not stop matrix A to be 0 matrix. 0 matrix is also a singular matrix. It is also a real singular matrix. So the option C actually becomes incorrect just because of 0 matrix. If A is 0 matrix, in that case option C will be failing. For any other non-zero matrix A, it will be true in general. But this 0 matrix makes option C incorrect. I hope this makes sense. Option D is if B lies in column space of A, then Ax equal to B has a unique solution. No, if B lies in the column space of A, it will have infinite solution. Because again, it is a singular matrix. So it will have infinite solution. Write in the chat if you got it. Okay. Now let us look at the next problem. Okay, lot of math is given, but it is not that difficult. Okay, very simple problem. A centered data matrix X, which is 6 cross 3, has singular values 6, 2 and 1. There are 3 singular values of X. It is a 6 cross 3 matrix, so full column rank, because it has 3 singular values, 3 of them have to be 0. Okay. We perform PCA via SVD and keep only the first principal component. Now consider the least squares problem with the same matrix. So there is a least squares problem. And the thin SVD of X is U sigma V transpose. The thin SVD of the matrix S is U sigma V transpose. And the vector B satisfies this constraint. And we are doing optimization on X. Define the rank 1 PCA restricted solution as X1 is this. So rank 1 solution is also given. X star is also given. X is also given. Singular values is also given. U transpose B is also given. So there are a few things which are given. Now we have to compute this value, which means variance explained by the first principal component upon the total variance. This is very easy to calculate, the PCA part. The PCA part is what? The variance explained by the first principal component of matrix X. That we can directly calculate using the singular values. The first principal component will explain how much variance, the square of the singular value, the first singular value, which is 36. Upon the total variance is what? 36 plus 4 plus 1. So this fraction will become 36 upon 41. This is fine. First part is fine. This is done. Okay. Now second part is we have to calculate the norm of X star and the norm of X1. So what is the norm of X star? Let us try to calculate that. X star will be what? What is the least square solution to xx equal to b? So the system of linear equations is xx is equal to b. X is the matrix. We know that since SVD is given, we know that we can calculate the solution to the system of linear equation using SVD also. How to do that? Using pseudo inverse. Right? And hence the optimal solution is nothing but the pseudo inverse of x times b. The pseudo inverse of x times b. And what is the pseudo inverse? Pseudo inverse is nothing but V sigma inverse U transpose. Yes. So pseudo inverse of x is V sigma inverse U transpose. You just take the inverse of this, right? Essentially, like this is, we know what is pseudo inverse. So you just use the pseudo inverse and you write it V sigma inverse U transpose times B. So this is the optimal solution. So it will become V times sigma inverse. Sigma is what? This matrix. So sigma inverse will be like the 1 by 6, 1 by 2, 1 by 1. So this is sigma inverse. And thin SVD, sigma will be 6 to 1 diagonal matrix. So sigma inverse will be this. Now U transpose B is directly given like this. So it will be 12, 4, 1, 0, 0, 0. So it will be V times, only the first three vectors are useful, the rest three will be 0 anyway. So the first three vectors will be 2 plus 0. So 2, then 0 and 2, and then this value was what? 1, right? So 1 times 1 is 1. So matrix V times 2 to 1. This is what the optimal solution is. We don't know matrix V. That is the problem. We don't know matrix V. We don't know the exact SVD of X. But this is how we can calculate X star. But we know that matrix V is an orthogonal matrix. Matrix V is an orthogonal matrix, and orthogonal matrices do not change the norm of the vector which they are multiplying to. Orthogonal matrices don't change that. And hence the norm of vector X star will be the norm of the vector V times 2 to 1 will be also equal to, because norm will not change. It will be just the norm of the vector 2 to 1. You just need to calculate the norm of this vector, because V times this will not change the norm, and hence the norm of X star, the denominator, and we want square of it. So the norm of X star square, Euclidean norm, will be 4 plus 4 plus 1, which is 9. So denominator is 9. So the least squares part, denominator is 9. Now we need to calculate the numerator. Numerator is this. So if U transpose B is this, what is U1 transpose B? U1 is what? The first vector. The first vector will have component 12. So U1 transpose B is 12. And sigma 1 is what? Sigma 1 is 6. So 12 by 6 times V1. So this is nothing but 2 times V1. X1 is 2 times V1. X1 is 2 times V1. So what is the norm of 2 times V1? So the norm of X1 square is the norm of 2 times V1 square. Now V1 is what? The first eigenvector of A transpose A or X transpose X. But it is the unit norm vector, right? All the eigenvectors we place in matrix V are unit norm. They are orthonormal vectors. They have unit norm. So the norm of V1 will be 1, and hence this norm will be 4. And hence the numerator will be 4. And hence now we have all the fractions that we need. The first fraction is 36 by 41. The second fraction is 4 by 9. It's just that the problem was complex. In that way you have to calculate too many values. But all these values can be questioned among themselves. Like this part, this part, this part. There are 3 questions. And if we calculate all 3 of them, we will get the final answer. So the final answer will be 36 by 41 plus 4 by 9. You can calculate the exact value, okay? It will come out as 1.33. Sigma are in descending order. Okay, you have to write them in... No. But in sigma it is like that. So sigma is the matrix 6 to 1. So in sigma inverse is not a singular, like sigma inverse is not a sigma matrix, right? It is the inverse of it. It can have decreasing order also. Okay, moving on to the next problem. Beautiful problem. Another beautiful problem is coming. It involves linear algebra and probability. It actually can be considered a probability question also, right? Let B1 and B2 be independently and identically distributed Bernoulli random variables with probability of B1, Bi means any of the I. So probability of B1 being 1 and the probability of B2 being 1 is half, and their like probability of being 0 and 0 is also half. Essentially they are Bernoulli random variables with probability half. The parameter is half. Define the random symmetric matrix. So this symmetric matrix itself is a random variable here. It contains 2 random variables. It is like, yeah, like it is a random matrix. It can take any value depending on B1 and B2. This matrix can take different values. And it is not very difficult because Bernoulli random variables can take only 2 values, 0 or 1. So what are the options do we have? So either B1 and B2 can both be 0. In that case, the matrix A will be 0, 1, 1, 0. Or B1 can be 0 and B2 can be 1. In that case, the matrix A will be 0, 1, 1, 2. Or the matrix B1 can be 1 or B1 can be 1 and B2 can be 0. In that case, the matrix A will be 2, 1, 1, 0, or they both can be 1. In that case, the matrix A will be 2, 1, 1, 2. So these are 4 possible cases. And the probability of all 4 of them is what? Since they are independent, the probability of B1 being 0 and B2 being 0 is the product of the individual probabilities, independent events. And hence the probability will be 1 by 2 into 1 by 2, 1 by 4, 1 by 4, 1 by 4, 1 by 4. The probability is same. Now what they are saying, let lambda max be the largest eigenvalue of A. What is the expected value of the largest eigenvalue of matrix A? So what is the largest eigenvalue? We just have to calculate the largest eigenvalue here, here, here and here. That will be the eigenvalue, and then we can calculate the expectation. Probability is sorted, we just need to calculate eigenvalue. So what is the eigenvalue of this matrix, this matrix, this matrix and this matrix? For the first matrix, the eigenvalue is, like, we have to calculate minus lambda whole square minus 1 is 0, which means lambda square is 1. Lambda is plus or minus 1, and hence the largest eigenvalue I am writing here is 1 here. Here it will be minus lambda times 2 minus lambda minus 1 is 0, which means minus 2 lambda plus lambda square minus 1 is 0, which means lambda square Did I make a mistake? 0 minus lambda, 2 minus lambda. So minus lambda times 2 minus lambda minus 1 is 0, which means minus 2 lambda plus lambda square minus 1 is 0, which means lambda square minus 2 lambda minus 1 is 0. But that will make lambda as 4 plus or minus square root of 4 plus 2 upon 2. So is this correct? Yeah, I think it's fine. Okay, let me solve it. So the eigenvalue will be lambda is minus b plus or minus square root of b square minus 4ac upon 2a. So it is 1 plus or minus square root of 8. Square root of 8 is 2 root 2. So root 2, 1 plus or minus root 2. And hence the largest eigenvalue of this will be 1 plus root 2. And this is also the same matrix, like the eigenvalues are same, right? So the largest eigenvalue here also will be 1 plus root 2. And the largest eigenvalue here will be 2 minus lambda whole square minus 1 is 0, which means 2 minus lambda is plus or minus 1, which means lambda is either 3 or 1. So the largest eigenvalue here is 3. And hence the expected value for the largest eigenvalue of this matrix is 1 times 1 by 4 plus 1 by plus root 2 times 1 by 4 plus 1 by 4, which is 1 by 2 plus 3 times 1 by 4. So you can calculate this value using calculator, and this value will come out to be 2.207. Not a very difficult question, right? If you just follow, like, it's simple, pretty simple. Like, just follow, like, just create the matrices, calculate the eigenvalues, calculate the expectation. Just need to know the formulas. Okay, so that is the last problem from linear algebra. Now again, let's take a couple of minutes break, and then we will solve machine learning problem. Beautiful problem, but this was a really beautiful problem. Okay, cool. So we'll be back with machine learning in a couple of minutes. Okay, let's continue our discussion with machine learning now. So machine learning, we have 4 1 marks questions and 5 2 marks questions, and hence total 9 questions with 14 marks. Okay. Okay, let's start. So this is the first question. Given a neural network for binary classification, this is the neural network given. Let y be the true label and all biases be 0. So all the biases are given to be 0 and y is equal to 0 is the true label. After performing one gradient descent update using backpropagation with learning rate 0.1, learning rate is 0.1, the actual output is y, all the biases are 0. And using binary cross entropy loss function, what is the updated value of the weight? W11. And we are using binary cross entropy loss. Okay, so firstly let us do forward propagation. So let us call this value as like whatever output this neuron will give as something, doesn't matter. Okay, let's call it as y1. Let's call this output as y2 and the overall output is y hat. So y1 is what? Here this activation is identity activation, which means the same output will be propagated. So y1 will be, so activation is nothing. It is like the same, whatever is there, like whatever is incoming, that will go as output. So there is no activation at all actually. So it will be, that makes things simpler actually. That makes things simpler. So y11 x1 plus w11 x1 plus w21 x2. This will be y1 and y2 will be w12 x1 plus w22 x2. So what are these values? So 1 into 1 plus 1 into 1. So this will be 2 and this will be 1 into 1 plus 1 into minus 1, which is 0. So this will be y1 and y2. And what will be the overall y hat? So firstly for y hat we will need z and then we will apply sigmoid activation on it. So y hat is sigmoid of z. So firstly what is z? Z is v1 y1 plus v2 y2, which is 1 into 2 plus 0 into 0, which is 2. And hence overall y hat is sigmoid of z, which means 1 upon 1 plus e to the power minus 2. Z is 2 here. So sigmoid of 2. So y hat is sigmoid of z, which is sigmoid of 2, which is 1 upon 1 plus e to the power minus 2. This is the overall y hat. Now if you calculate this value, like this will come out as 1 upon 1 plus e to the power minus 2 will come out as 0.881. Okay. Now what? Now actual output has to be 0, but the output that we are getting is this. So what is the loss? The loss function is, binary cross entropy loss is y log y hat plus 1 minus y log 1 minus y hat and minus of this. Correct? This is the binary cross entropy loss. So if y is 0, we will just take this part. If y is 0, we will just take this part. And we actually don't care about loss. Loss is not there asking. We want to perform back propagation. So we want actually the gradient of loss with respect to y hat. The gradient of loss with respect to y hat, because y is 0, we will just have to take this part, which means it will become minus 1 minus y, and then y hat will become, this will become plus. So upon 1 minus y hat. And y is 0. So essentially it is nothing but 1 upon 1 minus y hat. This is the loss with respect to y hat. Now we don't need this. We want the gradient of loss with respect to w11, because that's what we have to update w11. So we have to actually calculate the gradient of loss with respect to W11. So gradient of loss with respect to W11 using chain rule will be gradient of loss with respect to y hat times gradient of y hat with respect to z times gradient of z with respect to y1, because y1 contains w11. So just follow the trail. W11 is in y1, y1 is in z, z is in y hat, and so on. So and gradient of y1 with respect to w11. This is what we will need the chain. Now gradient of loss with respect to y hat will be 1 upon 1 minus y hat. Okay. Yes. And times gradient of y hat with respect to z. So what is the gradient of sigmoid activation function? So gradient of sigmoid activation function is sigmoid times 1 minus sigmoid. Sigmoid times 1 minus sigmoid, right? Or we can say that y hat times 1 minus y hat. So it will be, so this value, okay, yeah, everything is correct. So this value is 1 upon 1 minus y hat times the gradient of sigmoid with respect to z is what? The value of sigmoid times 1 minus sigmoid. We know that the gradient of sigmoid is that. So it will be y hat times 1 minus y hat. So this and this will cancel and we will just get y hat. And you can always remember that the gradient of binary cross entropy loss function with respect to sigmoid activation will be just the sigmoid value. You will always get y hat. Because even if y is 1, you will have y hat here, y hat here. Okay. So you will always get y hat in the end. Okay. But yeah, cool. So 1 upon y. So you will get y hat times gradient of z with respect to y1. Gradient of z with respect to y1 is v1 times gradient of y1 with respect to w11, which is x1. Very simple. So overall gradient will be just y hat. Y hat is this value, sigmoid of 2. So sigmoid of 2 into v1. v1 value is 1 and x1 value is 1. So it is sigmoid of 2 only, which means the gradient is also 0.881. Gradient is also 0.881, and now we just have to perform the gradient descent, which means the new value of w11 will be the old value of w11 minus the learning rate times the sigmoid, like the gradient. Gradient is sigmoid of 2. So if you perform this, the value will come out as 0.912. Okay. We have solved plenty of questions like this in class, like forward propagation, back propagation. How does the gradient descent work? Okay. Okay, moving on to the next problem. The next problem is from model evaluation and validation. A binary classification dataset has 2000 samples. 2000 samples, out of which 1500 belong to class 0 and 500 belong to class 1. Now you perform 5-fold stratified cross validation. 5-fold, k-fold, stratified cross validation. What does it mean? Cross validation means, firstly, k-fold cross validation means we will create 5 folds. Fold 1, fold 2, fold 3, fold 4, fold 5. In every fold, in k-fold, what do? We use k minus 1 folds, k minus 1 size samples. Like basically we divide entire data set in 5 parts. And we use k minus 1 parts for training and we use 1 part for validation. Right, which means we will divide the entire data set in 5 parts and we will use 4 parts. Like if we divide everything in 5 parts, we will have what? 5 parts means every part will contain how many? 2000 upon 5, which is 400. And it is stratified. Stratified means the class proportions is maintained. Class proportion is maintained, which means out of 400, the same proportion will be maintained. So 1500 by 4 here, and actually not, we have to divide by 5, right? Yeah. So 300 of class 1 and 100 of class 2, class 0 and 100 of class 1. 300 of class 0 and 100 of class 1. This is how the parts will be created. This is how the parts will be created. In fold 1, we will use total 1600 points. Like k minus 1 folds will be used for, k minus 1 parts will be used for training, which means 1600 points will be used for training and the remaining 400 will be used for validation. Did I again? Okay, yeah, correct. Okay. So 1600 will be used for training, 400 will be used for validation. The next fold again 1600 will be used for training, 400 will be used for validation, and so on. Actually, that doesn't matter. We just have to calculate for every fold. In the training set, how many will be class 0 examples? So again, the class proportion will be maintained. So out of these 1600, how many will be class 0? 300 into 4, which is 1200 will be of class 0 and the remaining 400 will be of class 1. Essentially, the class proportions is the main important thing. So in the training set, we will have 400 samples from class 1. In the validation set, again the same proportion if you want. You can say that 3/4 of these or 1/4. So yeah, 100 here and 300 here, class 0 and class 1. But they are asking about the training set. In training set, in every fold, there will be 400 examples of class 1 and 1200 of class 0. How many of you got this? You mark 100 for validation. Okay, yeah, these things happen. Just read the questions carefully. Very simple problem. Moving on, next problem. You are given a mean centered data matrix X, 4x2 matrix. X is a 4x2 matrix. Let V1 be the first principal direction of this matrix. First principal direction we have to calculate. How do we calculate the first principal direction? First eigenvector. How do we calculate eigenvectors? You calculate x transpose x. And the eigenvectors of x transpose x are the principal directions of matrix X. So x transpose x is this matrix. 1, 2, minus 1, minus 2, 2, 1, minus 2, minus 1. It is a 2x2 matrix. That is good. So 1 plus 4, 5 plus 1, 6 plus 4, 10. Then 2 plus 2, 4 plus 2, 6 plus 2, 8. Then 8 and 10. This is matrix X transpose X. It is symmetric. That's why I have written this way. Okay. Now the eigenvalues. We need to calculate the eigenvalues of this matrix and the eigenvectors. So eigenvalues will be 10 minus lambda whole square. Like I'm just setting the determinant of 10 minus lambda 8, 8, 10 minus lambda to 0. So 10 minus lambda whole square minus 8 square is 0. Which means 10 minus lambda square is 8 square. Which means 10 minus lambda is plus or minus 8. Which means lambda is 2 or 18. So the eigenvalues are either 2 or 18. And the corresponding eigenvectors we can very easily calculate. The eigenvalue vector corresponding to 2 will be, corresponding to 18 will be 1, 1. The eigenvector corresponding to 18 will be 1, 1, because if you multiply 1, 1 with this matrix, you will get 18, 18. So 1, 1 is an eigenvector corresponding to eigenvalue 18. Or you can write it as 1 by root 2, 1 by root 2 also if you want. And similarly, and eigenvectors corresponding to different eigenvalues will be perpendicular. It is a symmetric matrix. This will be 1, minus 1. So if you multiply it with 1, minus 1, you will get 2, 2. Okay, this is correct. Okay. So yes, these are the eigenvectors corresponding to the first. So the first or the principal direction. The principal direction for this matrix becomes, the first principal direction becomes 1, 1. And you have chosen it such that V11 is greater than 0. Because see, every multiple of, and it doesn't matter since you are picking the first principal direction is any multiple of 1, 1. So it will look like k, k. And they are asking you the ratio of these. So k by k is what? K by k is always 1. So option, like the correct answer is for the first option, which is 1. You can pick any k, k, you just divide both the values, you will get 1. Can you please show the matrix multiplication? This matrix multiplication. So it is like 1 plus 4 plus 1 plus 4, which is 10. Then when you multiply this row with this column, you will get 2 plus 2 4 plus 4 2 6 plus 2 8. Then when you multiply this row with this column, you will get 2 plus 2 4 plus 2 6 plus 2 8. And then 4 plus 1 5 plus 4 9 plus 1 10. Okay, just row with column. Any more doubts, you let me know. Okay. Cool, let's move forward. For a 2-class Fisher's LDA problem, 2-class Fisher's LDA, very simple problem. With class means as not equal, the Fisher's objective for the projection vector is given. Fisher's objective is same for 2-class or multi-class both. SB and SW are within class and within scatter class matrix. We know all these things. Which of the following statements is true? The optimal direction is proportional to SW inverse times D. Correct. We know that optimal direction, it is something that we have proved, that we remember. This is the formula. For a 2-class LDA problem, the optimal direction is proportional to SW inverse times D. D is the difference in the means. So directly this is done. Like, this is a very simple problem. The between class scatter matrix has a rank of 2. The between class, no. For a 2-class LDA objective, the between class scatter matrix, actually in the derivation, if you remember, in that when I derived the entire things in the class for 2-class LDA and multi-class LDA, we just proved that the between class matrix is proportional to D, which is nothing but mu1 minus mu0. So it's essentially a rank 1 matrix because it is proportional to a single vector. So it is a rank 1 matrix, not to rank 2 matrix. Okay. The maximizer W star is unique. No, it is not unique. It is not unique. Any multiple of W star is also optimizer. Any multiple of W star will also optimize JW. We know this thing. Any multiplier K, multiplied by K. SW must be invertible for Fisher's objective to be well defined. Incorrect. In the class we proved all the theorems when SW was invertible. But I told you, even if it is not invertible, although we did not see the formulas for that, but still we can solve it. But still we can solve the Fisher objective. For Fisher objective to be defined, the denominator has to be greater than 0. So they are saying the Fisher's objective has to be defined. So for Fisher's objective to be defined, we just made one assumption that W transpose SW was greater than 0. This was an assumption that we made, that SW is a positive definite matrix. But we did not make an assumption that it has to be an invertible matrix. If it is invertible, then we are able to find solutions. If it is not invertible, then I told you can do it using pseudo inverses and so on, or regularization. Okay, but the Fisher objective is defined and we can still solve it using pseudo inverses. Okay, so the only correct option here is option A, directly from class, directly using formula. Moving on to the next problem, you are given the 2D points A 0, 0, B 0, 4, C 4, 0, D 4, 4, E 10, 0. So there are 8 points given. Run the K means with K is equal to 2 using Euclidean distance, and the initial centroids are also given. And they are saying on ties, assign the point to the cluster with the small centroid index. Okay, this is for the tiebreaker. After one full iteration, assignment plus centroid update, which of the following statements is or are true? Okay, so we are given 8 points, 0, 0, 0, 4. Let us write them down. Point A is 0, 0, B is 0, 4, C is 4, 4, 10, 0. E is 4, 0. Okay. 10 0, 10 4, 14 0, 14 4. And the two initial centroids given are C1 0 0 0 and 14 4. 0 0 and 14 4. So, and we are using Euclidean distance. So, I am just writing Euclidean distance square in this table because square root, or if you want, we can write square root like the Euclidean distance also. Let us write the Euclidean distance. 0 0 0 0 will be 0. Then this will be square root of 4. This will be square root of 4. This will be square root of 8. This will be square root of 100. This will be square root of 100 plus 16, 116. This will be square root of 196. This will be square root of 196 plus 16, which is 212. Okay. And here we will have 196 plus 16, again square root of 212. Here we will have square root of 196. 4 comma 0, again 100 and 16, 116. Then we will have 100, then square root of 4. Oh, this is wrong. This is also wrong. Square root of 16, square root of 16 and square root of 32. And same here we will have 16 plus 16. Okay, 4 square is 16 and then 4 square is 16, yes, 32. Then square root of 16, then square root of 16, then square root of 0. Okay, so these are the Euclidean distances. How many of you agree? Now what do we want to do? We want to do k-means clustering. How do we do k-means clustering? We just assign it to the centroid which is nearest. So this one will be like these, like which one centroid is closer, we will assign it to that centroid. So this one will be assigned here. So the first 4 points have smaller values of this, and the last 4 points have a smaller value of centroid 2. So these 4 belong to centroid 1, these 4 belong to centroid 2. Now we will update centroids. So let us see options, what they are trying to ask. C1 1. So after first round of updation, what will be the centroid 1? So the first centroid after first round of updation will be the average of these 4 points, because these 4 belong to the first cluster, these 4 belong to the second cluster. So what is the average of these points? What is the mean? 4 plus 4, 8 upon 4, which is 2 comma 2. And the second centroid after the first round of updation will be the average of these 4, which is 12 comma 12. 12 comma 2. 2 comma 2 and 12 comma 2, which makes option A correct, option B also correct. The point 4 comma 4 is assigned to cluster 2 in the first assignment step. 4 comma 4 is assigned to cluster 1, not cluster 2. 4 comma 4 is assigned to cluster 1, not cluster 2. Option C is incorrect. The within cluster square sum after this iteration equals 64. After this iteration, this is the first centroid, this is the second centroid. So the within cluster square sum will be like what? WCSS. Let's see. So this belongs to cluster 1, which is 2 comma 2. So 2 plus 2 is like 2 square plus 2 square is 4. Here we will have 2 comma 2. So 4 plus 4. Sorry, squares and addition. So here we will have 8. Within cluster square sum is 8. Here also 8. Here 4 minus 2 is 2. So 2 square is 4 and 4 plus 4 is again 8. Here also we will have 8. So by symmetry all of them will be 8. And hence total within cluster square sum will be 8 into 8, 64. Total within cluster square sum after this round of iteration will be 64, which is option D. Okay, option D is correct. Any doubts? Okay, this solves this question. Not a like very simple problem. Just follow the rules. Okay, moving on. In the given decision tree, each leaf is labeled as n plus n minus, where n plus is the number of positive examples, n minus is the number of negative examples. We prune using Gini impurity. Select all correct statements. Gini impurity, the higher the Gini impurity, the better. So we want the Gini delta to be smaller whenever we want pruning, right? So cool. Let us try to find the Gini impurity of node A is what? The Gini impurity of node A is what? Gini impurity of node A. So for node A, the overall class 1 and class 2 sum will be 9 plus 6 plus 5. 15 plus 5 is 20 and 1 plus 4 plus 5, 5 and 4, 9 and 1, 10. And hence Gini impurity of node A will be 1 minus 2 by 3 square plus 1 by 3 square. 1 minus probability square sum, which is 1 minus 4 by 9 plus 1 by 9, which is 4 by 9. So the Gini impurity of node A before splitting is 4 by 9. Gini impurity of node B before splitting is 20, 20. So the samples are 20 and 20 each. And hence the Gini impurity will be 1 minus 1 by 2 square plus 1 by 2 square, which is 1 by 2 and not 5 by 9. So option B is incorrect. Based on Gini impurity pruning, node A should be pruned first. Actually, yeah, here it looks like also node A should be pruned first, because node B has a clear... See, if you want to calculate, you can calculate the Gini indexes and calculate the delta. But here, if you prune the node A, here the, like, very obviously you can see that the distribution is not that good. Here we have 6, 4, 5, 5. The distribution is not good. Ideally, what do we want in a decision tree? In a decision tree, we want every node to be very powerful. Like, it should strongly favor one particular class. Impurity should be less. Impurity should be less, right? So we want impurity to be lesser. Here impurity is high, right? 6, 4, 5, 5. Impurity is high. Definitely node A has to be pruned. And node B is like more pure. 18, 2, 2, 18. Nodes B1 and B2 are favoring one particular class very strongly. But if you calculate the weighted Gini and calculate the difference, like I'll give you the complete solution, you can do it on your own. But the delta G for A, for the node A, will come out to be, the reduction will come out to be 0.05. Very small reduction. We want higher reduction. No, we want small improvement in, like, see, yeah, like least useful split is the first that we want to do. Is this the first that we want to prune? And hence the delta of Gini for node A will be 0.05 and delta of Gini for node B will be 0.32. Okay, I'm not doing the complete calculations here. Like, if you want, you can do that. How to do that? Calculate the Gini of A1, A2, A3, then calculate the weighted sum, then subtract it from Gini of A, then again calculate the Gini of B1 and B2, do the weighted sum. Weighted means the number of samples. Samples is same actually here, so weighted will be like 1/3 only. Then you subtract from the Gini of B and then you will get this. So delta Gini of A is smaller and hence yes, A should be pruned first. And also, like, you don't need to calculate all this. Just by looking at the tree you can see that we want impurity to be lesser. Definitely the nodes in B are favoring one particular class too much, and hence nodes in B are good. We would want to prune node A instead of node B. Okay, so option C is correct. If node A is pruned into a single leaf predicting the majority class at node A, what will be happen? If node A is pruned into a single leaf, what will happen? The majority here is class A, so it will always say class A or whatever it is, like the positive example. So it will always say positive, positive. This particular decision will always be positive. So what will be the misclassification rate? 10 examples will become wrong out of 30. So misclassification rate will become 1/3. Or what they are asking, if node A is pruned into a single leaf predicting the majority class at node A, then the number of misclassified training samples contributed by A subtree becomes 10. Yes, the number of misclassified samples will become 10. So option D is also correct. Okay, cool. Moving on to the next problem. You are given a 2D training data set. It's a beautiful problem again. Okay, it is a problem on KNN classification, and the plot is given. So you are given a 2D training data set with two classes A and B with 6 training points and 2 new points N1 and N2. So N1 and N2 are new points and class A points are the blue points. So these are class A points 1, 2 and 3, and class B points are red, red and red. So very obviously you cannot say anything. Where should N1 go? Where should N2 go? We cannot say anything. It is not a very obvious problem. We have to solve it. But the good thing is we are using Manhattan distance. Manhattan distance is easy to calculate. Right. So what happens? What is the Manhattan? So like, let us see, like how does KNN algorithm work? If K is 3, for first option is if K is 3, both N1 and N2 are classified as class B. Let us try to see. If K is 3, we will see the 3 nearest neighbors of N1 and 3 nearest neighbors of N2 using Manhattan distance. Now Manhattan distance works like this. So how much unit distances you need to cover? So Manhattan distance between N1 and A1 is 1 plus 1, 2. Because it is the difference in y's absolute value plus the difference in x absolute value. So it is like how much distance you have to cover in y and how much in x. You sum that up. So Manhattan distance between N1 and A1 is 2. So we have to find the 3 nearest points. Definitely for N1 the first nearest point is A1. I can write it this way. For N1 definitely it looks like the nearest point is A1. And the second nearest point looks like B1, right? 1, 2, 3 distance. So it looks like B1. Then next one will be B3 is 1, 2, 3, 4, 5. Yeah, so this looks like 1, 2, 3, 4, 5, B3. The next nearest point is B3. And the next nearest point if you want. So A2 will be 1, 2, 3, 4, 5, 6, 7, 8. 8 distances far away. And A3 will be 1, 2, 3, 4, 5, 6, 7. So A3 looks like the next closest. So the next closest will be A3. So I have just written the 4 closest neighbors to N1 in that order. Because at max we have to explore K as 2, 3 or 4. So I am just writing that way. Now what are the 4 closest neighbors of N2 in that order, in the nearest order? So for N2 let us try to see which point looks closest. For N2 B1 looks closest. It is only 2 units far away. So the closest point is B1 with 2 distance as 2. And A2 is what? 1, 2, 3, 4, 5. And A2 is 1, 2, 3. So A2 is 3 and A1 is 5. So A2 is closer. Then B2 is what? 1, 2, 3, 4. So B2 is also closer. And A1 is 1, 2, 3, 4, 5. So A1 is next. So these are the 4 closest points to the new point N1 and N2. Now if you take K as 2, the 2 nearest points for N1 will be A1, B1, for N2 will be A2 and B1. So there will be tie, right? Because A belong to class A, B points belong to class B. So which class will you decide for N1? There is a tie, right? There is 1 point which is saying class A, 1 point is saying is class B. So there is no majority, there is a tie. For N2 also there is a tie. If you just take the 2 neighbors, the nearest 2 neighbors, class B has a 1 point, class A has a 1 point. So there is again a tie. And hence for K equal to 2, there is a tie for both N1 and N2. There is a tie. For K equal to 2, there is a tie, equal votes for both N1 and N2. For K equal to 3, what will happen? We are taking the 3 nearest points. So here the majority is class B, and here also the majority is class B, because there are 2 votes for class B and 1 for A. Here also 2 votes for class B and 1 for class A. So for K equal to 3, both N1 and N2 are classified as class B, correct? For K equal to 3, there is a tie for at least one. No, there is no tie. Both of them are class B. For K equal to 4, there is no tie for N1 and N2. For K equal to 4, there is a tie here, right? A1, A, B, B. So there are 2 votes. There is a tie. For 4, again, here also there is a tie. There is tie in actually both of them. We cannot decide. So for K equal to 4, this option is incorrect. So the only correct options are option A and option B. Okay. So this is how this will go. Now moving on to the next problem, which of the following statements about regularization in regression is incorrect? So increasing the regularization parameter lambda in ridge regression generally shrinks the coefficient towards 0. Yes, whenever you increase the regularization coefficient, we are actually trying to shrink the parameters in both lasso and ridge. The lambda actually, the rate, the regularization rate or the regularization parameter actually controls how much we want to do regularization, which means the higher the parameter, higher is the control, and which means the weights will reduce more. So option A is correct. Option B is lasso regression can drive some coefficients exactly to 0. Yes, lasso regression exactly does that. I have given you the complete proof in class. I have shown you the gradient picture, if you remember, in the class, in machine learning class, when I discussed regularization. Lasso regression, how does it work? It will set some of the parameters to 0. It is feature selection. So option B is correct. Regularization can help reduce overfitting by discouraging overly complex models. Correct. That's what regularization does. Ridge regression minimizes the sum of absolute values of coefficients. No, that was lasso. Ridge does what? Like weight squares. It is like lambda times sum of weight squares, not the absolute values of coefficient. It is the square of the coefficient and sum of that. So option D is incorrect. Only options A, B, and C are correct here. So in the question they are asking which option is incorrect. Which option is incorrect? So the only incorrect option is option D. Okay. Cool. So okay, now next problem is from SVM. Now Sriniwas sir taught you SVM, so I'll hand it over to him. He will take it from here. He'll explain this question and the remaining subjects, okay, DBMS and calculus and AI. So that's it from my side. And yeah, I'm handing it over to Sriniwas sir. Stay on this video. In a couple of minutes, we will switch.
Yeah, so good morning to all of you. How are you guys doing? Let me know in chat if I am perfectly audible and visible to you guys. Then we'll start with the discussion of the remaining problems that we have in GDMT-2. Okay, so the last problem from ML is from support vector machines, and it's not a very difficult problem. It's basically a formula based problem in which the optimized W square is given to us. Optimized W square is given to us, and along with that, marginal functions are also given. So these MIs are given to us, which is yi times W transpose xi plus b. These values are given, and we need to find the optimal value of this objective. So why this is an easy problem? Because the formula is already given to you. You just need to exploit this condition in order to calculate all the values of slack in order to get the optimal value of the final objective function or the primal. Okay, so from these values we already know this two conditions are given to us. When we discuss about the SVM primal, these constraints are very important. That's why it's a constraint optimization problem, and we need to take care, we need to respect these constraints, and along with that C is also given to us. Okay, so Mi should be greater than or equal to 1 minus the slack, 1 minus the ith slack, 1 minus psi I. Okay, from this inequality I can say that psi I should be greater than or equal to 1 minus Mi, right? This is our equation number 1. This is first equation, and we also know that the second constraint is that all the slack variables, all the slacks should also be positive or greater than or equal to 0. So it should be greater than or equal to 0. This is our equality 2, correct? So based on these two constraints or equalities, can I say that psi I should be equal to, the ith slack variable should be equal to maximum of 0 and 1 minus Mi? Can I say that? Can I say this? Right? And this is what the condition that we discussed in class as well. So based on the ith value of M, we can calculate the psi I. I have the calculated values. So psi 1 would be maximum of 0 and 1 minus 1.3, 1 minus 1.3, which is 0, right? Psi will be 0, and similarly we can calculate the remaining size. Psi 2 would be maximum of 0 and 1 minus 0.7, which is 0.3. Psi 3 would be maximum of 0 and 1 minus of minus 0.2, which is 1.2. Therefore it will be 1.2. Psi 4 would be 0. I'm writing the remaining size. You can easily calculate based on this. Okay. 5 would be 1, 2, 3, 4, 5. 0.05. 0.05. The sixth slack would be 2.4, and finally the last one is 0. And once we have all the values of these slack variables, just put it in this primal and find the value. Put it in this primal. W square is already known to us, 9. So the optimal value would be 1 by 2 times 9 plus C times the sum of all size. C times the sum of all slack variables. C is 4. 4 times sigma over I belong to 1 to 7 psi I. Just calculate the sum of all, multiply it by 4 and add it to 4.5. Okay, so if you calculate, it will be 4.5 plus 4 times 3.95, which is 20.3, which is 20.3. A is the right answer in this case, right? So given the primal, if this like the objective was absent or was not given, in that case you might think that it would be a bit challenging since the formula is not given to you, but it is just the formula based problem. Once you know how these slack work and how to calculate slack using the functional margins, it's easy. Okay. All right. Then let's discuss the Python and DSA problems. So in GDMT-2, we had total 9 questions from this section, out of which 5 were 1 mark and 4 were 2 mark problems. So total 13 marks was allocated to Python and DSA. Since it also includes 2 to 3 problems from Python programming, that's why the weightage is slightly more compared to other subjects. So more or less you will get like 10 to 12 marks from each subject, but DSA and Python will be on slightly a higher percentage side since it includes Python programming as well. Okay. So let's start with the first problem. Which is a multiple select problem, MSQ, 2 marks, and it's from Python programming. The code is given and we need to find all correct options. You need to print the values based on these 3 function calls. And here is a little catch. Why? Because it is also using a tuple. It is using a tuple and a list. It is using a tuple and a list, and we already know that list is mutable but tuple is not. So we'll discuss that twist. First, it is called A is equal to FOOD of true. So first catch is in this line. A hash map or a dictionary is defined with key as booleans. So I need to state this point. A hash map is defined, and key is used as a boolean. So whenever a boolean is used, the key is allocated to, we already know that the value of false is 0 and the value of true is 1. So whenever you see a dictionary with key as boolean, you will straight away replace the key with either 0 if it is false or 1 if it is true, right? So it works like this. So a dictionary is defined with key as true and its value is 0. With key as true, so it becomes 1, 1 is the key and value is 0. So this is the first key of the dictionary or the map. Then again with similar key, the value is allocated as 1. So it will override this 0 and update it to 1. Why? Because both these keys, true :0 and 1:1, are pointing to the same key, which is 1. Correct? And adding to this, this is also equal to 0.0 or 1.1. 1.0, not 1.1. This is also equal to 1.0. So either you can use boolean as key, it will be 1, or you can use a floating number which is 1.0, it will also treat as 1, right? So this will override this 0 and this will no longer be 0, it will be 1, right? Then 1.0:2, again the same thing. 1.0 is also 1, the key is same, it is not different. So key 1, key true and key 1.0 all are same, right? So this will again overwrite this to 2. So this is the first key of our map. Then second key is false. False would be 0. Key is 0. What will be the value? The value is 3. Initially it will be 3. Then this 3 is updated. Then the value present at key 0 will update it to 4. So this no longer be 3, this will be 4. So this is the dictionary. The meaning of this line will be a hash map with 2 keys, 0 whose value is 4 and 1 whose value is 2. Is this clear? Is this clear? Any confusion here in defining the dictionary? And at the same time, if you go and access it, D of 1.0, will be equivalent to d of 1 will be equal to d of true, which is 2. All these threes are same. If you try to access the map with either of these three keys, it will give you 2. And same holds for false. 0.0, d0 and d false, it will give you 4. Right? Okay. If this is clear, then let's come to the function foo. So we are calling this function with d of true. And d of true will be 2. And similarly, d of 0.0 will be same as d of 0 will be equal to d of false, which is 4. Okay, so d of true is 2. So this function is called with parameter as 2. The first parameter. We have two parameters in this function, x and a tuple. So this is called a is equal to 2. That's it. Clear? And if we only pass one parameter in a function that needs two parameter with the second one as default, it will take the default value for the second parameter, right? And it is already defined as a tuple. It is defined as a tuple with one value, which is an empty list. T is a tuple with only one value, which is an empty list. Right? And now if this is the case, if foo is called with only one value, which is 2, x becomes, the value of x becomes 2 and t becomes the empty list, right? T becomes the empty list, correct? Okay. Now we have a exception handling block, a try catch block, and now this line is important. What we are trying to do is we are trying to update the 0th index, which is an empty list, in a tuple with another list, or like we are trying to append this x in this list. What is x? In this case, it is a list with a single element 2, right? For the first function call, right? If this is the case, we are trying to append equal to 2 over here. We are trying to append this over here. So here two operations will get triggered. The first operation is the extend operation. We are trying to extend this list, which is initially empty, with another list having a single value as 2. First operation will be extend operation, list extend. Second operation is we are trying to update the 0th index of this tuple. Update the tuple, which is an immutable data type, which tuples are immutable in Python. So this will throw an error. But extend operation will execute. Because it is a valid operation. We are trying to insert another list towards the end of a list. But since this list is in a tuple, it will throw an exception. Right? But exception is thrown after the update. This is the point, or the important, like the crux of the problem is this will get updated and then it will throw an error. That's it. Right? Okay. So at this point, when I'm trying to update this, T of 0 will no longer be an empty list. It will be updated to 2. Initially it was empty and then 2 is extended. So it is, the operation is similar to empty list plus 2, which is 2. Right? Okay. Then the exception is thrown, exception is captured, but it is passed and just T0 is returned. T0 is 2, this is returned. And one more thing, one more important point is, since the second argument was missing in the first function call, this A will refer to this T. This A will refer to this T. Which is also whose value is a list with value 2. Right? Okay. So if this is clear, then the next two function calls won't be difficult to understand. The second function call is b. Foo is like called again with d0. In this dictionary, d of 0 would be 4. So then b is called with 4 as first argument and second as a new tuple. This is a new tuple. This is a new tuple. This is a new tuple which is empty initially. Oh, yeah, which is initially empty. So this is not related to small t. The second function called b is not related to small t. Okay, so default value is not assigned as t. It will be a new tuple which is this, whose first element is a list, a empty list. Correct? Okay, but the idea remains the same. No matter whether it is like it is referred to this existing global tuple or a new tuple is assigned, it will do the same thing. It will try to update it. It will successfully update it, but it will throw an error. It will try to update it. B becomes, initially T0 would be empty, this list plus X. X is 4 in this case. X is 4 in this case. So B becomes 4. B becomes a list. B becomes a new list and it is not related to small t. It is not related to the global tuple or this one. Right? Okay. Then the third one, again in the third case, we are trying to pass the first argument as d 1.0 and we have already seen if it is 1.0, no matter, it will always give you the key 2. It will give you the key 2. Then C is called with foo and the second argument is missing. If the second argument is missing, it will take the default one. Default one is this t, but this time this t is no longer a tuple with the first element as empty list. This time it is a tuple. This time it is a tuple with t0 as 2. With t0 as 2. Why? Because the first function call has already updated its first element. Right? Okay. So therefore, what C will be? C will be again a extension of t0 which is initially having value as 2. So it will be 2. One more 2 is added after this. The operation is 2 plus 2, which is 2 comma 2, a list containing 2 elements, 2 comma 2. And the interesting thing is, since A was also referring the same tuple, the global tuple, C will also point to the same tuple. Why? Because argument is not passed, so it will take the default. The default is the global one. The default is the global one. So it will also point to this. It will also point to this. That's it. That's the crux of the problem. Now you can figure it out. Print T0. What will be T0? The tuple becomes, T is now 2 comma 2. That's it. This is the updated value of tuple. T0 will be 2 comma 2. It will print, let's see what it will print. It will print T0, a tuple, a list with 2 values, 2 and 2. Then we are trying to print, is A is equal to T0? Is A is equal to T0? Answer is yes, it is. Answer is yes, so it will return true. It will print true. Then B and then C. We are trying to print B. What is B? B is 4 and C is again 2, 2. It will print 4, 2, 2. This is our B, this is our C. And finally, length of D, it is total number of keys, which is 2. And finally, D of 1. What is D of 1? D of 1 is again 2. This is what will be printed. This is what will be printed. Clear? So A is correct. Second, after the program finishes, A is C evaluates to true. Is A is C? The answer is yes, it is. Both A and C are referring to the global tuple, are referring to the 0th element, this, of the global tuple T. Right? Third one, after the program finishes, B is T0 evaluates to 2. No, this is incorrect. B is not T0, B is 4. B is 4, B is not T0. Why? Because we have already passed a different tuple having the list, having the first element as empty list while calling the second time, while calling the function second time with and allocating its value to B. Clear? Okay. And finally, the last one, if try except inside the foo is removed, everything else unchanged. Okay, the scenario is this is removed and this is removed. The program raises type error. Answer is yes, it will raise. It will raise after extending the list. It will raise the type error. So this is correct. It will raise the type error. So only C is incorrect. Rest all are correct. So correct answer is A, B, and D. It will raise the type error. In this case also it raised, but since we have handled it over here, it is passed. Okay, the program is not halted. Clear? Any confusion in this? Any confusion in this problem? This was a good problem. So the important thing is how this dictionary works when a boolean key is passed, and then what if you try to update a mutable and an immutable object simultaneously. Okay? Alright. Next one, again from Python programming, and in this case you need to give the time complexity and the space complexity of this rotate function. We have already seen how to evaluate the time complexity in the functions involving loops. So we need to count the total number of times the loop will execute, okay, along with the operations inside the loop, right? And the space complexity is what additional space you are using in order to execute this program apart from the initial allocated space or the space allocated to the parameters of the specific functions. Okay. Alright, so the first is rotate function is called, and n is passed as an argument. So A is a list having range n. A is a list having range. This range will return value 0 to n minus 1. Okay, so this is, if you try to find the time complexity of the first statement, if you try to find the time, first let's discuss the time complexity. The time complexity of this would be big O of n. The time complexity of first operation would be big O of n. Why? Because whatever the range is returning, we are converting to a list and assigning it to A. It is big O of n operations. 0 to n minus 1 values. So A would be 0, 1, 2 till n minus 1. So these n minus values are appended in this list A. Therefore it is a big O of n operation. Right? Then a loop is called n number of times. It will be 0 to n minus 1. Same, a loop is called n number of times. This loop is big O of n operation, right? Just the loop. But there is some operation inside the loop, which is A is equal to a slicing and concatenation. A is equal to first the slice operation 1 till the last index. So it is A is equal to A 1 colon plus A colon 1. This is a slicing operation, and the slice is starting from index 1 till the last one. So it is a n minus big O of n minus 1 operation. Big O of n minus 1 operation. Why? Because we are starting reading the elements from index 1 till the last one. So n minus 1 operations are done for this specific slicing operation. Correct? And for the second one, this is also a slicing operation, but from this is only one. This is big O of 1. This is also slicing operation, but big O of 1. Till 0th index we are slicing. Till 0th index, so only reading the first element in the list. Okay. So combining these two operations, it will be big O of n. Correct? And this big O of n operation, we are doing it for every iteration of this outer loop. So this is big O of n. So combining these two, for every operation we are doing n amount of work. The total amount of work would be big O of n square. Makes sense? Why? Because first iteration it is n, then second iteration it is n, then third iteration it is n, till the nth iteration, which is also n times, which is big O of n square. So like n minus 1 by 2, which is big O of n square. So big O of n square will be the time complexity of this rotate. Clear? And if time complexity is clear, Next, we need to find the auxiliary space complexity, the additional amount of space which is required in order to do this operation. First, n space, like n amount of space is allocated in order to define A. Why? Because it is having size n. So for this, if we talk about space complexity, let's write it here. If we talk about space complexity, to define A, n amount of space is required. Yes or no? To define a list having n elements, additional n amount of space is required. Then second, in this iteration, while performing this slicing operation, additional n amount of space is required. While performing this slicing operation, n amount of space, n minus 1 amount of space is required to temporarily store these n minus 1 elements, and 1 amount of space is required to temporarily store this element, which is a list having only a single element, right? And then concatenating to A. So for the slicing, additional n amount of space, n minus 1 plus 1, which is n amount of space is required. But it is the common space for all iterations. It is not the case that we need n amount for every iteration. It is common for all. First iteration will be using that temporary storage of n size. The second iteration will also be using the same temporary storage. Why? Because every updation is getting, like every operation is getting updated to A. So we do not need a separate copy of size n for each iteration. This n would be sufficient. So therefore total space complexity would be 2n, or big O of n. This is equal. Why? Because we can come up with a constant c such that c times n will always be greater than or equal to 2n. Okay, you can use 3, 4 and so on. A constant can be found. So the right answer is n square and n, option A. Clear? This was also not a difficult problem, easy only. Any confusion? If no, this is an interesting problem. So if you try to solve it using the stack trace, you will encounter an error. Like it is high chance, there is high chance that you will commit a mistake if you try to solve this problem using the stack trace method that we discussed. Rather than, if you see a function involving multiple recursive calls, if you see a recursion having multiple recursive call, you can use a recursive tree approach in order to get the solution. And the catch is also that we are updating the value of L, which is a list. Lists are mutable. And the reference, we are passing the reference. So any one update will also impact the other function calls, because the list is shared among all these, right? So how will you do? Let's see. So initially the list is empty, and then this function is called with first argument as 3 and the empty list. For the first function call, this will be 3 and L will be empty. So if I want to form a recursion tree, it will look like this. The root will look like this. This is n and this is the empty list, initially L, right? Any confusion? This is an interesting problem. Then the first operation that we are doing is L dot append n. We are appending this 3 to this list. Now the list is no longer an empty list. The list is updated to having one element whose value is equal to n, right? After appending, this function is called again with n minus 1 and L. This function is called again with n minus 1, which is 2, and L will be 3. Correct? Then we have popped the element that we have inserted just after this function call is completed. Okay? and it is totally up to you how you want to like totally define this recursive tree. But if you want to define, in that case, if you want to define the second branch after removing the element that you have inserted in this list, you can anyway define, or you can go to the first trace in order to get the result and then go on to the second branch of this tree, which is the function call involving b, the second function call. Either way is fine, but let's go in the depth. After you call this 2 and 3, again it will come back and it will check whether n is equal to 0 or not. In this case, n is not 0 and list is having value 3. So it will append n to the list. It will append n to the list. It will append n to the list. List will become 3, 2. It will append to the list. List will become 3 and 2. 3, 2. Right? Again, the same function is called at this line with this configuration, and n is still not 0. Till n is not 0, we will keep on calling the recursion. Next would be 0, and this is appended. 1 is appended, which is 3, 2 and 1. The third function call will be made after appending 1 and then calling the function with n minus 1 and l. N minus 1 and l. Is this clear? Is this branch clear? Let me know in chat. Any confusion in this? First we will call with 3 and empty list, then 2 and list with having single element, then 1 with 3, 2, and then finally 0 and 3 to 1. Finally 0 and 3 to 1. Any confusion in this? So if this is clear, the second step, what it will return, we have to like stop to jump over what it is returning, since it is 0 and 3 to 1 is what is returned. But we have to wait. Why? Because there is a catch. We are removing the element that we have added in the list. We are popping this out. And this list, the L is shared among both A and B. L is again, the second operation is then pop from the list. And if you perform this pop operation, it will remove this one. It will remove this one. It will remove this one. After removing this one, B is the recursion function is called again with n minus 1 and L. But the value of L will be 3 and 2, not 3 to 1. Why? Because you have already removed the last element that you have inserted, which is 1. So next function call would be 0 and L would be 3 and 2. L would be 3 and 2. L would be 3 and 2. Now if you return, now if you see this return, which is A, B, N, or like for in this case it will be 0, so L would be returned. Both the cases we are returning L. In both the cases we are returning L. But the L which is returned in the first case will not be 3 to 1. Why? Because there is a pop operation which is already done, which will impact the result, of this L, which will impact the result of the value L. Why? Because L is shared among these two function calls. So both of them will return 3, 2. This is what they will return, 3, 2. Is this clear? Is this point clear? This is the important part. This is the crux. If you understand this, why removing the last element that you have inserted from the list will impact the value of A and B, then the problem don't have that much significance. If this is clear to you. And the follow-up function calls, the follow-up recursive calls would be easier to understand if this point is clear. Okay. So if this is the case, the next is to, once you are done with function call A, when we are done with function call B, the last step is to return A plus B plus N, concatenate, form a list and then return it. This will be your A, this will be your B, concatenate it with the third one and then return. Concatenate with the third one and return. This is what is returned, 3, 2. This is what is returned. Let me mark it with white. It will return 3, 2. The last step of this function call, would be take A, take B, concatenate with N and then return. Take A, which is 3 2, take B, concatenate it with N. What is N? N is 1 in this case. Concatenate with 1 and then return. What it will return? It will return 3 2 3 2 1. It will return 3 2 3 2 1. It will return 3 2 3 2 1. So this becomes the A for this function call. Now we'll see the B of this function call, and then we will concatenate this A, the B which is returning from the lower function call, and add 2 at the end, and so on. We'll keep on continuing this recursion till we reach the root. But this is important. Okay, so if this part is clear, then the second part of this, which is, what if the second function call, this was A, then we need to remove 2 and then call B. It will be 1 comma 3. It will be 1 comma 3. Is that clear? The first function call A was made with 3 2. The second function call will pop the element from the list, and then n minus 1 and L is called with n minus 1 and L. L becomes 3 now at this point. At this point L becomes 3 now. Okay, is this clear? At this point L becomes 3, and if L is 3, the next two subsequent function calls will be easier. First one will be 0 3 comma 1. The first will be 0 3 comma 1. The second would be 0 3. Second will be 0 and 3. Why? This one which is got appended will be removed, and then the function is called again for B. Is this clear? Any confusion in this? What will be the value which is returned over here? Now tell me, what will be the value which is returned just by seeing these two function calls? This is the termination of the recursion of this branch. What will be the value which is returned? Anyone? It will return the same thing. It will take 3. It will return 3. Again it will return 3. It will take this 3. It will take this 3 and append 1. It will take this 3. So it will be 3, 3 and 1. Why? Because of this A, then add B and then append N. N is 1. This is what is returned to its parent. It will be 3, 3, 1. Okay. So if I want to calculate what this function call will return, it will take its left hand side, it will take its right hand side, and finally concatenate, and lastly add N. For this instance N is 2. So the value returned to the parent from left hand side would be 3, 2, 3, 2, 1, which is this, then 3, 3, 1, and finally 2 is appended. This is what the left hand side, or A of the root will be. Clear? Any confusion here? So if left hand side is clear, right hand side would be like easy enough. Let's quickly have the right hand side of this tree as well. Yeah, if left hand side is called with 2 and 3, then the element is removed, then this 3 is removed. So the next function call for B would be for n minus 1 and a list having the last value removed from it. It will be 2 and the empty list. Make sense? Right? If this is the case, you go towards the left node of this recursion. It will be, its n is 2. So it is not the termination condition. So L will be appended, 2 will be appended to this list. List is empty. So it will be 1. The next function call for a would be n minus 1 and the last value n is appended to the list 2. Clear? And for this the leaf nodes would be, for this the leaf nodes would be 0, 2, 1 and 0, 2. But in between there is a pop operation, so this one will be removed and both will return 2. Both will return 2. So what the value? This will return 2, this will return 2. So let me be quick over here. The value which is finally returned from this function call a of 2, the left hand side of 2 would be this 2 and one appended at the end. One added at the end, which is 2, 2, 1. Clear? Similarly, the right hand side of this node would be 1 and the empty list. 1 and the empty list. Again, this is not the terminal condition. The recursion is further having 2 subtrees, 0 with 1, since 1 is got appended over here, and 0 with empty list. And in between there is a pop operation, so this one will be removed. So both will return empty list. In this case, both will return the empty list. But don't get confused. The left hand side would be empty list, right hand side would be empty list, but there is also one more condition, which is 3. You have to append n at the end. A is empty, B is empty, but n will be having a value which is 1. So its value will be empty plus 1, which is a list having a single value 1. That's it. This is what is returned to its parent. So it will take left hand side, it will take right hand side and append, finally add 2 over here. So its value will become 2, 2, 1 from left side, 1 from right side and 2. It will return to the root. Root will take left value, root will take right value, append it, finally add 3 over the last position. So its final value becomes 3, 2, 3, 2, 3, 2, 3, 2, 1, 3, 3, 1, 2, 2, 2, 1, 1, 2. And finally this n, which is 3. Finally this is 3. This is what the final value of this recursive function will be returned on in this variable called out. The value of out will be this. Is it clear? Is it clear? Any confusion? Any confusion? And the second catch is we are printing this out and L. And each function call, what it is doing, it is appending L with an element and then popping it out. So logically you can argue that the value of L after all the operations will be empty. The value of L, the list will be empty. Why? Because every operation is appending a value and then removing it. Every recursive call is doing the same. So L, this is out, and after this list will be empty, which is option A. It's a good problem to understand how the list is shared among different recursive calls and how to trace recursion if the recursion becomes a bit complicated, involving more than one, like 2 or 3 function calls. So better to go with the recursive tree approach and then backtrack till the root from leaves. Okay, you can also do it with like stack trace, but using stack trace it will be a bit difficult to maintain all the values. Clear? Any confusion? So we can expect similar sort of problem. If you want to reduce the complexity of the problem, we can remove list and use some variables or some values to print. We can print n. If you just print n over here in between these recursive calls, it becomes a bit simpler. Why? Because maintaining these values, there are high chances if you commit even a smallest mistake in appending the last value or retaining these values from left hand side and right hand side, it is like the chances are high that you might commit a mistake. But yeah, similar problem, remove list, print something, and then what is the value which is printed by the recursive call. It's like very common in like a CS gate exam. Okay, so if it is clear, then let's see the next one, move on to the next one. This is also an interesting problem. A graph is given, basically a dictionary is given, but it is a graph. You can form the edges and all, and a function called walk. So how these nodes will be walked using this function is what is asked in this problem. We are calling this walk with parameter as a, which can be treated as the initial node from which we are starting to tracing the nodes. We are starting the traversal from a. What will be the order in which the nodes will be explored? So this is BFS. This is BFS, if I am not wrong. A, B, D. Yeah, this is BFS. This is how BFS is implemented in Python using graph. Like the graph is a map. So if you see the graph, this is what it is saying. You have A, which is the starting node. If we draw the graph, A is linked with B and C. From A, you can go to B and C. Then from B, you can go D and E. We can go D, we can go E. From C, we can go F. From D, it's the dead end. From E, there is a edge till F. This is what it shows. This is what, if you draw this, if you convert this map to a graphical representation, a DAG, like a directed acyclic graph, this is what it will look like, right? Now if you see the problem, it says we are using a set. In Python, the set is a data structure which is implemented in a similar way as dictionary. The only difference is it maintains the value is like the keys are the values that you are adding in this set. Set is like this. If you add anything, it will form a dictionary, but the keys will be the values that you are adding, and its values will be either 0 or 1. The value will be either 0 or 1. So for the elements which are present in the set, it will be a dictionary. For instance, you are added A, B and C in this set. If you add A, B, C in this set, it will look like this. A, first key with value, the key value is A and its value is 1. B, 1, C as 1. That's it. So all other keys which are not present in this set, all the values which are not present in this set will return as 0. Right? So internally it's a hash map only. But it holds whether a specific key is present in the dictionary or not, and the idea is given by its value. If it is 1, then it is present. If it is 0, it is absent from the set. Okay. So let's trace this problem. Visited set is initially empty. So either you can use a dictionary. The more convenient way is to have a 2D array, a visited set, a set with nodes. Initially, let me mark all the values as 0, which is initially the set is empty, and the nodes are A, B, C. A value 0, B 0, C 0. A, B, C, D, E, F. D, E and F. All are initially 0, which means the set is empty. And the variable is visited. It is just to trace whether a node is visited or not. Basically, these sort of data structures are used for graph search. And like it is same. We have seen this visited in BFS, in DFS, and BFS, DFS in AI, the uninformed search. Okay. First is we are starting with a list which is having only a single value start, and we are calling this function with A. So A is the starting point. ST is A. ST is A. Correct? This is fine. And order is initially an empty list. Order is initially an empty list. This is also a list, but this list is only having one value as A. Right. This is the scenario till now. Then the while loop, while ST is non-empty. This is a Boolean condition ST, which will check whether this list is empty or not. It's true, it is not empty. So we will get into the while loop. V is equal to st.pop. V is equal to st.pop, and it's a list. All append operation will be from the right hand side. All pop operation will also be from the right hand side. So this will be removed. A is removed and assigned to V. V becomes A. Right? The second is if V is visited. If V is visited, which is if V is present in this visited set or not. Answer is no, it is not. It is not visited, so this won't execute. Straight away, we will skip the if condition. Visited dot add V. Add is a function. Add is an inbuilt function which is used to add an element to a set. Visited is a set. Add is the function, utility function that is used to insert an element in the set. What it will do? It will take this visited hash map, which is a set. It will take this key and then assign a value 1 to this key in this set. That's it. What it will do? The value of V is A. It will take A. It will go to the set. It will remove 1 from here. It will remove 0 and assign 1. Which means this set now contains an element which is A. This means the set or the map contains an element A. Right? So we are done with this line. Second is order.append V. We are appending the node that we just now visited in this order. Order is initially empty, so this A will be added or appended in this order. Removed from ST, assigned to V, and then updated in the visited and added to the order. Order is the order in which we are traversing the nodes. Right? Then a for loop. Which is for NB in G of V. G of V is G of A. G of A is a list having two nodes B and C, having two values B and C. So this will be a loop. What will be the value of NB? NB belongs to a list having B and C. So for first iteration it will be B, for second iteration it will be C. Right? This is how for loop works on a list. We are iterating the elements of the list G of V, which is G of A. G of A is B and C. Right? Okay. So if NB is not visited, which is the case, both B and C are not visited, in the first iteration NB would be B. If B is not visited, so we have successfully visited A, then we have added, we are iterating over all the neighbors of A. We only have two neighbors, B and C, starting with B, and the neighbors are traversed based on the order in which they are initially defined in the G. Because this for loop will read the list sequentially. This will be the first iteration, and in second iteration NB will be C. Right? So in first iteration NB is B. This is what NB will point to. NB is B, which is not in the visited list. We will just append it in ST. So B got appended over here. After that C will got appended over here. That's it. We are done with this for loop, and we enter into the second iteration of the outer while, which is just to check whether ST is empty or not. If it is not empty, in that case again enter in the loop having V as the popped element or the last element that you have added in ST. Correct? In this case, if you pop the element from ST, it will be C. So V would be C. So if the first iteration is clear to you, I will be quick in the subsequent iteration. If V is C and V is not visited, so we won't continue. If V is visited, then only we will continue, which means that whether the node which I am currently seeing, I am seeing it for the first time or I have already seen it. If it is the first time, then visited will be 0 for that. If it is already visited, then we have already updated or added this V to the set. Okay. If not, then add C. So C will update it. This will be 1 then. If this is 1, the second is append it to the order. So A, the next will be C, and we will check all the neighbors of C. All the neighbors of C, there is only one neighbor of C, F. So F is added to ST. F is added to ST. In the next iteration, if you try to pop the last element that you have added in ST, it would be F. F will be removed, V becomes F, and we will check whether this F is visited or not. If it is not visited, make it visited. If it is not visited, make it visited and add it to order. Add it to F, right? And then we will check whether there are neighbors of this F or not which are not yet visited. The answer is no, it's the dead end. So we will go back in the stack and try to find the nodes which are not yet visited, but we have already seen them, so yet to be explored, which is B in this case. B will be popped, V becomes B, V becomes B, visited will be added, updated, this visited will be updated as 1, and then we will check whether there are neighbors of B or not. Answer is yes. D and E are neighbors of B, D and E, D and E, correct? So we will append it to ST, we'll append it to ST, D, then E, D and E, and before that we need to append this to the order. So B will also first add it in order and then ST will get updated, correct? In the next iteration, the next node that we will be exploring is the last which has got added in the stack, which is E. E will be removed, V becomes E, V becomes E. E's visited status is updated to 1, added to the set, added to orders, and finally no new neighbors of E, or there is one F but it is already visited. So the only condition when we add a new node in the stack ST is when NB is not visited. F is already visited, so we won't be updating ST. The last one will be D. Last one will be D. That's it. The last one will be D. Added to ordered, marked as 1. That's it. At this point, ST becomes empty. This while will terminate. This while will terminate and we will return the order, which is A, C, F, B, E, D, a list in this form. Clear? What it is? It is BFS. It is level order traversing. We have traversed this, then the second layer, then the third layer. Height 0, 1 and 2. This is BFS. This is BFS. BFS in graph. Why in graph? Because we are also maintaining the visited nodes. If a question comes, you need to traverse not in form of graph, in form of tree. In that case, repetitions are possible. You won't be maintaining visited set or visited map in that case. Okay? So yeah, that's it. Option 2 is right. Option 2 is right. So it is how you will be tracing these problems. Any confusion? Any confusion in this? If no, then move on to the next one. It's easy, it's not difficult. So what it says is we are using the inbuilt function. We have already discussed in this class how DEX work. DEX is like if you do not want to implement, if you want to implement a queue, it's easy to use DEC. So DEC is an inbuilt collection which internally uses a doubly linked list in order to implement these sort of data structure. You can implement doubly linked list, you can implement singly linked list, you can implement queues, you can implement stacks using DEC. But like for stacks, we prefer list over DEC, but for queue, DECs are preferred. Why? Because operation insertion, which is like a DQ and NQ operation, should be constant time operation when it comes to queue. So what it does is it stores doubly linked list like this. It stores a doubly linked list having pointers of head and tail, and this is the front. So if we want to try to implement a queue using DEC, it's very easy. Already we have pointed to front, we have pointed to tail. So NQ operation will be done from here and DQ operations are done from here. And both are constant time operations. Why? Because tail pointer we have and head pointer also we have. So DEX use internally doubly linked list. And pop left is the operation of DQ. This is the DQ operation. This is constant time, big O of 1. And pop is also, this is removing the element from the right hand side. This is also a constant time operation. Pop left is, it will remove the first element, pop will remove the last element, right? So now it becomes easy. Straight away we are defining a queue. Then S is 0. For I in range 1 to n plus 1, so it will 1 to n, q dot append I, q dot append I. Initially 0 will be there, then I is added, I is 1, I is ranging from 1 to n, I is 1. If I is 1, we are checking whether it is even or odd, If it is even, in that case we'll remove the leftmost element which is present on the left hand side from this queue and add it to S. If it is false, if it is odd, in that case we are removing the rightmost element and then updating S. Just this and return S. That's it. For this we are calling the function with value 6. So it will be 1 to 5. 1 to 6. It will be 1 to 6. In this case, when I is 1, 1, 2, 3, 4, 5 and 6. When I is 1, if I is 1 which is odd, else will execute. It will pop 1 and append. S will be S plus 1 and this is removed. Right? In the next iteration when I is 2, it will remove the leftmost element. 2 is added, it will remove leftmost element which is 0 and it gets added. After that when I is 3, so I is 2 is done. When I is 3, 3 is added in the list. If I is 3, in that case leftmost element is removed. So we will remove 2 and append it to S. For next iteration when I is 4, the rightmost element is removed, is added to the list. When I is 5, the leftmost element 3 is removed and added to the list. When I is 6, the rightmost element is removed and added to the list. It becomes 6, which is 6 plus 4, 10, 11, 12, 13, 14, 16. I think we have committed a mistake in order. 16 is not an option. It should be 15. Okay, let's go through again. Initially it's empty and S would be 0. 1 to n. When I is 1, 1 is appended to the list. Fine. When I is 1, it is appended to the list and we will pop 1, which is this, correct? This is popped. For the next iteration when I is 2, 2 is added to the list and I percent 2 is 0. We will remove 0 from the list, which is correct. 3 is added, we'll remove 3. Here is the mistake. We have added 3 is removed, not 2. One second. Let's do it again. Okay, so I is 1 to n, 1, 2, 3, 4, 5 and 6. That's it. S is initially empty and we have this Q which is having these elements. Okay, for first iteration we add it to 1 added to q, 1 is added to q, plus based on whether it is true or whether it is odd or even. In this case it is odd, so s is appended to the last element which is popped out from q, which is 1. This is fine till first iteration. Then 2 is added. If 2 is added, then we have to pop from the left hand side, so this 0 is removed and added to the list, added to s. Then for third iteration it is 3. If it is odd, then we will remove it from right hand side, it will be 3. For fourth iteration it will be 2. For fifth iteration, when I is 5, 5 is added to q, and if it is odd, then 5 is removed, it is 5, and 6 is added, and this is 4. This is 4. This is 4. Pop left. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah, this is now correct. This will be the correct order. I think in the previous we removed 6 rather than 5 from the queue. That's it. So D is the right answer. Clear? And this is what it will return, and we will print it straight away. Okay? Alright, next one. It is also not a difficult problem. A small twist, rather than just storing keys in a specific node of linked list, this stores two values, a key and a tag. So we have modified the linked list nodes structure such that now it stores a key, a tag, and the next pointer. This is key, this is tag, and this is pointer to the next node of the list, right? And when it comes to Python's perspective, it is not exactly a pointer. It is in fact the next node is stored internally inside the third part, right? But yeah, we can interchangeably use the reference of these pointers when it comes to dealing with linked lists. Okay, for instance, for this node 4a, key will be 4 and tag will be a. Okay, and then there is a pseudocode. 4 insert operations are performed. What will be the list after these insertions is what is asked in the problem. Okay, so list is like this: 4a, then 6a, 6b and 8a, and then none. None or null, both are fine. First insertion, after you trigger the insert with this 3x, key is 3, tag is x. This is key is 3 and tag is x. Okay, this is what we will refer. A new node is defined. This is our head. Current is the head, so pointer current points towards head, and a new node is defined with key as 3 and value a tag as x. A new node is defined 3x, right? Now the logic says there is a while loop. You will, and this while is incrementing the current pointer based on whether the condition is true or false. The condition is current next should not equal to null. In this case, is current next is equal to null? Answer is no. So this is true. For first case I am talking. And current dot next dot key should be less than x dot key. X dot key is 3. X dot key is 3. Current's next key is 6. So for first case, whether 3 is less than 6, no, it's other way around. Whether 6 is less than 3, answer is no. So this while won't execute for first insertion. For first insertion, this while won't execute. Okay, the next thing is new dot next should be updated to currents next. New, this is new. New dot next should be currents dot next. So this link is added. Currents next is new. This link is removed and it is pointed to new. So a new node is inserted just after 4a, which is 3x. That's it. Return head. and head is the same. Head is the same. Okay, so after first insertion, the list will look like this: 4a, 3x, 6a, 6b, 8a, and none. Is it clear? This is after first insertion. Then we have 3 more subsequent insertions. 6x, let's see, 6x, a new node is formed. This is our current. We are checking whether currents next is equal to null. No. Then currents next key should be less than x key. X key is 6 in this case. The first condition will be currents next key, which is 3. So is 3 less than 6? Answer is yes. So it will update the current pointer to current.next. We will update the current pointer. This will becomes the next current. Again the same comparison. We need to check currents next, which is 6 is less than 6. Currents next is equal to, is less than x dot key or not? Answer is no, it is not. So it will halt. It will halt. Next is to make the connection. New dot next is currents next. What it will do? It will take the new node and update it to currents next, and it will remove this pointer, point it to 6x. So the updated list will be 4a, 3x, 6x, 6a, 6b, 8a, and none. The updated list would be 4a, 3x, 6x, 6a, 6b, 8a, and none. Clear? This is after 6x, after inserting 6x. The next is, let's try to insert 10x. Let's try to insert 10x. This is easy. If the key that you are trying to insert is maximum among all of them, it will keep on incrementing this while. Why? Because every key is always less than equal to x dot key. So 10x is simple. You have to just insert towards the end of the list. Towards the end of the list. So this is easy. It will, the new list will be 4a, 3x, 6x. Why? Because the second condition is always true for a insertion having key largest among the available keys in the list. This is 10x. And finally, the last element 4b we need to insert. If you try to insert 4b, current will be 4 initially. So the check is whether currents next is less than x dot key. Whether 3 is 3 less than 4 or not. Answer is yes, it is. So current is updated to 3x. Current is updated to the second node in the list, 3x. The next check is whether 6 is less than 4. Whether 6 is less than 4. Answer is no. So the new we will take, this is 4b, add it in between 3x and 6x. That's it. The updated list will be 4a, then 3x, then 4b, then 6x, then 6a, 6b, 8a, 10x. That's it. That's it. Is it clear? So what will be the answer? What will be the answer? Option A, 1. Clear? So a slight twist, rather than, and like you can exploit the scenario that you can also compare these tags in order to find the correct position of the newly inserted element. You can have a logic to delete a specific element based on the key or tag from the list. Okay, let's see the next one. This is from double hashing two hash functions are given, and whenever two hash functions are given and the double hashing function is not given, in that case by default the hash function that you will use would be h1k plus j times h2k. It should be by default mod the size of the hash table, mod 11, the size of the hash table, if the double hashing function is not given to you. In most of the cases they will give you the double hash function, and most probably it is similar to what I have given over here. And this double hash function should take two values, the key and the probe sequence. It should take h of key and j. J is the probe sequence, such that the sequence j belongs to 0, 1 and so on till 10, because you can't go beyond the 11th probe if all are full. Clear? Okay. So using this hash function, we want to insert these keys in the hash table, and then based on like what the scenario after insertion, we have to see the options. So it will have, if I remove this, the hash table will contain 11 slots. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, one more, 10. Okay. The hash table, this is the hash table. Hash table will contain 11 slots, 0 to 9, and based on these two hash functions, we starting with inserting 10. For 10, h of 1 and h of 2. h1 of 10, what it is? It is 10 mod 11, which is 1. h2 of 10, the second hash, what it will be? It will be 10 mod 10, which is 0, plus 1, which is 1. And for calculating the final value of hash using double hashing, we will pass this k, which is 10 for the first case, and the probe sequence starting with 0. Every time we are using a double hash function, the probe sequence will always start with 0. So for 10, h will be, it is the first probe will be 1 plus 0 mod 11, which is 1, and 1 is empty. Initially the entire hash table will be empty, so it's a success. 10 is allocated to this in a single probe. Let me have probes over here. The count of probes, is only 1. In the first probe itself, we have successfully allocated 10 to the hash table. Okay, next is 21. For 21, h of 1 will be 21 mod 11, which is 10. h of 2 would be 21 mod 10, which is 1 plus 1, 2, which is 2. So for first probe, when j is 0, h will be using this function 10 plus 0 times mod 11, which will be 10, and we have already, it's not 10, it's 21. Yeah, it's 10 mod 11, which is 10. Is there a error in it? Yeah, mistake is, like, h of 1 is not 1, is 10 over here. It is 10% 11, which is 10. So this is 10, not 1. A correction. This is 10 and this is 10. So 10 will be inserted in this 10. 10 will be inserted here. Let me verify it quickly. Yeah, this is correct. 10 will be inserted in this slot. and probes are 1. In the first probe itself, we have found a correct slot for this. While inserting 21, the first probe is 10% 11, which is 10, which is not empty, We have already an element present at 10. Okay, so for that we will go with the second probe with value j as 1. In the second probe, using the same hash values, h of 1 will be same, h of 2 will be same. Why? Because these two values are independent of the probe sequence. We will calculate the new value of the slot based on k as 10 using h1 h2, using h now becomes for the second sequence 10 plus j times h2 is 2, 10 times 2 times 2, which is 4%, 11, which is 10 plus 4, 14%, 11, which is 3. It becomes 3, and 3 is available. So 21 is here. But for this, we have to search 2 times. One, a miss, second, a hit. Clear? Similarly, for 32, let's see one more. For 32, what will be the value of first hash function? 32 mod 11. 11 times 2 is 22. It is 10 more than that, so h1 is 10. And h2 for this is 32 mod 10, which is 2. 2 plus 1, 3. h2 is 3. Let's see the probe sequence. When j is 0, h of k and 0, k comma 0, which is 32 comma 0, it will be h1 times h1 plus 0 times 3 mod 11, which is 10 only. It is a miss. First is a miss. Then for j is 1, h will be 10 plus 1 times 3, which is mod 11. It will be 13% 11, which is 2. The 2 is available. So 32 is allocated here, and we required 2 probes. We needed 2 probes. Clear? Similarly, for the next one, 43, 54, like these are like let me quickly have the probe sequences for these two so that we can spend some more time in the last ones in order to get the overall answer. For 43 and 54 as well, if you go with the similar method, for 42, it will be for 43, not 42. For 43, it will be 2 probes, and the slot that will be allocated to 43 would be I think again we have made a small mistake. The mistake is over here. For 21, while calculating h of 2, it is not 10 plus 4. J is 1, not 2. So it is 10 plus 2. Which is not 3, which is 1. So it will be 21 for this. Again, the probes will be the same. Probes will be 2. And this 21 will be allocated to 43. 43 will get added over here. And after that, 54 also will be having 2 probes. Okay, you can calculate, it is not difficult. With the same way, you have to calculate h1, h2 for 43, for 54. For 131 also, let me have it. For 131, the slot will be 5. For 131, it will be 5. And the probes that are needed over here would be 4. 4 probes are required. And we can straight away go to 241 and then identify for the final insertion. For 241, h1 and h2 we need to calculate, and this is the current instance after inserting till 135. Not 135, it's 131. 130. Okay. For 241, h of 1 is 241 mod 11. 241% 11. What it will be? It will be 10. 22 and 21. Yes, it will be 10. For H2, the second hash value of this key 241 will be 1 plus k mod 10. 241 mod 10 is 1, 1 plus 1, 2. This is the scenario. This is the scenario 10 and 2. Now, for first probe sequence, when j is 0, if j is 0, what is the value of h? H is 10 mod 11, that's it. It is 10. Miss, 10 is already occupied. For j as 1, h will be 10 plus 1 times 2, which is 2. So it's 12% 11, which is 1. 1 is already occupied. So it's a miss. When j is 3. So this is how the double hashing with open addressing works. We will keep on probing. We will keep on probing until either we exhaust the slots, exhaust the total slots. We have probed 11 times for this specific key and we decided that no slot is available to assign. Then we will stop, or we will continue till we find an empty slot. For 3, h would be 10 plus 3 times 2 percent 11. What it will be? It's 16 mod 11. It's 16 mod 11, which is 5. Again, it's a miss. 131 is already present at slot 5. The next, j is 4. H is 10 plus 4 times 2. 4 times 2 is 8. 10 plus 8, 18. 18 mod 11. 18 mod 11, which is 7. Which is 7. Now it is available. 7 is empty. So 241 is allocated to this. Index 7. 241 is located to index 7. And how many probes? 0, 1, 2, 3 and 4. Total 5 probes. 5 probes are needed in order to insert the last element. That's it. If you figure it out, then all options are fine. All insertions, 241 stored at index 7, which is correct. 241 is inserted at this. Second is, while inserting a key 241, the insertion algorithm exactly 5 probes. This is also right. We have seen it. Total 5 probes are required in order to insert 241. The total number of probes performed over all insertion is 18. You can count the probes. 5 plus 9, 4, 9, 11, 13, 15, 16, 17. It is 17, not 18. It is 17, not 18. So this is incorrect. No, this one is also there. 18 is right. 5, 9, 10, 12, 14, 16, 18. 18 is correct. 18 is correct. And last, an unsuccessful search for 120 performs exactly 3 probes. This you can check. If you try to perform a search for 120, what it is? Like if you talk about inserting elements to the hash table, it involves 2 operations: insertion, deletion, and search. So insertion internally uses search in order to find the available slot, the perfect slot for a specific key. For search as well, we will use the same hash function h1 and h2 and try to find it out whether 120 is present or not. So if you go with this 120, the search in the similar manner, you will see, I have the answer for you. You will see that exactly 2 probes are required, not 3. So in the second probe itself, you will find an empty slot for 120. You can we can see that for 120, h1 will be 120 mod 11. So it's 110, 10 only. h2 is 120 mod 10 is 0, is 1. So for j is 0. Okay. First probe j is 0. H is 10 only. So it's a miss. 10 is already occupied. For j is 1. H would be 10 plus 1 times 1 mod 11. 11 mod 11, which is 0. So it's empty. So exactly this is the place where 120 will get stored or searched. So this is also this is incorrect. Not 3 probes, only 2 probes are required. Clear? Any confusion? Any confusion in this? Let me know in chat. Okay, then the next one. The following pseudocode is executed on, this is also an interesting problem, which says a BST is given to us, and if you run this pseudocode, what will be the order in which the keys are traversed? There are some complications as well, but if you successfully find the order of traversal of this binary search tree using this pseudocode, remaining are like easy only. Remaining are easy only. Okay, let's see. So for instance, I will be ignoring these two lines in the pseudocode because it is not making any difference in the order of traversal of this binary search tree. This is just additional thing that are added in options in order to find the correct set of options. Okay, first of all, we'll have BST. So creating a BST in this sequence is not difficult. You have starting with the root node 15, then 7 on the left hand side, 20 is greater than right hand side, 3 would be at this position, 9 would be over here, 18, 25, 18, 25, 5, 8. So 5 will be over here, right hand side of 3, 8 will be left hand side of 9. Then 17, 19, 22. 17 will be here, 19 will be here, 22 is left hand side of 25, and finally 24. So 24 will be right hand side of 22. Yeah, this will be your BST. This will be your BST. This will be the binary search tree, right? So if this is the BST, let's go through the pseudocode which involves two stacks. So let me tell you what exactly it is doing. We are traversing this BST level order, level by level in a zigzag fashion. How? Using two stacks. Okay, this is S1, this is S2. And initially both the stacks are empty. Two empty stacks, push S1 in root. Root is 15, 15 is pushed to S1, right? We have pushed root to 15 in S1. Then we have a label called left to right. We have a variable left to right which is true or which is 1 initially. It is boolean, either 1 or 0. You can use anything. The next is I is 1 and answer is 0. For now I am ignoring I as 1 and answer is 0. We can evaluate it later on because it is not impacting the order of traversal. The loop is while S1 is non-empty, which is not empty, so it will enter into the loop. V is equal to pop S1, removed and popped out. V is 15 now. V is 15 now. Next is if this left to right is true, which is correct 1, then left is inserted to S2, then right is inserted of this current node. So 7 is added to S2, then 20 is added to S2. That's it. 7 is added to S2. First the left node is added if it is not null, then the right node is added if it is not null, which is correct. Okay. After it, else part will not execute. The next statement is if S1 is empty, which is correct in this case, we will swap S1 and S2. We will swap S1 and S2. This becomes S2 and this becomes S1, and we will repeat the same process and update the left to right. This becomes 0 now. This becomes 0 now. That's it. This will be the scenario after the first iteration of this file. After you traverse the first node, two nodes from left to right order you have added in S2, which is now S1 because S1 is initially empty. Oh, S1 was empty after removal of the root node. Okay. In the next iteration, S1 is now having two elements, 7 and 20, so it is not empty. We will pop 20 and V is updated to 20. Now based on whether left to right is true or false. If left to right is true, in that case we are storing the elements of the next layer in this manner from left to right. If it is false, in that case we are storing from right to left. This is what these two conditions are. If left to right is false, then the rightmost element is pushed to S2 and then the left element is pushed to S2. First the right element of 20, which is 25, is pushed to S2, then 18 is pushed to S2. That's it. And if S1 is empty, which is no, S1 also has one more element 7, we will do the same thing with 7. V is now 7. V is now 7, the popped element of S2, the last element from right. V is now 7. And if left to right is true, which is no, 9 and 3 are inserted in S2. 9 and 3 are inserted and this is popped out. 7 is popped out. At this point, S1 becomes empty. If S1 is empty, swap S1 and S2. This becomes S1 and this becomes S2. And update right to left from 0 to 1. From 0 to 1. Clear? And similarly, same thing we will do with S1 now, starting from the rightmost element. Starting from this 3 is popped, assigned, we will assign this 3 to V, and based on whether right to left to right is 1 or 0, we will keep on adding the lower layer from left to right, starting from 3. So for 3, 5 will add it to S2. Now the next will popped will be 9, V is added to 9. For 9, left hand child is there, so we will add 8. The next element will be popped, which is 18. For 18, left to right, 17 and 19 will be added. Next 25, for node 25, left to right will be added. So which is only one node, 22 is added. Only one node, 22 is added. Right? Then S1 and S2 are swapped. Once S1 is empty, we have successfully removed all elements. It's time to swap both S1 and S2. This becomes S1 and this becomes S2. This becomes S1 and the second becomes S2. And if this is the case, this will be updated to 0. We will keep on traversing the last set of nodes that we want from 22. So from at this point it was traversed like this, then it was traversed like this, then it was traversed like this, now it is traversing like this. 22, 19, 17, 8 and 5. 22, 19, 17, 8 and 5. We will keep on popping from S1 and adding the subsequent nodes from left to right. From left to right. Okay. So now for 22, only one node is there, 24. We will add and just pop it out. And for all the subsequent remaining nodes, there are no childs. So just we will keep on removing, remove. Nothing is added. And in the last iteration, after swapping S1 and S2, this becomes S1, this becomes S2. The last node that will be removed will be 24. And there is no subsequent order after 24. So this is the end of the code. So can you see the traversal? Can you see the traversal order? We started with 15, then 20, then 7, 3, 9, 18, 25, 22, 19, 17, 8, 5 and 24. This will be the order of traversal. This will be the order. Make sense? Okay, so this is the order. A is correct, and then Z of root will return 1319. So this is what the Z root, which is we are returning answer, and answer is calculated answer plus I times V of key, and I is starting with 1. So what we will do, Z root is summation I times key, I starting from 1 to, you can count the total number of elements. So it is 1 times 15, 2 times 20, 3 times 7, 4 times 3 and so on, which is 1 times 15 plus 2 times 20 plus 3 times 7 and so on. You just calculate the summation, it will be 1393. It will be 1393. This is also correct. 8th visited node is 22. 1, 2, 3, 4, 5, 6, 7, 8. Correct. D is the in order traversal, is the increasing order. any BST, if it is the correct binary search tree, then order traversal will be the order in which the elements are increasing in order. In order traversal is left node, root and right node, and the property is the left node is always less than or equal to the root and greater than or equal to the root. Hello. Okay, seems it's fixed now. Yeah, can anyone confirm in chat? You can see me, you can hear me properly or not? So we're discussing this problem, and alright, so this is fine. All options are correct, and this is how you will be going ahead with this sort of problems. The last is you're given an undirected weighted graph G having vertices like this, and you need to find, it's easy, you have to just find the minimum spanning tree for this one. Okay, so idea is same, you can use any algorithm. We have two popular algorithms, Kruskal's or Prim's algorithm, in order to find MST. Okay, so we can go ahead with Kruskal. We have to define nodes, and then we will keep on taking the weights in increasing order if the adding specific weight is not adding a cycle to the MST. 2, 3, 4, then 5, 6, 7. These are the nodes, and starting with weights, the least weight is this one. You add, connect 4 with 5, cost as 1. Second is 2, we do not have, 2 we have, and 3 also we have. Connect it, it is not creating a cycle, so it's fine. This is also fine. The next is 4. We have 3 options, either 1 to 2, 1 to 2, 3, or 1 to 4. We can connect anyone, all are similar, and this will just include 1 in this tree. You can take any one, all are correct. Then for 5, we have 2 choices, either connect 3 to 4, but it will introduce a cycle 3, 5, 4, so this won't be there. 2 to 5, again it will form a cycle, so we will discard 5. This is discarded. these two weights are discarded or edges are discarded. Then 6, 5 to 7, it's fine. We have edge as 6. For that we also have a node with 4. So we will go with this 4 before exploring higher weights. We'll add 4 first. So this is fine. We have taken this. 2, 3 is fine. 5 we do not want because it is introducing a cycle. Then we have the next is 6. 5 to 7. Yeah, we will include this. That's all. All the edges are connected. So this is the MST. And the cost is 6 plus 4 10 plus 4 14 15 16 17 18 19 20. Cost is 20. You can form multiple MSTs, but the least cost will remain the same, which is 20. Okay, which is the right answer. All right. Okay, so that's it for programming and DSA. So we had total 9 problems in that. Next is calculus. So we can have a short break, a 2-minute break. Then we will resume calculus. Till now, any confusion in DSA and programming calculus, you can just ask in the chat. Okay, let's continue with the discussion. So from calculus, we had total 6 problems, weightage of 10, and more or less like for all the subjects it will be around 9-10. It will be around 9-10, like 2-3% you can increase for some of them. Okay, the first problem is a function is defined x square plus 1 by x square. We need to find this value g of 5 plus 1 by g of 5, where g is the inverse of the function, where g is its inverse. Okay, this is the first problem, and for that the tweak or the twist in this problem is you do not have to calculate the inverse of the function in order to get the answer. But since all options contain a valid either a rational or irrational number, so therefore the inverse will always exist. If in case you get similar sort of problem in which you have an option that inverse of a function is not exist, because like not for all functions its inverse exists. Inverse is only for one onto functions. If f is 1 and onto, then only f inverse will exist, otherwise f inverse will not exist. Okay, in this case it is the onto. If you calculate the range, it will be equal to codomain from 2 to infinity, which says it is onto, and it is also 1 on 1. It's an increasing function. Fx is x square plus 1 by x square. You can write it as x minus 1 by x whole square plus 2. X minus 1 by x whole square plus 2, which is always greater than equal to 0. It's an increasing function for two values of x and y. For instance, if you want to identify whether this is an increasing function or not, you can take x and y, two values, such that x is greater than y. If it is an increasing function, then f of x should also be greater than f of y. Then only it will be an increasing function. So you can prove it for all x and y which respects the scenario that x is greater than y and y is greater than equal to 1, because it's the domain. It can't be like a less than 1. If y is for two numbers x and y such that x is greater than y and y is greater than equal to 1, which is inside the domain, this will always holds. You can calculate it. This will always holds. Fx will always be greater than fxy. Okay, because x is greater than y. If x is greater than y, in that case x minus 1 by x will be greater than y minus 1 by y, right? Therefore it is an increasing function. Okay, but yeah, this point is just to like prove that it is a 1 and onto function. Therefore its inverse exists. It is an invertible function. Okay, when it comes to the value this, so we can say that right, if you take a value a such that it is equal to g of 5, we can evaluate without calculating its inverse. If you say a is equal to g of 5, I can write it as, if we take inverse from both sides, if x to y is a mapping in this function, then y to x will be a mapping, it's an inverse, right? Makes sense? So I can say that f of a is equal to 5. I can say that f of a is equal to 5. Yes or no? If a is an arbitrary constant whose value is equal to g of 5, I can say that f of a is equal to 5 because g is f inverse. Because g is f inverse, right? I can say this. Any confusion in this? Any confusion in this? If g is f inverse x, I can say, let's assume the value of g of 5 is a. I can say f of a is 5. Yes or no? So if this is true, the value, what is the value of f of a? F of a is a square plus 1 by a square. If this is true, from this equation I can say that a square plus 1 by a square is equal to 5. Yes or no? I can say that a square plus 1 by a square is equal to 5 because f of a, I've just updated the value of x, I've just replaced or assigned x as a and get the equation. This is what already given in the problem. Clear? And a plus 1 by a whole square If I calculate this whole square, it is a square plus 1 by a square plus 2. A square plus 1 by a square plus 2. And we already know the value of a square plus 1 by a square. This is already known to us. This is already known to us, which is 5. So I can put it over here to get 7. A plus 1 by a whole square is 7. From this, what it is? The left hand side. Left hand side, it is the square root of the equation whose values we need to find. A is g of 5. 1 by a is 1 by g of 5. I can take square root from both sides. It will give me a plus 1 by a, which is square root of 7. It can't be minus square root of 7. Why? Because a should be positive. A should be positive. Range is 1 to domain is 1 to infinite, range is 2 to infinite. For inverse, it's a 1 1 onto function. Inverse, the domain will be 2 to infinity and the range will be 1 to infinite. So all positive numbers greater than or equal to 2 will be the domain of the inverse. Therefore, square root of minus square root of 7 won't be there. So only positive square root. This is what the answer is. A plus 1 by a. A is g5. A is g of 5. Okay. So it's option A. Clear? Any confusion in this? Alright. Easy only. But just you need to take care the functions which you are dealing with should be invertible. If it is not invertible, in that case you can't find the value. The next is easy. It's limit 1 over infinite. So it's the standard limit. If you see a limit 1 over infinite, it is of the form 1 over infinity. 10x by x, limit x tending towards 0 is 1, and this is 1 by 0, which is infinite. We take log both sides. Log L would be, it will be below log of or you can have log limit x tending towards 0. This 1 by 1 minus cos x will be down, so it becomes 10 x by x whole divided by 1 by 1 minus cos x, which evaluates to 10x times 1 minus cos x by x limit x, and you can include this log and limit x tending towards 0. It's just an evaluation. Now it becomes easy to find the limit. Either you can use L'Hopital, it is 0 by 0 form. Either you can use L'Hopital or you can also use Taylor series expansion. If you remember the Taylor series expansion, it will be good. At least you should remember Taylor series expansion of 10x, sin x and cos x. This is must. It becomes these limits become so easy if you just know these expansions. For instance, if we add the Taylor series expansion, it will be like this. For 10x, the expansion is, I have the expansion, it's x plus x cube by 3 plus a polynomial having degree greater than or equal to 5. So that's it. It is sufficient. That's it. 1 minus cos x. For cos x, the expansion is, for cos x, the expansion is 1 minus x square by 4 plus a polynomial with degree greater than or equal to 5. So 1 minus cos x, you can take everything towards it on the left hand side and it will give you 1 minus cos x. For 1 minus cos x, it will be x square by 4 plus a polynomial having degree greater than or equal to 4 divided by x divided by x divided by x. Okay, is it clear? Any confusion? Any confusion over here? Any confusion in this? In fact, it is not 1 by 1. It will be 1 minus cos x. A small correction. It will be like this. it will be in denominator. It will be like this: x times x square by 4 minus big of x to the power 4. Okay, and it's now easy. You can just simplify. It will, x will be removed, and you will get two terms. First is this and this. This is the important terms. It will be x cube by 3, 1 by 3, and all other limits will equate it to 0. All other limits will equate it to 0, and you will just left with x to the power 3 by 3 plus some polynomial divided by x to the power, it's x square by 4 with some polynomial. 4 not, it's 2. It's 2. Okay, and if you evaluate and put limit x tending towards 0, it will be 2 by 3. It will be 2 by 3. This is log of L, becomes 2 by 3. So L would be e to the power 2 by 3. That's it. P. Other way around, go with Taylor series expansion. Like not Taylor series, go with L'Hopital. It will also give you. And you can also have 1 minus cos x divided by x square multiplied by x square. It is 1 by 2. In that way, you can simplify these limits. It is not that difficult. Clear? Any confusion? Okay, let's move on to the next one. This is y is equal to x plus e to the power x is given. Equation is given to you. You need to find d2x by dy square. You need to find this. It is not equal to d2y by dx square. This is easier to calculate. This you need to check based on the equation. Okay, let's see. So we have this y, which is x plus e to the power x. Can we differentiate it with respect to x? Answer is yes, we can. This will give us dy by dx, which is 1 plus e to the power x. 1 plus e to the power x, right? From this, I can take reciprocal because we need to find d2x by dy square. So dx by dy, we will just inverse the entire equation. It will be 1 divided by 1 plus e to the power x. Now can we differentiate it with respect to y? Answer is yes, we can. Differentiating with respect to y. Left hand side will be d2x by dy square. This is what we need to find, and right hand side will be 1 divided by 1 plus e to the power x. It is a function in x. It is a function in x. D of d by dy 1 by e to the power x plus 1. Can I multiply it with dx and divide it by dx? And then differentiate it with respect to x by putting dy over there. This is equivalent of differentiating this function 1 by 1 plus e to the power x with respect to x, multiplying it by dx by dy. It is equivalent, right? I can do that. It's just the basic chain rule. And if this is the case, it is just differential of 1 plus e to the power x minus 1. This will simplify to minus 1 upon 1 plus e to the power x whole square times dx by dy. Dx by dy we already have, which is 1 by e to the power x. 1 by 1 plus e to the power x. So it is equal to minus 1 divided by 1 plus e to the power x whole cube. That's it. That's it. Clear? Plus e to the power x. Because if you differentiate it with the chain rule, e to the power x differential will be e to the power x. Yeah, this is correct. Okay. And then just evaluate and get the answer. For ln2 we need to put x as ln2 and get the solution. For x, so d2x by dy square for x as ln2, it will be minus 2 divided by 1 plus 2, 3, 3 to the power 3, 27. Minus 2 by 27. B. Okay? Any confusion? Any confusion in this? Easy only. The small twist. It is not regular d2y by dx square. It is dx square by dy square. So find first derivative with respect to x. Reciprocal it. It is a function in x. Differentiate it with respect to y. And then using chain rule, you have to differentiate it with respect to x, multiplying it by dx by dy. That's it. Okay? Alright. Let's move on to the next one. A function is given, a piecewise function involving some trigonometric functions is given to you, and it's also known that it's continuous at x is 0. If it is continuous at x is 0, the left hand limit should be equal to the right hand limit, should be equal to the value of function at x is 0, which is 3. So that's it. We will just exploit this fact and find the values of a, b, c and d for this case. Okay, the left hand limit should be equal to 3 and it should be equal to the right hand limit. That's it. So let's see the left hand limit. Limit x tending towards 0 minus from negative side. This is the function f of x, which is equal to limit x going to 0 a times 1 minus sin x plus b cos x plus 5 divided by x square divided by x square. Again, at this point, you can do the same function with L'Hopital and you can also do the same function with Taylor series expansion. Expand for sin x, expand for cos x and see what are the powers which are less than x square. That should always be 0. The coefficient of this expression after expansion which is having a degree less than x square, which is having a degree less than 2, should always be 0. Otherwise, limit won't exist. Okay. So if this is the case, having the Taylor series expansion of sin x and cos x, I can straight away write this expression like this. It will be equal to a plus b minus 5 plus 5 plus minus a minus b by 2 times x square plus a polynomial having degree 4 divided by x square. This is what it will evaluate to, and you have a limit over x tending towards 0. X tending towards 0. It is like this, right? And if this is the case, it should be 0, it should be 0, otherwise limit won't exist, right? So we have two equations from this. A plus b plus 5 should be 0 and a should be equal to minus b by 2. Equation 1, equation 2. Solve it and get the value of a and b. Solve it, get the value of a and b. From this, no, it is not the case. One quick correction. Yeah, the second term having the coefficient as x square, so it will get cancelled if you divide it like this. This x square will be cancelled with this x square. So second coefficient won't be 0. It is in fact equal to the actual limit value. In fact, it is equal to the limit's value. So second coefficient is what? Minus a minus b by 2 will give you 3. Why? Because if this is 0 and all other powers greater than x square will anyway be 0, since you are dividing it the entire equation with x square. So the coefficient having the degree as x square should be equal to the limit of the function, which is 3. Okay, so these are two equations. Solve it and get a and b. Solve it and get a and b. Clear? Make sense? Solve it and get a and b. So solving it, you will get a as minus 1 and b as minus 4. A and b as minus 1 and minus 4. Okay. Next part, you see this, the right hand limit. For right hand limit, this is left hand limit. Now right hand limit. Again, using a very basic analysis, we can see that it is of the form 1 to the power infinity when x is 0. It is 1 to the power infinity. So we have limit x going towards 0, 1 plus c, and to hold this scenario 1 to the power infinity, this term should be 0. Yes or no? This term should be 0. This is cx divided by x square, c by x plus dx cube by x square. It is like this. It is like this. 1 by x. Okay, so to hold this to be a form of 1 to the power infinity, c should always be 0. This should always be 0. Otherwise, it will be infinity by infinity. Limit doesn't exist in that case. In that case, limit doesn't exist. So c should always be 0. Is that clear? Why c should be 0? Because if c is not 0, in that case, limit will not exist. You take any value of c, limit will not exist. And it is already given in the question that it is continuous at x is 0. So limit should be equal to 3. Limit should be equal to 3. Okay? And if c is 0, what should be the value of d? What should be the value of d? We'll be calculating by equating it with 3. Taking log at both sides. If you take log at both sides, it will give you 1 by x times 1 plus dx, 1 by x plus 1 plus dx equal to ln 3, because the limit is equal to 3, equal to ln 3. Right hand limit is also equal to 3. I have taken this condition. Right hand limit is equal to 3 and take log both sides. It will give you the value of d. Clear? So from that, the value of d that we will get is ln 3, and c is 0. These are c's and d's. These are c's and d's. Okay, make sense? So a is minus 4, a is minus 1, b is minus 4, c is 0, and d is ln 3. Based on this, a plus c, what will the value of a plus c? Minus 1 and 0, minus 1. A is correct. B plus c, b is minus 4 and c is 0, minus 4. It is also correct. A plus b, a is minus 4, b is minus, it is minus 5, correct. And c plus d is an irrational number. ln 3 is irrational number. All options are correct. All options are correct. Right? Any confusion? Any confusion in this? Any confusion? If no, let's move on to the next. Okay, if let f be a differentiable function satisfying f dash x is equal to f dash minus x. So f is a differentiable function and first derivative is in fact even function. This condition only holds for even functions. When f of x is equal to f of minus x, the function should be even or symmetric across y-axis for all x's. Okay? Alright, then there are certain options. We need to find which option is correct given it is differentiable and the first derivative is even. So if the first derivative is even, can I say if the first derivative is even, if dy by dx is even, can I say that f, which is y, is odd? Can I say that it is odd plus some constant? It is a odd polynomial, not polynomial, it is an odd function with some constant. For instance, you can have a scenario that let's assume f of x is x cube plus some constant 5. In this case, if you derive the first derivative, it will be 3x square, which is in fact even. This constant, the derivative will be 0. Odd functions derivative would be even. Make sense? Taking this into consideration, we can answer the following options because this is satisfying the condition which is given to us. Or if not, we can tweak these polynomials or constants in order to see which option is correct or not. That's it. So if f of 1 is equal to f of 2, then f of minus 1 is equal to f of minus 2. Can we have a scenario which satisfies option A? If f of 1 is equal to f of 2, if you try to put f of 1 over here, which is not the case, if f of 1 is equal to f of 2, which is function is independent of the value which we are passing in this function, can we come up with a scenario where this holds? If I assume f, keeping this mind that the first derivative is always even, can I have a constant function? Can I have a constant function? Can I have a constant function such that f dash x, which is 0, 0 is equal to 0, makes sense, satisfies the criteria for all real numbers, fx is equal to constant. So this is equal to that constant only, and f of minus 1 is also equal to f of minus. This is correct. This function holds that. This function ensures that this is correct. Okay. So A is right. I can come up with a function, a constant function, which satisfies the criteria and holds option A. Second is, can I come up with a function such that this equation holds? Such that this equation holds? Answer is no, I can't. You can take any function, either a constant or a basic polynomial having odd degree. This won't hold true. Why? Let's assume this is a function which is 1 by 2 times fx. Fx is x cube plus 5 plus 1 by 2 y cube plus 5. This is not equal to f of x plus y by 2. F of x plus y will be x plus y whole cube 1 by 2 plus 5. This is not equivalent. So we have a counter example which is not satisfying option 2. Option B is incorrect. Okay. Third option, if f is even, then fx is 0 for all x belongs to R. If f is even, in fact f is not even. If it is not even, then it should be f of 0 for all R. Answer is, what should be the value for option C? What should be the value of option C? If f is even, then fx is 0. F is not even, in fact f is odd. F dash is even. So this is the first line, is it's itself incorrect. Okay. And finally, the last one, fx plus f minus x is 2 times f0 for all x belongs to R. Fx, for this case we can see, if it is odd, then f of x plus f of minus x, this is equal to x cube plus 5 minus x cube plus 5, which is 2 times f of 0. This is correct. This is correct. You won't be able to find the counter example which invalidates option 4, f of x plus. Why? Because if f dash is even, then f will be an odd function plus some constant. This odd part will be different, will be separate from a constant which we are using to define that function. And this odd part will always be some function of x. This will be a function of x. And if you put g as 0, the only thing left is c. Either it is minus x or plus x. C will be there. So it adds up 2 times in the final sum, where you add f of x with f of minus x. Odd part will cancel out every time, and c will integrate. It's 2 times c. 2 times c. Make sense? You won't be able to find a counter example to like invalidate option 4. Okay. Next is a canonical vessel. This is like a optimization problem in which, like single variable optimization, a canonical vessel is to be prepared out of a circular sheet of metal of unit radius. For the vessel to have maximum volume, the sectorial area removed from the sheet is A1. Okay, you have a circular sheet. The backdrop is, you have a circular sheet. In that sheet, you remove a specific area. Now the remaining area, let's assume it is angle theta. It is 2 pi minus theta. After removing this sector, this is what is left. This is what is left. Now this is taken and formed a cone. This is taken and formed a cone. The sectorial area removed from the sheet is A1 and the area of the sheet is A2. Okay. A2 by A1 is equal to m plus square root of n. Find value of m plus n. Alright. What we are doing here is a sector is removed and the remaining sheet, a cone is formed, and the area of that sheet is maximized. The volume is maximized of that cone. For that maximum volume, what will be the ratio of A2 by A1, where A2 is the area of the original circular sheet and A2 is the sectorial area removed from the sheet. Okay. So it is already given that the sheet is having a unit radius. So A2 is straight away. A2 is straight away. What is the area? Pi r square. R is 1. It's given. So it becomes pi. A2 is pi. A2 is pi. For A1, we need to calculate what will be the value of A1 in this case. Okay. Let's assume that the removed sector, the area of the removed sector angle is pi radian, right? So the remaining sector, we are now calculating what should be the value of A1 so that we can find m plus root n. For the remaining sector, what will be the angle? It will be 2 pi minus theta. It will be 2 pi minus theta. If I remove this theta, the remaining sector would be 2 pi minus theta, and this is what is used to form the cone. This is what is used to form a cone. Now a specific observation: if I take this and form a cone, the cone has three properties. First is the radius of the lower circle, the radius of the circular ring, height of the cone, and the slant height. In this case, the slant height is exactly equal to the radius of the unit circle. This is the slant height of the radius. If I take this and form a cone, this is what the slant height will be. Slant height of the cone will be r, which is given to us 1, right? And let us assume that small r is the radius of base, of the cone. And the second observation is the circumference of this. The circumference of this is equal to the total remaining length of the sector. The circumference is equal to the remaining length of the sector. That's it. And based on that, I can calculate height. Why? Because we need to maximize the volume. A volume of the cone. The volume of a cone is 1 by 3 pi r square h. R is this, h is this, which is equal to 1 by 3 pi r square. And what is h? H is, like, we can apply the Pythagoras theorem from here. H square plus r square is equal to 1. Therefore, h is 1 minus r square root. This is what h is, 1 minus r square. This will be the volume of the cone. This will be the volume of the cone. This is what we need to maximize. To maximize this, idea is same. You take the first derivative and make it to 0. You take, this is v, have dv by dr and equate it to 0. Differentiate this with respect to r, and this is an easy differentiation. I already have the final answer for this. From this differentiation, what the r you will get, which is having the maximum volume, and you can prove it by taking the second derivative and putting the value of r, which we are getting after equating the first derivative to 0, which is the critical point. It will be less than 0. It will be less than 0. So the r that comes to be 2 by root. R square is 2 by 3. R square is 2 by 3. So r is square root of 2 by 3. This is what the radius of the cone, such that the volume is maximized. Okay. And once we have it, the second part is not that difficult. It is just A2 by A1. It is just A2 by A1. Now we need to find A2 by A1, which is A2 is already pi. What is A1? If you find the radius, A1 is the sectorial area removed from the sheet. What is A1? Sectorial area removed from the sheet. What is the value of A1? Anyone? A1 is, radius is 1 and we can also have the relation between this and r. So 2 pi minus theta, 2 pi minus theta is equal to r, which is 2 by 3 in this case. So we can find the theta, which is 2 pi minus 2 by root 3. 2 pi minus 2 by root 3. Okay. So anyone want to chip in? What should be the value of A1? What should be the value of A1 such that A2 by A1 becomes m plus square root of n? Anyone? Can anyone quickly give me the answer? It is the area of the sector, right? It is the area of the remaining sector. A1 is the area of the sector, right? So which is 2 pi 1 minus r, right? Which is 2 pi 1 minus r. So this will give you this, pi can be removed, 1 by 2 1 minus r. This is equivalent to, this is again 2 pi. 1 second, a confusion over here. This is fine. A2 would be pi. This is okay. What will be the value of A1? 1 second. It's pi 1 minus r. Pi 1 minus r. It's pi 1 minus r. It's theta by 360 into pi r square. Pi is cancelled, r is cancelled, which is theta r by 2. Theta here will be 2 pi minus 2 by 3 square root of. So this becomes theta by 360, 2 pi minus 2 by root 3 by 360, which is 2 pi into pi. Are we making a mistake over here? Give me a minute. This is A2 by A1. The sectorial area removed from a sheet is A1. And this is the area. Area of a sector is theta by 2 pi into r square. Which is 1. So therefore it becomes pi divided by theta by 2 pi. Theta by 2 pi. And theta is 2 pi by 2 pi would be this by 2 pi. 1 minus r. Are you making a mistake over here? Give me a minute. It is coming 2 pi. It should be 1 minus r. It will be 2 pi 1 minus r. Right. It will be pi divided by pi 1 minus r. Correct. Right. This is fine. So this will be 1 divided by 1 minus r, and we already know what is the radius of the cone, optimal cone having maximum volume over here, which is equal to 2 by root 3. We just put over here to calculate 1 divided by 1 minus 2 by 3 square root. We will multiply 1 plus 2 by 3, 1 plus 2 by 3. It is 1 minus 2 by 3, which is 1 by 3. So this will be 1 plus 2 by 3 square root times 3. That's it, which is 3 plus 3 times 2 by 3 square root. Yeah, and square root 3 can be cancelled out. It will be 3 plus square root of 6. 3 plus square root of 6. And this is what the desired A2 by A1 is, m plus square root of n. M is 3, n is 6. So I guess it's 9. It's 9. Okay, this is 9. Any confusion? So I think we only had 6 questions in calculus. Yeah, we only had 6 questions in calculus. Then the next is AI. Let's have a short break. We'll resume AI after that. Okay. All right. So let's resume with the discussion of AI problems. In AI, we had total 7 questions, 4 2 marks, 3 1 mark, and total weightage was 11. AI was mixed, sort of like few easy questions, few really good problems. Starting with the first one, this is a easier problem. It's MCQ 1 mark, and in this a graph is given, and we need to find the order in which UCS and BFS will traverse, starting with the start state S state and reaching the goal state. In case of BFS, we won't be using the weights which are given in the problem. It will be all weights will be having, all edges will be having same weight as one, and then we will evaluate the order in which it will execute. But for UCS, this, yes, the cost is required in order to check whether which node we need to explore based on the least cost that is available among the next nodes. Okay, so BFS is easy. So this is like this S, and again you don't even need to know the shortest path. If I remove all the weights and assign, we need to find the shortest number of hops that we are required to reach G from S. It will be always like this. You can't have a path starting from S going to G less than 3 steps. Less than 3 steps. We can have 1 2 3. We can have 3, but there is one more point which is present in the problem, which is the ties are broken in alphabetical order. So if you have an option to explore the next node from S, you have two options, A or B. The tie will be broken having least alphabetical order, which is A will be explored first, then B. So if you are at S, this is the first step that we will take. If we are at S, among C and D, C will be the first step that we will take. Why? Because the condition is given to us. And if we are C, there is only one path, go to G and halt the search. So ASACG is correct for BFS. This is right. And for UCS, we need to like have a priority queue, proper priority queue. Starting with the first node, S0 will be present initially, and based on S0 we have two paths. Either you can go to A or you can go to B. We'll remove it from the queue. So A of 2 will be added and B of 1 will be added to the queue. Right. Now we have two options. Either from S you can go to A or you can go to B. Either from S you can go to A or go to B. What we will be exploring? We will explore B first. Why? Because it is having the least cost. B will be explored next with cost as 1. Okay. So if B is explored, then the next set of nodes that we're going to be adding is from B. The current cost is 1. I can either go to D or I can go to E. If I go to D, the total cost would be D, comma 2. D, comma 2. One, the cost from S to B, and second is B to D. If I go from B to E, the total cost would be 1 plus 5, which is 6. These will be added in the queue. E, comma 6. Right? So these two nodes D, E will be added to the queue. Next, which node should be explored next based on the priorities? So we have a tie over here. A, comma 2 can be explored or D can be explored, both having cost as 2. But the frontier will be broken by alphabetical order. It will prioritize A over D because A is less than D. A comes before D in alphabetical order. So this is what the next node is explored. A with cost as 2. A with cost as 2. From A, you have two options. Either we can go to C or we can go to D. I'm continuing the list over here. Yeah. If I add C, the cost will be 4. If I explore, the cost will be 4. And if I explore D, the cost will be A to D. Again 4. Again 4. Okay, this will be the scenario. From A, I can add C and D both to the queue. C4, and one more important thing, two nodes D having different cost can be simultaneously present in the priority queue. Okay, all right. Then the next one, the next that will be removed from the queue would be having least cost d comma 2. Then the next is d comma 2 is explored. From d I can go to g, that's it. I can go to g, but the cost is 10 plus 2, 12. The cost is 10 plus 12. Okay, and this is removed from the queue. Next is c, having least, c and d both having least cost, but c is like the lower alphabetical order from d. Next would be c, 4. Next would be c and 4. Okay, from c I can straight away go to g, which is one more node g with cost as 4 plus 2. 6 is added in the queue. 6 is added in the queue, and this is removed. The next one is e, g. There's a type, no, d will explode first. D comma 4 will remove d, and from d I can go to g, but 4 plus the cost, new node g, 4 plus 10, 14 will be added in the queue. This is the queue. I'm continuing the queue over here. This is what it is added. Next is e and g. E will be explored first. E will be explored first. If I remove e, same alphabetical order, I can have g comma 7 as a node. Then among all possible scenarios, g12, g6, g14, g7, this is the one I will take. This is the one I will take, which is gc. This is the one I will take, gc, and this is the goal. That's it, the search will stop. And this is the node which is coming from c. This is the node which is coming from g. You can see the cost is, total cost is 6. If the cost is 6, the cost can only come to 6 if you take this path. 2 plus 2 plus 2, that's it. For any other path, the cost will be greater than 6. So it won't be the optimal cost. But UCS always ensures that it is the optimal cost. So this is the correct sequence of the traversal. This is not the sequence in which the nodes are explored. This is the final solution. It will return the final optimal solution, and this is correct. There are multiple solutions. You can go to G in cost 12, we can go to G in cost 7, we can go to G in cost 7, but they are suboptimal paths. Okay, so this is how UCS works, and this is how priority queue works. So answer option A is right answer for this problem. Next, this is also easy problem. Most of the points we have already covered in class, which says a weighted A star uses evaluation function as this, and evaluation function is, it is the cost function. The cost function in A star, the cost function that is used is Fn is equal to Gn plus h of n, where h is the heuristic. But in weighted A star, there is a weight associated with the heuristic, Gn plus w times hn. This weight, there is a weight associated with this, and based on this value of w, if h is admissible, if this h is admissible and I take a value less than equal to less than 1, in that case the w A star will always be optimal. For an admissible heuristic, if the weight is less than 1, why? Because a weight which is less than 1 is reducing the overall value of this. So anyway, h is an admissible heuristic, it is then underestimate its value, and all underestimations are always admissible, right? So this will be an optimal algorithm if w is greater than 1. But if w is less than 1, but if w is greater than 1, in that case this is beyond our control. We do not know what the value of w I am using, even for the admissible heuristics. Even for admissible heuristics, we might get a cost function which is suboptimal. This is important. This is important, and this is the overall point. If you know, then you can easily answer the question, where Gn is the path cost from start to n and Hn is the heuristic estimate, and W is greater than 1. If W is greater than 1, then whether it is admissible or not, you can't commit based on whether this will underestimate or overestimate the cost. It will definitely, it might overestimate, so there is no certainty when it comes to having the optimal cost function. Okay, then the options. If H is admissible, okay, W A star always optimal for any W greater than, no, it won't. It won't. For a very large W, say W as 10 to the power 3, you take any admissible heuristic, it will always overestimate. And if it is overestimating, then it will reach to a goal state in from a suboptimal path. Okay. So this is incorrect. Option A is not correct. Second, W A star is complete for any fixed W grid. For completeness, yes, it is complete. What completeness says is whether I will reach the goal state or not. Answer is yes, you will reach. It is just an estimation. It is just giving you an estimate which is far, far, far more than the optimal cost. Okay. So for completeness, it is correct. For completeness, it is correct. Why? Because these two assumptions are also hold. All step costs are positive and branching factor is finite. If these two conditions hold, then you will anyway get to the goal state or the solution. But it will be suboptimal. So option B is not doesn't talk about the optimality. It just, can I reach the goal state? Answer is yes, you can. C is if H is admissible. Return cost, this is also correct. The return cost can't exceed W times the optimal cost. For any W, irrespective of what the value of W is, it can't exceed. If it is less than if W is less than C, if W is less than 1, in that case, what will be the value of optimal cost? C will always be equal to W times, C will always be equal to the C star. This equality will hold. But in other case, it won't be, like, it can't exceed weight times the optimal cost. We have proved this point in the class itself. So C is right. Option D, if H is consistent, W A star never reopens a closed node. Consistency doesn't deal with reopening of nodes. Consistency is a more stricter criteria over the optimality of the algorithm. If H is consistent, then you can't have no edge overestimating in your search space. So this is not related to opening or reopening of the closed nodes. So that's why this is also incorrect. So correct options are B and C. Correct options are B and C. Okay. All right. Next is, this is also an easy problem, and just by seeing the diagram, you can choose the correct option. Two scenarios are given. And a situation is given such that this is the starting state and this is the goal state. This is the starting state, this is the goal state, and you want to reach to the goal state from starting state using these operations. Using these standard operations, then how many operations are required in order to reach to this goal state? Okay, and you can easily form a search space, you can form a graph starting from this state and try to explore various operations that are possible in this snapshot, in this instance, in order to reach to the goal state. And like logically also you can do it. It is just, you need to place this B over C, and then you need to not C over D. You need to place this B over D, and then this C over A. So total 2 operations, but if you try to go and do these 2 operations using these functionalities, it will take 4 operations. The first is to unstack B and A. Second is to stack B over D. Third is to move to pick C, and fourth is to put it over A. You will need, because we can only perform like these operations: pick up, put down, unstack, and stack. Based on that, it is not a difficult problem, it's on the easier side only. Okay, based on option, any valid plan must begin with unstack. Any valid plan should begin with unstack. Answer is no. You can stack as well. You can move these operations C and D. You can pick C, you can pick D, you can put C down, you can put D also down. You can start from the goal state even if you do not perform this. This is incorrect. You can reach to the goal state even if you do not start with unstacking. Second is, there exists a valid plan of length 3 actions. No, it is not. There exists a valid plan for 4 actions. So B is incorrect, C is right. D is there exist, and it's a single correct. So C is the only correct option. There exists an optimal plan in which stack CA is executed before stack BD. Stack CA, no it can't. No it can't. This is also incorrect. It can't. First you have to stack C and then you have to stack B. This is a like easy problem only. Okay. All right. Next, this is also not a difficult one, but if you know how alpha beta pruning works, it will be a very easy problem for you. But if you do not know, in that case, you will struggle with this problem. So alpha beta is just an enhancement on the standard minimax, but the idea remains the same. So I will be quick in explaining what will be the scenario if you apply alpha beta two-player zero-sum game on this search space starting from the root node. These are max nodes. These are max. These are mins. Again, these are max. Okay. So the overall idea or the intuition behind alpha beta pruning is, if I am sure, if I can decide based on the current information that I have that I want to explore the remaining set of nodes or not. If I am certain about it, in that case, I will prune the remaining part of the search tree. That's it. Okay, starting with this max node. This is the max node. It will first explore 4. It will first explore 4. And this is the max node. So the idea of a max node is it want the child node which is having the maximum value. So if it goes to the last leaf node and sees that its value is 4 and it is transmitted to its parent, so it should be, the max node is always interested in the remaining nodes whose value is greater than or equal to the maximum till the maximum value which has already find till now. In this case it is 4, so it will be interested in values greater than or equal to 4. It will be interested in that, but the second node is unexplored. It can be greater than 4, it can be less than 4. In this case it is less than 4, but it will be explored in order to have the certainty that it has chosen the maximum of the available children. Okay, now if the value 4 is allocated, it becomes 4. We will go to search the right hand side of this tree. We'll go to search the right hand side, but with an information that from left hand side I already know that it will always return 4. So this mid node will be interested on the right hand side if it is giving me a cost which is less than 4. If it is greater than 4, then it will be ignored, but at this point we do not know. Okay, now let's see. So this min should be interested in less than equal to 4. For now it is interested in a value less than equal to 4. If from right hand side I am getting a value which is less than 4, it's okay. If not, in that case we'll go with 4 because it is a min node. Alright, now if I am here, I will explore 6. This is a max node, so this node is interested for values greater than equal to 6. This value is interested in value greater than equal to 6. If I know that the parent has already got a minimum value which is 4, will it be interested in taking 6 because the child is a max node? This is what this is where exactly the pruning starts. Exactly at this point the pruning starts. What it says, I am a max node. From that max node I am getting a value 6. I already have an information from my parent that he already have a path having a cost as 4, and I know that my parent is min. Will this min be interested in exploring the subsequent remaining branches of this max node which is 6? Answer is no. This is alpha for this node 6, and when alpha becomes greater than equal to beta is 4, the pruning starts. This is the pruning condition, and this part will chop off. This 2 won't get executed. Why? Because I don't care. I don't care. There can be only 2 scenarios at this point. This value 2 either can be greater than 6 or it can be less than 6. In both of the cases, it becomes irrelevant. Why? Because search won't come this side. Search won't come this side. Why? Because there is already a number which is greater than the current minimum. So min node won't be considering this. This is what like overall crux of alpha beta is. At any point, if a node is able to decide that which path it will take, it will always go with that and chop off the remaining nodes. Make sense? Okay, so this is the node that will be pruned, which is 2, and similarly you can compute this 4 will be transmitted to the head from this side, then this will be explored and this will be explored. Let me have one more exploration. If I'm here and I go here, I see 2. This is a max node. It is interested in value greater than or equal to 2, and the parent is also a max node, but this is a min node. This node wants minimum of all 3 nodes. This node wants minimum of all 3 nodes. So I am here, but at this point I do not know whether 2, which is the minimum value, 2 or 1. First I will explore 2. This is the max node. Then I will explore 1. It is less than 2, so we'll go ahead with 2. We'll go ahead with 2. From here, the information that is circulated to the min node is 2. So this node is only interested in values which are less than or equal to 2. At any point, if we find that the maximum value or the alpha of the child is becoming greater than beta of the parent, in that case it will prune off. That's it. It will prune off. Is it clear? Is it clear? And this is exactly what the pruning criteria is. From parent, from this max node, the value 4 is already coming. So it should be, it's a max node. It should be greater than or equal to 4. It should be greater than or equal to 4. But just after exploring the starting 2 nodes of the left hand side of the min node, it says that it will always give you less than or equal to 2. The best possible case will be 2 in this case. Why? Because it's a min node. All the nodes which are greater than 2 is not even considered. Why? Because it is a min node. And there is already a path which is having a cost greater than 2 from this side to this parent. So why it will continue the search? It will prune off. It will prune off. And this is exactly the condition. This condition was alpha beta condition for max min node. This condition is for min max node. In this case 4 is greater than or equal to 2. This is my alpha coming from parent. This is my current beta coming from my child. And if this condition holds, in that case it is pruned off. The remaining search is called off. This will be called off. Why? Because there is already a path 4. So it will be interested in either path 4 or a path which is greater than 4. That's it. So this 9, 5, 3, 1 won't get explored, including these internal nodes. Right? And similarly, you can go towards the right hand side, and if you calculate, we will be exploring this 5, this 4 and this 7. This last 5 will be pruned off. Last 5 will be pruned off. Okay, and you can have the similar argument on the rightmost side of this tree. Okay, then the options, the minimax value at the root is 5. It will be 5. It will come from here. It will come from here. If you solve the rightmost section, it will come from here. So this is correct. This is correct. Then second, the minimum value, the minimax value of the min child is 2. Yes, it is 2. We have calculated. This is the 2 that it will circulate. This is correct. So with left to right, depth first, alpha beta pruning, the number of leaves evaluation is 8. We can count the leaf evaluation 1, 2, 3, 4, 5, 6, 7, 8. Correct. C is also right. Total leaves that will be evaluated are 8, and number of leaves that will be pruned will be 2. Like 1, 2, 3, 4, 5, 6. So 6 will be pruned. and 8 will be explored. And similarly, you can also count the internal nodes that will be pruned or explored. The last one, the pruned leaf utilities are exactly this. This is incorrect. 4 is incorrect. 4 is we are exploring 4. It should be 5. So D is incorrect. The pruned nodes are 2, 9, 5, 3, 1 and 5. The last one will be pruned off. Okay, that's it. So this is like what alpha beta pruning is all about. Clear? Next problem. Let the first order domain non-empty. Okay. So certain combination of predicate and propositional logics are given to you, and it's given that it's the knowledge base which is true, and out of these 4 options it's a multi-correct. Which property or which proposition I can infer based on the knowledge base? Assuming this knowledge base is true, can I say that this will also hold? That's it. Okay, so starting from the first one, if I am assuming knowledge base is true, can I say that P implies R? P implies R is true. P implies R. Can I say? Yes, I can, because fourth point of this knowledge base is not R implies not P. Not R implies not P is given as true to us. If this is true, the first option is the counter positive of this. Contra positive. This is contra positive. This is correct. Okay, so option A is correct. Why? Because that straight away it's like the fourth option, the fourth point is not R implies not P. The contra positive is P implies R, which is this, which is correct. And if statement is correct, its contra positive will also be correct. Okay. Next is, given the knowledge base, if P implies there exists some x q of x, is this correct or not? P implies there exists a x such that q of x, whether this is correct or not. Let's see. So first point is correct. First point is correct, which is P implies there exists a x such that P of x. This is correct. If this is correct, in that case there should exist at least one x. Let's assume A. There exists at least one x such that P, capital P of A is true. Such that capital P of A is true. Why? Because of the first point. And if this is true, then second point says for all x, Px implies Qx. For all x, Px implies Qx. So if this holds, in that case, Pa implies Qa. Therefore, Qa is also true. Why? Because the x that we are considering in first point should also be there in second point, right? Because second is saying that for all x's, for every x, Px implies Qx, which is correct. Okay. So then this argument P implies there exists a x, which is A. There exists a x, yes, there exists, which is A. X is equal to A. Q of A is true. So therefore P implies there exists a x such that Q of x, which is true. Okay. B is also correct. B is also correct. Next one says, if the knowledge base is true, is my R implies P is correct? Answer is no, it is not. Why? Because the inverse is correct. If a statement is correct, its inverse need not be correct. P implies R is true, but it doesn't implies that R implies P would also be true. It's the inverse of the initial statement. And you can have a counter example for this. So C is incorrect. You can have a counter example for option C. You take P, a specific D as false, Q of D as false, small p as false, and small r as true. So this will make sure that knowledge base is true, this counter example, but the given scenario R implies P would be false. True implies false, it is not correct, it is false. Okay. All right, and similarly we can have a counter example. This is also incorrect. Why? Because P implies there exist, because the inverse is true. If the inverse is true, if the inverse of a specific predicate is true, in that case it doesn't mean that the original statement is also true. And similarly you can have a counter example. For this, if you want to prove it logically, you can use this counter example. Q of D is true P of D is false, small p is false, and small r is also small r is true. Okay, you can use this to invalidate the fourth option. So A and B are right, and logically also, if you see that P implies R is correct, in that case R implies P need not be correct, right? And same holds for option 2 and 4. They are opposite of each other, inverse of each other. Next one. So this problem is also not that difficult, little bit calculations, but considering the Bayesian network of binary random variables, and the Bayesian network is given, which is from C. The Bayesian network is from C. We have two nodes R and S, and from R and S you have W. Okay, so there are calculations involved in this problem, but it is not that difficult. Okay, and all the conditional probabilities are given to you. We need to find C, the probability when C is 1 and the evidence is W as 1 and S as 1. We need to find probability of C. Let me write it here. We need to find probability when C is 1 given the evidence W as 1 and S as 1. And for any such scenarios, you can compute it like this: P of all variables C, W, S and R. This is if you expand the conditional probability, it is P of C, W, S divided by P of W and S. This is what it is, right? This is what it is. So if I am able to find these two probabilities, I can just divide it and get the value. But it is not that simple. We have to apply the Bayes theorem in this. But the idea is to first calculate this. Idea is to first calculate the marginal probability. The marginal probability of all variables having, and if the Bayesian network is already given, it is not that difficult to form it. If you see probability of C, W, S and R, what it will be? We can use the Markov blanket in order to get the desired conditional probability, not conditional, desired probability, which is P of C times probability R, condition on the parent C, then probability S given C times probability W given S and R. Yes or no? I can write it like this. Any confusion in this? Given the Bayesian network, I can write the marginal probability as this. Any confusion in this? Any confusion in this? Okay. After this, if this is true, in that case, after this point, it's all about calculations and all. Okay. So if this factorization, the Bayesian network factorization is correct, let me move it. over here. If the Bayesian network factorization is correct, I can use this in order to find probability of C, W and S by taking sum over R, right? Because R is independent. So we need to have summation over R in order to get C, W and S, in order to get the marginal of C, W and S. This is what we'll do. So probability P of C, W and S, it will be sum over R, and it can belong 0 or 1 because all are binary variables. P of C, W, S and R. This is how we will evaluate, and I can replace it with this. If this is the case, summation over small r, probability of C times probability of R given C times probability of S given C times probability of W given S and R, out of which this is independent of R, this is independent of R, can be taken out left hand side. This is probability of C times probability of S given C times then summation over R, P of R given C times P of W given S and R. Is it clear? I can write it like this because I need to dissolve R. For that I need to take all possible combinations that this small r can take, and since it's a binary variable, it can either be 0 or it can be 1. Based on that, this is my probability. This is my conditional probability. Can I solve it now? Because all the other things are already given. We are trying to find this P for C as 1 and the evidence W as 1 and S is also 1. So we can use these conditional probability tables in order to get the desired probability. Okay, and if I take only the summation part, this is already known to me, this is also already known to me, I can directly use it from the table. The third part is what I need to evaluate. So let it be, say, T. So we can calculate the value of T as T is sum over R. R can be 0 or 1. T is sum over R. R can be 0 or 1. C is already defined, W and S are already defined. For this case, C is 1, W and S are evidences, both are 1. We just need to we take combinations of R and then put the values to get the value of small t. Okay, so it will be probability. First take, let's R as 0. R0 given C times probability C as 1, let me directly put the times probability W as 1 given S is also 1 and R is 0. This is the first case, plus probability R1 given C as 1 times probability W as 1 given S as 1 and R as 1. This is what the small t will be. This is summation over R is 0 or R is 1. There can be only two scenarios. It's a binary variable, binary random variable. Okay, for that, probability of R0 given C as 1, it's 1 minus 3 by 5. It's 1 minus 3 by 5. So it will be 2 by 5 times probability when W is 1, from W as 1 given S as 1 and R is 0. S as 1 and R is 0, 1 by 2. It's 1 by 2 plus the next two terms R as 1 and C as 1. R1 C1 3 by 5 times 1 by 2 probability W as 1, S and R both as 1, 9 by 10. If you calculate, it will be equal to 37 by 50. It will be equal to 37 by 50. So now if T is fine, in that case we just need to take T, multiply it with probability when C is 1, multiply it by probability when S is 1 and C is 1. That's it. It will give me this value. It will give me this when probability when C is 1. Okay, so just take and put it over here. This will give me P of C is 1, which is 1 by 2, which is 1 by 2. It's 1 by 2 times probability S given C. Probability S given C. S is 1, 2 by 5 times 37 by 50 by 37 by 50, which is equal to, if you calculate, it will be 37 by 250. 37 by 250. 37 by 250. Okay. And here exactly like similarly how we have calculated when C is 1, we need to calculate one more instance when C is 0, W is 1 and S is 1. Keeping the evidences same, we need to compute the joint probability of this while C is 0, and then we will apply the Bayes theorem. We will normalize that. So therefore this value would be probability when C is 1, let's call it phi as 1 divided by phi as 1 plus phi as 0. This is what the Bayes theorem is. Similar to this, we will calculate C as 0, W as 1, because evidence will be the same for both the cases. And if you divide it by the normalized form, this will cancel out. This is the constant. Since evidence is given, P of W and S is a constant. So we have to apply Bayes theorem after that. Okay. So how you will calculate? It is exactly same. Just give me a second. This is T when C is 1. We will calculate another T when C is 0. What it will be? It will be same probability of R 0 given C as 0 times probability W as 1 given S as 1 and R as 0 plus probability of R as 1 given C as 0 plus times probability W as 1, it's an evidence given S as 1 and R as 1. Similar way, just the values will be changed. R0 given C0, where is that? R1 C0, it's 4 by 5, 1 minus 1 by 5, we'll use 4 by 5 times W as 1 given S as 1 and R as 0, 1 by 2 plus R1 C0, R1 C0 is 1 by 5 times W1 SR1, 9 by 10. If you calculate, this will come out as 58 by 250. And once it is evaluated, you have to put it over there with C as 0 and evaluate the value of phi of 0. This is my phi of 1. This is my phi of 1. So I can use this to evaluate phi of 0. It will be probability of C when it is 0. P of C when it is 0, 1 by 2 times probability S given C. S is 1, C is 0. S is 1, C is 0, this 4 by 5 times the one which we have evaluated, 58 by 250, which is in fact equal to, this will be equal to so this is equal to 58 by 120. This is 58 by 250. This T is 37 by 90, 29 by 50. This is 29 by 50. This is 29 by 50. That's it. This is 29 by 50. Okay. So once you have phi 0, put it over here and calculate the answer. It's 37 by 37 plus 58 by 58, which is 37 by 95. And GCD is 1 for these two cases. This is A, this is B. You need to give A plus B. This becomes 37 plus 95, which is 132. 132 is the right answer for this. Clear? A typical problem on Bayesian network where the conditional probabilities are given and you need to find the specific scenario when C is 1 and evidence is given. Okay? Any confusion in this? So you can expect a similar sort of problem, much smaller one. You can simplify the values, but the overall idea is like this. You have to deal with similar problems in this manner where CPTs are given and a specific scenario of probability is asked. Right? So next one is also little bit similar but a small twist. This is also like we have a Bayesian network with three variables A to B and then A to C, and conditional probabilities are given, much simpler compared to the last one. Evidence is given B as 1. We Gibbs sample over A and C in order A then C. This is a problem on Gibbs sampling. We will keep on finding. Gibbs sampling is a technique in which we find the probability of a specific node having a specific value, right? We will keep on sample the data based on the given Bayesian network till n number of times. Basically this is what sampling is. You keep on sample it till like certain number of times, which gives you a confidence that the data is more or less accurate. Okay, so we will be sampling A and C in this order, A then C repeatedly. Initial state is A as 0 and C as 0. So we are starting with the starting state is A0, C0, and we have some random probabilities. These are the probabilities of sampling, whether after you sample the data, what are the chances the value of the sample that you have started with, in this instance when A is 0, will be changed. This is the probability. This is the probability. And how we will be changing? The update rule is if we will update the state to 1 if and only if these random numbers, these probabilities are less than or equal to the conditional probability when x is 1 given its Markov blanket. Given its Markov blanket. Basically it's a like a posterior. We need to find the posterior such that if it is greater than or equal to the given probabilities or the given chances, then only the variable is updated, otherwise not. This is the rule of updation in this Gibbs sampling criteria. Okay. Now the condition is we will be running 2 full sweeps A then C each time, and then we will find out how many times the value of A is incremented or the updated to 1. Either it can be 2 or 1, it can be other than that, because we are starting with A as 0. So for first sweep, either it can be updated to 1 based on what the probability is. If it is greater than or equal to U, which is the given probability is 70%, in that case it will get updated. If it is not, then it won't. Then we will wait for the second sweep. For second iteration, we will do the same sampling again and check whether for second pass my probability is greater than or equal to 0.1 or not. If it is not, in that case the answer will be 0. If it is 1, in that case the count will be the total number of updates from 0 to 1, or like update to 1, that's it. Clear? So in a nutshell, you need to calculate this probability and then compare it with the given probabilities so that you can decide whether to update a sample or not. Any confusion in this? And it is similar to the last problem that we have seen. We need to find the posterior given its Markov blanket. One is for A, second is for C. Okay. All right. So let's quickly go through the posterior. So P in this case, P of A, C, A, B and C. This will be given as probability of A times probability of C given A times probability of B given C given A. Right? This is what the the joint probability will be. So if this is the case, if this is the joint probability, we are interested in finding P when this capital X is A. We are interested in finding P when A is 1 given its Markov blanket, which is this only, that's it. P A of 1. We are interested in this probability. Okay. And again, even if we want to calculate P of A1, we need to go through this approach only. We need to have summation over B and C to identify what is the probability of A. Okay. So let's quickly see the starting point. So P of A, no, in this case it's the Markov blanket. So we need to calculate P when A is 1 given its Markov blanket, and for A its Markov blanket will be B and C both. For A it will be B and C both. Yeah, it will be B and C both. This is not a regular Bayesian network, it's the Markov blanket. If the condition was such that 1 given the Bayesian network's condition, in that case it will be independent of other nodes, but since it's Markov blanket, it will be, the conditional probability will be, it depends upon the children. Markov blanket is generally all nodes, children or parents. Okay, so we need to find this. In order to find this, we need to find this. So idea is to get this by the same technique that we did in the previous one, taking the joint probability distribution and apply summation, get rid of the variables for which we already know a specific state will be maintained. If not, in that case we will take all possible combinations. Okay, so starting with the scenario, this is what in the previous question it was similar. So overall we are interested in finding this. Which is, in a nutshell, it is P when A is 1. P when A is 1 times probability when B is 1 given A is 1. This is, I'm just using the above expression, above joint distribution to like write it down. B and A times probability when C is small c. It can be, it can change anything as for a specific, it is the general expression given A as 1 divided by, for both scenarios, for both A belongs to 0 and 1, into take both cases, P of A small a is equal to A times P of B as 1 given A as small a times probability C as small c given A as small a. Basically both cases when A is 0 and when A is 1, that's it. Okay, and this is also simplified since it's given that we only need, the evidence is given as 1, and it is also known that for the first sweep the value of capital C is 0. So in fact we only need C as 0 scenario, that's it. That's why it is a constant. Okay, so what should be the next step? Let's quickly see. We need to evaluate both the cases when C is 0. So B as 1, C as 1, right? No, C is 0, B as 1 given that evidence is 1, and for first sweep C is 0. This is given for first sweep. Okay, so now just it's like seeing the value and putting it in this formula to get the probability. So the probability will be probability when C is 0 and A is 1, probability when C is 0 and A is 1, 2 by 3, 1 minus 2 by 3. Probability when A is 1 is 1 by 4, so it's 1 by 4 times probability when C is 0 and A is 1. C0 A1 is 1 by 3. This is the third multiplier. Second is B is 1, A is 1. B is 1, A is 1, 3 by 4. 3 by 4 divided by the same 1 by 4 times 3 by 4 times 1 by 3 plus the second case when A becomes 0. When A becomes 0, the probabilities will be, probability of A becomes 0 is 3 by 4. 3 by 4 times probability C is 0 given A as 0. Probability of C is 0, A is 0, 1 minus 1 by 6, 5 by 6 times probability B is 1, A is 0. B1, A 0, 1 by 4. That's it. This is what basically we have applied the Bayes theorem over this. So finally it will be this 2 would be here. So 3 times 2 divided by 5 times 3, 15 plus 3 times 2, 6. 6 upon 3 can also be cancelled out, 2, 5. It's 2 divided by 2 plus 5, 7. It will be 2 by 7. 2 by 7 is the probability. 2 by 7 is the conditional probability when A is 1 given its Markov blanket. 2 by 7 is the conditional probability, and it is equal to approximately 0.2857. It is equal to 0.2857. Okay. Now the next thing is, if it is greater than or equal to U, which is 0.7, in that case A will get updated from 0 to 1. This is what the update rule is. So the next thing is, we will be checking for first sweep, is my probability, is my P A as 1 given its Markov blanket of A is greater than or equal to 0.7. Is it greater than or equal to 0.7? The answer is no. 2 by 7 is not greater than or equal to 0.7. So A, in first sweep, A will not update. A will be 0, or we won't be updating A. We won't be updating A. Correct? Next is, we have to similarly calculate the posterior when C is 0. Posterior when C is not C is 0, C is S1, given its Markov blanket, given its Markov, it involves only A, given A. We need to calculate this. PC given A, and the easy thing over here is A is already given as 0 because it's the first sweep. The next is to calculate P of C is equal to 1 given A, and A is also 0 only, so it's not difficult, it's straightforward. How will you calculate? It is already given. P of C is A, given A is 0, it's 1 by 6. Nothing to do for A, it's 1 by 6. And we need to check whether 1 by 6 is greater than or equal to 0.5 or not. Answer is no, it is not. So C will also not update it. This is not greater than or equal to 0.5. So C will also be same. Will be 0. In first pass, none of them will get updated. So the counter which we are talking about in this problem will remain 0 after the first sweep. Okay. Now for second sweep, if nothing is changing in the first sweep, A is 0, C is 0. So all the calculation will remain the same. Just we need to compare these posteriors with the second pass probabilities, which is 0.1 and 0.9. Okay. So for second pass, let me write it here. For second pass, second sweep, the probability, this probability will remain the same, which is 2 by 7, approximately equal to 0.2857. At this point, it is increasing 0.1. It is greater than or equal to 0.1. It is greater than or equal to the second pass probability. Therefore, it will update A. A becomes 1. And if A is updating, the criteria is we want to sample A and C in this order, A then C. The next we will do is we will sample, we will find the probability of C in order to check whether we need to update C or not. The only difference in this case is we will be finding probability C as 1 given A is 1. Why? Because A is already updated in second sweep. So therefore for C, probability C as 1 given A is also 1, and this is also given from CPT, 2 by 3 is 2 by 3, which is 0.66. Is 0.66 greater than 0.9? Answer is no. So C will be the same. C will be the same. So C will be 0 only. Okay. So the only additional thing that add up to the final counter will be updating A from 0 to 1 in the second sweep. So therefore n becomes 1. N becomes 1. We need to find how many times A is updating to 1. Clear? It is how many times A is updating to 1. That's it. So it's 1. Okay. All right. So that's all. I guess this was the last problem from Gibbs sampling. So let's have a short break. Then we'll discuss the remaining set of problems, remaining set of 7 problems from DBMS and warehousing. All right. So yeah, let's have the final set of 7 questions. Let's go through quickly them. Let's go through them quickly. So DBMS and warehousing have 7 questions, 4 from DBMS and 3 from warehousing. 5 2-mark question and 2 1-mark question. Total weightage around 12. So you can see, like, you can expect approximate weightage of 10 to 12 from this subject as well. Why? Because it has 2 components, warehousing and DBMS. DBMS, we already know we have a quite strong question bank from DBMS alone that gives us a very strong foundation of an idea that how questions might be. But from warehousing, we do not have, nor we have the resources, like neither we have the resources nor we have a strong question bank to have an idea of the problem set, because this time they have asked a OLAP query from warehousing, which was a good problem. So if you do not know, you won't be able to do it. That's it. So we have one question just to brush up the overall OLAP operations that we can perform on these data cubes. So the last problem is on that only. So that will be a major highlight from warehousing. Apart from that, problems are not that difficult. Starting from the first one, which is some like functional dependencies are given to you. We need to find the total number of super keys. You've seen a similar problem in GDMT-1, which is we need to find the total number of keys present. In this, we need to find total number of super keys. Idea is same. Super keys are, you can take supersets of the existing keys. That's it. Okay, for that we need to find first all the keys in this. Once we find all the keys, we can easily identify total number of super keys present. Dependencies are A to B, C D to E, and E to A. E to A. So if you try to find the canonical covers of A, it will be only A and B. That's it. A, B. For B, it will be B itself. It will be B itself. From B you can't go to anywhere. A to B, C, D, E, E to A. And from C, only C. From D, only D. You can't go to any other column. And finally from E, it's E, A, and B. From E we can have. This is the total number of keys which are present. Okay. So out of this, like, none of the final key will be present in this sort of relation that depends upon only a single column. We have just now seen that if you have only a single column A, B, C, D or E, you can't go to the remaining columns or the set of all possible columns. So no super key or no key will be having a single column, right? So if this is the case, we need to find the combinations. So like if you see all these functional dependencies closely, if you have C, like none of the column like C and D can't be reached using any of the functional dependencies. So C and D should always be present in the key. Why? Because there is no functional dependency that is going towards either C or D. So for a key, C and D are must. If C and D are present, so just we need to check whether it is covering all the columns or not. If C and D are present, you have C, you have D. From this you can reach E. If you have E, we can go to A. If we have A, we can go to B. So this is correct. A and B. So this is a valid key, valid minimal key. CD. Okay. And any all possible combination of super key in this relation should involve C and D. Why? Because none of the functional dependencies will give you C or D. So C and D are must. So if a key contains C and D, in that case, C and D are like independently sufficient enough to get all the columns. So any additional column in this will be just a scenario of total, like of counting total super keys possible. Okay, so only one key, which is C and D. Apart from that, for the remaining columns A, B or E, either you can have it or you can't, it won't impact. All of them will be super key. So total number of super keys would be C and D are must, C and D are must, plus you can have any combination of remaining columns, because it is not, it won't depend on these columns since C and D are sufficient. So you can take A, B, C, a set having all possible combinations. So 2C1, 2C1, 2C1. So 2 to the power 3 is 8. 2 to the power 3. You can have all possible combinations. You can count total 8 super keys will be there. All of them should include CD, because none of the functional dependencies will give you C or D. But if you have CD, you can give, like you can get to all the columns. Clear? Is it clear? And like it is only 8, you can count as well. Like either you include A or not, you include B or not, or you include C or not. Okay, answer is 8. Easy only once you know how to find the keys, you can count the total number of super keys. This is also not a difficult problem, and you can aggregate some of the records just before starting with the complex looking query over here. We need to give the total number of rows returned from this query based on this snapshot or this instance of the data. Okay, so it's a count from this table where amount is greater than or equal to some condition will condition 1, and there is one more condition, and this is a bit simpler condition. This condition is and t1 dot account id is not in the subquery, the IDs that are returned with this subquery, which is returning the IDs of the rows having amount less than 600, so this is less than 600, and this is less than 600, this is less than 600. 3 rows having amount less than 600. So we can identify the IDs 10, 14, not 14, 15 and 20. What it says, the query is some subquery and ID should not be present between 10, 15 or 20. ID should not be present between 10, 15 or 20. Okay. So we need to reject all the rows having these IDs. So straight away, this is rejected. This is rejected because ID is 10. It won't be included in the second where clause. 15 is rejected and 20 is also rejected. That's it. This is the filter based on the second where clause, the second condition after AND, because there is an AND in between. Both should be true. So ID should not include either 10 or 15 or 20. Why? Because amount is less than 600. If amount is less than 600, this subquery will return the ID of those records. And the final query, the parent query, should exclude these IDs. Correct? This is the first filter. Now, once this is done, let's go to the the first subquery, which says select the maximum amount. Select the maximum amount. There is a maximum function from the table where t2.city is equal to t1.city. We need to select the maximum amount in a similar city with different ID. This is for differentiation. ID should be different, but city should be same. IDs should be different, but cities should be same. For instance, if you see Delhi, for Delhi you have this record, and third last record. For these 3 rows, all 3 rows will be considered because city is same and IDs should be different. 11, 17 and 19, all are different. So what we will do, we will take the maximum amount. The maximum amount will be taken, which is 1600. 1600 is the maximum amount, and that amount is returned. It will return 1600. So what it will return? It will return the 1600. Then for the second set of for the second city, which is Mumbai, and Mumbai, the maximum will be returned, which is 15. Yeah, 15. This will it will return 1500. 1500. And third for Pune. For Pune, 600, 1100, 900. That's it. 1100 is returned. 1100 is returned. Okay. So the columns that, like, the rows are highlighted is this T08, T13, and T04. These three. Okay, these threes are returned, and finally we need to count the total number of rows returned for this table if the amount is greater than or equal to the maximum amount, which is these 3 rows only. Not greater than, but it will be equal to 1500, 1600, and this 1100. That's it. These 3. It will be 3. C. It will be 3. Okay. So you just have to simplify the query, and it might look scary, but it is not. The second subquery is very easy. The first subquery is also not that difficult, but like, you need to know this specific clause, this specific filter, where the filter is city should be same but ID should be different. Same city but different sales. Okay. Any question in this? Any doubt? Go on to the next. Let's wind up quickly the remaining set of problems. Okay, this is also not that difficult. It's an MCQ. We have to match the corresponding rows of first column with the second column, and even if you read this logic with the corresponding relational algebra, you will be able to identify. For instance, if you just see the second one, S dot name, such that there S is a student and there exists, like, he has enrolled in a course with, like, a student ID, and he has also enrolled another course. Like, basically no two course IDs should be same. He has enrolled in 2 different courses. And this is what exactly the relational algebra for this is. It's a straight match. From 2 you can straight away match B. I am a student. I need a cross join such that the course IDs should be different. I have enrolled in more than one course having different IDs. That's it. So B is second is mapped to B. Now you can either see first or you can either see third. Both will give you the answer. Because if second is B, then these are terminated. 1A or 1C will get you the answer. Okay, so what one says? The one says that S is a student and there is an implication which says at least one enrollment and every enrollment in the student's own department, no cross department. There is an implication such that whatever the department of this specific student is, the course should be of that department. That's it. And if you read the first one, which is give me students such that the all enrollments minus enrollments of cross departments. So whatever courses the students has taken from different department are subtracted from here. This will automatically give the courses that a student has enrolled in within a department, right? So first is A, and similarly third also is not that difficult. You can have it, right? Okay. Next, a B plus tree is built on a file with these number of records. Block, like, some conditions are given. Some criteria for leaf nodes, some criteria for internal nodes. Assuming all nodes are completely full, find the minimum possible height of the B plus tree from root to leaf, including both. This is important. If you miss this including both, you will always give the total number of edges that come from the root node to the leaf. It is number of edges plus 1, right? So for that, you need to calculate total number of leaf nodes present and total number of internal nodes present based on how B plus tree stores the internal nodes and the leaf nodes. For that, for leaf nodes, the it's like purely calculation based. You have block, you have like in these nodes we have like metadata, some data which is we store some pointers, we store the remaining form of data, right? Starting from the first one, so usable bytes of leaf node. What are the bytes that we can allocate to store in the leaf node? Let's see that. The usable bytes will be, first of all, what is the total block size that we have? 4096. This is the total block size. Okay. If I subtract the metadata or the data that is compulsorily present in the nodes, I can calculate the total number of bytes which we can use, right? So we'll do exactly the same. So every leaf will have a metadata that we will subtract. Along with that metadata, we will also subtract. Yeah, additionally, each leaf stores one next pointer having 6 bytes. So leaf is like this now for a B plus tree. This pointer also will like take some storage of 6 bytes This will give us the total available data in a leaf node, which turns out to be 40. It's 64 and 6. If we subtract, it will be 4026. It is the usable data, right? And each leaf node will be having size 8 bytes, record pointer size, and key size is 12 bytes. Each leaf node will have a pointer and the node, the key is 12 bytes and pointer will take additional 8 bytes for that, like for that specific node. So it will be 12 plus 6, 12 plus 8, which is 20. This is the size of each leaf node. Okay. So based on these two, we can find the total number of maximum entries per leaf, which is like 4026 divided by 20, the lower bound, and it turns out to be 201. Maximum entries per leaf would be 201. Okay. And similarly, if we know the maximum entries per leaf, we can find the total number of leaves required. Total number of leaves we need in order to store these 201 entries, which is the total record, divided by 201 seal. Correct? This will give us total number of leaves. So we calculate it, it turns out to be 248. It's like pure calculation only, no logic involved. Once you know how B plus trees stores leaf and the internal nodes. Okay, so these number of leaves we need. Okay, all right. Now the second part of the problem, which is the fan out of internal node. For internal node, we need to see what things we need to, like what are the things we need to store in internal node in order to get the numbers. Okay, so for that, like if it's an internal node in a B plus tree, it will have p pointers. If we have p pointers, in internal nodes, in that case it will have p minus 1 keys. The keys are always one less than the total number of pointers present in the internal nodes. Right? So if this is the case, then the fan out for internal nodes will be 64, which is the per node metadata. Metadata is same for internal node or the leaf node. Plus you have 6 bytes, like additionally each child pointer size is 6 byte. So if we have p pointers and each p pointer will be taking 6 bytes, we need additional 6p space, right? And if we have p bytes, in that case the p child pointers will have p minus 1 keys. So we also need to incur the size of key. Total p minus 1 keys, and one key is taking 12 bytes. Key size is 12 bytes. It's times 12. Yeah. This should be less than equal to the block. This should be less than equal to 4096. So if you calculate it, it turns out to be p should be less than equal to 224. What is p? P is total number of pointers, total number of child pointers of an internal node. Okay. So I guess 224.66 if you calculate it. So p max would be 244. And based on total number of pointers an internal node has and the total number of leaf nodes, we can evaluate the maximum height. Okay. We can evaluate the maximum height. How? So if height is h, if the height is h, then maximum leaves, then maximum number of leaves would be total number of pointers present in the internal node p max to the power h minus 1, which is equal to 244 to the power h minus 1. Okay, so now it's just we need to put different values of h for 1, 2, 3 and see which just crosses this value, because these number of leaves are required in the B plus tree. Okay, and when you put HS2, if you put HS2, the maximum leaves will give you 244 3. Sorry, if you put HS3, it will give you 244 square, which is whose value is equal to 5176. But this is not sufficient. This is less than the total number of keys, that the total number of leaves that we want. So it is just one greater than that. So h should be at least 4. Not at least, at max 4, maximum height. H should be at max 4. If h is 4, then maximum leaves will cross the total number of leaves that we have, which is correct. At least it is not less than. So the total number of leaves that we want to put in that B plus tree will be, like, we can sufficiently put it. We have like a space. We have total pointers greater than that. Right? So therefore it's 4. Therefore it's 4. All right. Then this is easy only. This is like a normalization, the problem on normalization. The data involves 3 dimensions and a pre-processing pipeline is given to you. A pre-processing pipeline is given to you. First step is to log transform only the third attribute. Okay. If you take log, you just need to replace z component of all these data points with log z base 2. Second step is to perform min-max normalization from 0, 1 independently on each attribute. Okay, using minima and maxima from ABCD. And third is let the normalized points be A dash, B dash, C dash, D dash, and define D1 and D2. We need to find, basically we need to normalize it. First take log, then normalize, and then find the Euclidean distance of D1 and D2. That's it. We need to evaluate D1 by D2. So it's easy only. Let's see the values. So after taking log, after first step, the first step is to take logs. Updated A will be 2, 10, and log of 8 base 2, which is 3. Updated B would be 6, 14, log 32, which is 2 to the power 5, 5. C 10, 18, 128 is 2 to the power 7, 7, and D is 14, 22, 5 and 2 is 2 to the power 9, 7, 8, yeah, 9, 9. It will be ABCD after the first step. After you perform log transformation, the second step is to perform normalization, the maximum normalization. Second step is to normalize, and by the normalization is, this is simple because the range is 0 to 1. If the range is changed from A comma B, in that case it becomes difficult. This is easy. So you have to normalize each point A, B, C and D based on these x's, these y's, these x, values of x, values of y and values of z. Okay, so for that, normalized point A dash, it's x, the current value, t minus t min divided by t max minus t min. That's it. This is like how we normalize. It's just a regular normalization of converting 2, 6, 10 and 11 in this range 0 to 1. That's it. Okay. For A dash, the x of A dash would be 2 minus minimum, which is 2 only. It becomes 0. Least will always become 0 and the maximum will always become 1. Then 10, 14, 18 and 22. Again it is least 0. 3, 5, 0. It will be 0. A dash will be 0. B dash will be 6 minus 2, which is 4, divided by maximum is 14. 14 minus 6, which is 8. 4 by 8. 1 by 2. It's 1 by 2. And I have the computed values of the normalized score. Not 1 by 2, it's 1 by 3. 1 by 3 and 1 by 3. Third is C dash. For C dash, it's 10 minus 2, which is 8, divided by 12. So it becomes 2 by 3. 2 by 3, 2 by 3 and 2 by 3. And finally, D dash is all ones. Yeah, this will be the values or the data points after step 2. Then step 3 is just you take it, calculate small d1 and small d2, the Euclidean distance of A and D and B and C. So d1 by d2 would be 1, 1, it's 1 only. Distance between A and D 1 and B and C we will evaluate. 2 by 3 minus 1 by 3. It's 3 times 1 by 3 whole square. 9. 3. It's 1 by root 3. It will come as root 3. You can evaluate. It will be root 3. A. It will be root 3. Okay. It won't be root 3, it will be 3. See, we just need to evaluate the Euclidean distance and divide it, d1 by d2. d1 is fine, it will be A, D, B and C. Yeah, A, D. Correct, it will be root 3 by 1 by root 3. So it becomes 3. Yeah, this becomes root 3 and this will be 1 by root 3. Okay. All right. Now this is a bit time consuming problem on a certain scenarios given. Like we have I've given a very detailed explanation of this problem in the solution. So you can go ahead and check from the solution set. It's like sort of a problem in which you need to go into the theory in order to identify whether these options making sense or not based on all the information present in the question. Okay, to go through like a very detailed solution is given in the result. Go through from the solution set, and it is not that difficult. Just you will understand. The last, this is important when it comes to like OLAP operations on these data cubes or the data. This is important, and it covers like almost all the operations, like major operations that we can perform on the data. Okay, so have it like first of all, I need to explain it like thoroughly without like jumping on the solution. It is just a snapshot of data is given to you, and certain label and a corresponding query is given, and what is asked in the problem is whether this label, which is slice, is correctly denoting what the operation is performed by this query. So whether it's a valid slice operation, whether it is a valid dice operation, whether it is a valid roll up operation, drill down operation, pivot or rotate operation, or drill cross operation. If the correct label is mentioned beside the query, then you have to increment 1 to the solution or the final integer answer, or else leave it. The total valid label query pair you need to identify. But for that, you need to know all these operations. So a small, like a small guide or a lookup so that you do not like miss these operations. So slice is, if you go through the name, slice is just you have different columns. Slicing is just cut out a specific pie from the data. This is what slicing is. Slicing is you, like when it comes to having a data cube, if this is the data cube, if this is the data cube, slicing is just cutting out a specific slice from the entire data cube, or you need to you can slice it, slice the data across a specific dimension. You can slice the data across a specific dimension, or from like a row. It can be either a specific row or a specific column. It can be anything. This is what the slice operation is. Okay. So generally, if you see the regular queries, slice or cutting out the data, cutting out a slice from the entire data, it can be implemented using a where clause, where the dimension is having a specific value or a set of values. This is generally a slice operation is. Okay. The second is dice operation. Whenever you see a dice operation, and in the query, if you see that a clause is like this, where dimension in, whenever you see an in clause, a certain values, then generally it is a dice operation. Okay. It is dice is just an extension of slice. Rather than having a specific dimensional data, you are getting the data in various dimension or from these set of dimensions. So you can aggregate multiple slice operations in order to get a dice operation. You are not chopping off from a specific dimension, you are aggregating multiple dimension or clubbing different chops or slices in order to get a dice operation. Okay. All right. Then roll up. If you see this operation roll up, if you see the roll up operation, you can straight away, like we have discussed the detailed query in GDMT-1, but on a broader perspective, giving you an overview, whenever you see a roll up, you can associate the roll up with the group by clause. And like when it comes to specifically discussing about roll up from OLAP queries perspective, this roll up and cube both can be like implemented using group bys by taking the columns in a specific order, by aggregating on the columns in specific order, or by choosing the subsets in a specified order. If you have 3 columns A, B and C, both roll up and cube will take certain subsets, like cube will take all subsets, but this will take only few subsets, not all the subsets. Few subsets of A, B, and of this set. But either of the both operation rollup and cube can be implemented using group by clauses. By grouping, by deliberately grouping over these combinations that we want either in rollup or in cube. Okay, so you can associate these operations. Second, drill down. Next is the drill down operation. Drill down is basically getting into the granularity of the data. For instance, if you, for this case, you have a quarter. Drilling down is from quarter, you are getting the data of months. From months, you are getting the data of, say, weeks. You are increasing the granularity of data, or in short, you are increasing the records, the total number of records. If you have the data for quarters, can you get the data of months or of weeks? You are increasing the granularity. So drill down operation will increase the total number of records returned compared to the original data, because you are increasing the granularity. You are going down the hierarchy in order to get more number of records. Okay, so this is what drill down operation is. Then it's pivot or rotate. It is also an interesting operation. Rotate or pivot operation says, so based on these rows, can you rotate the data such that a row becomes a column? Row becomes your column, or vice versa, column becomes row. It's a rotation operation. You take the data and rotate it such that a specific row will become a column. And you can have multiple instances of these scenarios, or vice versa. This is what a rotate or pivot operation is. So if you see a query which is rotating the data or converting or making conversion in this manner, it will be a pivot operation. And finally, drill across. Drill across operation. So drill across is basically a combination of drill down and drill up. So like if you have a data cube, if you have a data cube and you apply conditions, either like you combine the conditions of drill up and drill down operation, in such a way that it can't be called a drill down operation, or it cannot be called a drill up operation. In that case, it will be drill across operation. You're going across the data cube in order to get certain set of data. This is what drill across is. It is basically a combination from different facts. All right, so this is the overall common operations that you can perform on these data cubes, right? Then when it comes to the question, first is slice. It is correct. We are specifically extracting the data for a specific quarter. We are slicing the data. Slice is fine. Then next, dice. Correct. We are including multiple categories. This is a valid dice operation. Clubbing various slices together. Then third is roll up operation. It is also correct. We are using some sort of a group by mechanism, so it can be considered as a roll up operation. Fourth is drill down. This is incorrect. This is a slicing operation that we are making on category. This is restricting the data. We are not increasing the number of rows in this. So this is incorrect. It's not a valid drill down. Fifth is pivot. Select these and this, where when category, then this is a valid pivot. This will change the dimension of your data. This will rotate the data. Okay. And finally, drill across. This is not drill across. It is you are applying a join on it's just a simple join. So this is also Not correct. This is incorrect. So total matches are 4, which is the right answer for this problem. Okay. All right. That's it. That's it from the discussion perspective. And after the discussion, soon we will like release the results and the correct solution sheet of this test. So congratulations again to the toppers. Okay. And we have the next test on 1st of Feb. This test will be gate level test, not very basic, not very difficult like what we have seen in this test. It will be a combination of GDMT-1 and GDMT-2, which like perfectly mocks the final gate exam on 15th. Okay. All right. So that's all in this discussion. Hope you enjoyed it. See you in the next slide.